All right. Well, this is going to be even more fun second day, especially because you're signing up your friends to talk. Um, but yeah, no, we is it? But
It should be extended, but not today.
okay. So okay, there you go. It's good, and you have the mic. And yeah, welcome everyone, and also let's welcome Rui Hang to talk about Rust and Prometheus. Yeah.
Thank you. I'm honored to be first in the second day. And my talk today is about engaging Prometheus in the Rust ecosystem, another language. So first, a few introduction about me. I'm currently a software engineer at GripTime, which is another database startup. Yeah. And I'm also a Apache Data Fusion PMC member and Arrow committer. So today's talk, I will also include much of them. And this is my GitHub ID. I noticed that some talkers yesterday have a unified theme and template, but I haven't noticed that. So this is not no Prometheus orange color here. And yeah, this is my first time being in Europe. I'm not used to put my own selfish on the slide, so you can see me in visual eyes. Okay, today I will bring this topic in about three major parts. Like first, why we take this, why we bring Rust to Prometheus or bring Prometheus to Rust. And second, what does this kind of action means to me or to our company, to the entire community. And the third is how we achieve this. I will provide two examples with two totally different ways. And before we start, let's give you some content warning. First, this is about talking about Rust in a Go-centric project. I'm not that kind of guy who yelling off using Rust to rewrite everything. No. I do my day job with Rust, but I'm not that kind of guy. And second, I got some cough, so. And the third, I will do some comparison, but some of my code is on one side, so there would be expected biases. But I would try my best to make them balanced. And the fourth is broken English, not very fluent. Okay, let's get started with a quick fact check. In the introduction I put on the website, I said 19% of the projects are written in Go. But I realized I haven't done any formal investigation, so I replaced it with most of. But I think that this state still stands. That if you work using Go, I believe most of you are written in Go. If you are involved with Prometheus, you are mostly limited to exporting metrics only in the SDKs to report data to Prometheus, not leverage your data with your system. And to validate this, I found a picture. That this is from the compellence test, which is provided by Prom Labs, I think. Yes, but this picture is pretty old. About 3 years ago, they haven't updated. Yes, all of them are written in Go. Some of these are, like the first one is hosted by another cloud service, and some of them are speaking Prometheus languages or just on top of Prometheus, like M3, and yes, all of them are in Go. And then I found a GitHub map, which is a project that shows which other projects are related to one specific project. In the center, it might not be that clear, but in the center is Prometheus itself. And around them, we can see many familiar projects like Victoria Matrix, like, oh, I can't see it. Like some Grafana repos. So at current, today, we have a strong and better tested stack around Prometheus, start from Prometheus itself, and Mimir Cortex, and then Sanos, the distributed solution for Prometheus, and M3DB, I think is an enterprise solution, and Mimir, and then lots of cloud provider hosted Prometheus in their cloud, like Amazon or Google. Yes, but I think the innovation, so any kind of innovations, like either you innovate or develop new things in the Prometheus itself, as we have heard a lot in the yesterday, I think the innovation itself should be easier to happen if you can get your hand on quickly, without you, for example, to have set up another set project or scaffold for around 1 month or like this. So in the other side, this means it is harder for other projects or other communities to get involved with Prometheus deeply beyond their only client labs. Yeah. And the first thing is about integrations. We know Go provide a SQL system that can allows you to integrate other kind of native language like Rust, like C++ into Go. I have done around 1 year of my job to trying to replace the underlying storage engine of Prometheus to another key value storage engine written in Rust. And I think that's one of the best choices I have ever made. Yeah, it take me a lot of time, but I think about 70% of the time is not spending on the project itself. It's about like negotiating about Go and Rust, the SQL Ruby pen. So we decided to do some change, and where we bring Prometheus into Rust. This is the most intuitive thing is about you can do some more deeper Prometheus hack in Rust and in maybe another project other than Rust or Go. Because if you have some scaffold already built, so you can first you can exploring other language features. It can help to put some buzzword like memory safety, the ownership when we talk about why Rust, but not here. Go has some strengths, features like Go routines or some things, and you can also exploring other things from other languages if you can written in them. And also this also unlock you or unlock the entire community a very different ecosystem or ecosystems. For example, you can use some good libraries in Rust or even in C++. You have noticed that I have mentioned a lot of the third languages about C++, and I will let you know why. And also you can using some cutting edge infrastructure. I will show you, like for example, here is a comparison of talking about using Packet, the Apache Packet file format, compare them in Rust and in Go, the feature set comparison. I know the second topic is about leveraging Packet in Rust, in Prometheus ecosystem. So from this, we can see most of them are very similar. Only a little difference, but there is a difference. There is a gap. The third column is about using Prometheus, using Packet in Go, what you can get, and the fourth column is about what you can get in Rust. And about this, the left corner project, the left corner screenshot is about how you can using advantages and just innovated. The date is very close. It's July, yes. How you use embedded index in Packet format. You know, if you are familiar with Packet formats, you know this is not a part of them about the indexes, but you can now use it in Packet format to do some hack from the spec. This is only currently only exclusively available in Rust because it comes from the diffusion community, so which is basically on Rust. And Packet is about a metro format, and we still have many other cutting-edge innovations or cutting-edge fundings. This is another table for comparison. You may notice the columns, no official Go SDK. I have to say that I don't mean to find a lot of file formats that's not available in Go. Actually, this comes from a list that our customer sent to me and asked, do you support them? And then I find it's a good list, and I do a lot more investigation to find the community in which language it was built and if it is available in Go. So except the first one, the kind of old format, Apache Oak, is from the Hadoop ecosystem. Except this, all of other cutting-edge languages or new file format are not available in Go. I believe this is only a temporary status, but this is also the fact. Like this is not too much surprise because, or maybe to yours, we would expect more innovations or more small projects or more labs happens in other native languages like Rust or like C++, other than Go. And yes, and all of them are about columnar, and I think this is suited for Prometheus. So for this, if we just jump the first jump out of Go ecosystem, we will find it's like a nuclear fission. If we unlock Rust, we can use the native bindings, the C bindings of Rust to bind them to other languages. Like, for example, PromQL parser, which is from its name, the parser of PromQL, it is written in Rust, and we provide some bindings, and the community help us to bind them to Python and Lua. Imagine that, have you ever think of written some plugin in your NGX layer with Lua script to intercept some PromQL query? This is not, I think this is not available in, or not feasible in if you are all in Go, but it's now is an option to help you, to let you read some Lua script to intercept some, to ingest some business logic into your queries or into your request. I'm not saying this is a good choice in some architecture, but for us to build a infrastructure architecture, it's always help if we have more choices. And the other side is about another project, OpenDL, which is, you can think it of a cloud storage client. It is originally from Rust, and it has binding to a lot of more languages. And they share the same core of Rust. So that is why I call it like a nuclear fission. So it's not only about Rust itself, but you can use the native bindings or some other technologies to bring your things to many other languages. But funny, we theoretically can do this with C Go, with Go the same, but I think I haven't found the example. So yes, by doing this, by like porting or rewrite some part of Prometheus into another languages, not limited to Rust, we, or at least me, are kind of thinking my perspective to Prometheus has changed from it is a monitoring system to I think it's more like or more close to a standard for me. It's not limited to a single implementation, but it defines a lot of interfaces. Like from the this is from a repo from Prometheus compliance test. It says the Prometheus defines the interface compliance in 3 aspects. The metrics, which I think is ingest, how you ingest the data, and PromQL, the query languages, and the remote write, like line protocol or protocol you send data. So to me, Prometheus is more like a standard we or many of others to follow and to provide another implementation. If there is a standard, you can exchange or replace the things underlying. And to my knowledge, Prometheus internally also has some standard for their internal interface. Like say, Prometheus allows you to extend your storage or extend the remote storage. The same thing, I think they are the same things. And by taking it as a standard without instead of single implementations, we can embracing broader technologies to explore freely, not limited to some single point. And yes, the standard itself is not limited or banned to a specific languages. But this is not the wild acknowledgement situation for now. But I hope it is. I hope it is in the future. And then the first case of how we Rust or how we provide a PromQL parser in Rust. In this case, we try our best to follow the Prometheus own implementations. Thanks to the Prometheus team, for about 5 years ago, they have shifted from a handwritten parser to a Yak-based generator parser. And this do save us a lot of time. We can reuse the same Yak definition. If we are not very familiar, Yak is another file format or another grammar define a programming language like PromQL. And some other things like, maybe not now, but some other previous programming languages are defined in Yak. So by reusing the Yak, or actually we have to do some little change to port them because Prometheus use Go Yak, I remember. It is not fully compatible with the original Yak. But the workload is kind of limited because most of things are reusable, and we can easily follow the new update from Prometheus from the standard because they will also have to change to their Yak. So we only need to bring this div to the Rust version of Yak and do a little change. And for the parser project, it's about two things, or its major APIs is about the first AST, the abstract syntax tree, defines how your PromQL query looks like to the computer. And the second is the generated pass logic. For example, how you pass the time range. Is it from Prometheus 3.0? I remember you can now optionally omit the second ACE from your time range. So there are two aspects. And the second, the logic is internally. So if we want to provide the parser to other languages from Rust, we only need to write some generated code to bring your ST definition to Rust, to C, to C++, to whatever you want. And during this rewritten, we know the Rust project, the Rust community doesn't have a one-to-one mapping about dependency to the goal. So it does take us maybe half of the time to choose the dependency carefully to make them as much compatible as we can achieve. And with this, out of the Prometheus, out of the goal, you can now do some analysis. Yeah. Okay. You can now do some analysis to your system. Okay, and the second is about re-implement it. the PromQL query language, query engine in Rust. And obviously, I learned from yesterday. So monitoring is about junk data. I have to make these states because only for junk data you will consider the retention, the downsampling. You always will not do the same things for your bank account, for your business data. So yes, it is junk data. And for junk data, we means there are less values. Or unit of data have less value. Or if you want to achieve the same value of other data, you have to store a much more large of volumes of your data. So yes. And to our knowledge, to maybe the development of software, we have acknowledged that one of the best way we think of handling junk data is do it in the data lake. Yes, data lake from the name is also stored junk data. Yeah, that is why we choose to re-implement PromQL in Rust, or what we gain from re-implementing it. We fully decompose the PromQL, like how this step works, how other step works, how they are binding together, and then we rebuild it from the ground up in a totally different form. So, for example, we remap the operations to SQL model. For example, binary operator to connect to matrix is now joined in the Rust version of PromQL. And range vector, which is essential to range function, is actually a slice of arrays or array of array. You can think it of a metric. And filter aggregation, they are very same from other SQL model, or we just use it from data fusion. So if there is a standard protocol, yes, there will be a variety of implementation. And if one thing sounds like Prometheus and looks like a Prometheus and use like Prometheus, then it is Prometheus. So we do things differently or totally differently. This is how some of our tech stack, we didn't choose our dependency based on their names, but they happen to all bring Apache. So the first about the storage layer, we choose Parquet columnar format for our file format, persistent file format. And Iceberg, we choose their index format Parfin as our index format, and we combine them with Parquet. And Data Fusion as our execution engine, previous remapping and reusable operations are directly taken from Data Fusion. And you can also do the similar things if you want to use, for example, DuckDB to write your own version of PromQL. You can, or at least for me, I have confidence to do this within 1 month. And Arrow is an in-memory format. It's not only used in our computation level, but also in our protocol level or our memory cache level. And OpenDL allows us to access many of different services. Okay. And here is the goal we have achieved by rewrite this. It's now the drop-in replacement to Prometheus, at least if you only use ingest and query for PromQL. And we have achieved around 100% compliance to the vanilla PromQL. If you remember the compliance test, we are the highest one except Prometheus itself, even higher than other things which dependent on the Prometheus itself. Yeah, and we are also absorb lots of SQL experience by doing this in SQL model. For example, we can do a query optimizer to rewrite some dump queries or to prevent some dump queries to protect your system. And we have also this is very mature technologies in SQL or in Postgres. you can analyze your queries like this. You can know how each steps takes their times, and also you can visualize it like per step in a very human readable visualization. And you also have out of the box theory support of how you do distributed query language, distributed query execution. And this is something I think is cool. It might not be that useful, but I think it is cool. You can stack your queries with PromQL and with SQL. You can see we use CTE, which is Common Table Expression, to stack our queries. The first, the matrix pointed by a thing is a PromQL, and then you follow a SQL to filter it, and then you follow another SQL to do count. You can, I know there are some strengths of PromQL that SQL can't express, and there are some strengths of SQL PromQL can't express. But for now, you can choose whatever you want to do, whatever you want to do. And if you know how we achieve this, you know this is very fundamental things and very intuitive things. We all shift our query logic to a centric intermediate representation, IR, the logic plan. And in this level, you cannot distinguish how this step from SQL or from PromQL. They are totally mixed together, so they can seamlessly cooperate with others. And let's jump to the last page. Yes, the rewritten is about catching the fundamental things, the protocol, the data, and the computation. And then we also can provide some extensible things by doing this. For example, optional extrapolate, which also mentioned in the yesterday, and strict mode. For example, Prometheus will not report error if your query something doesn't exist, but we can choose it to report things because this is more like a SQL failure. And rich types, have you ever wanted query things other than just float? What about duration? What about interval? What about date time? My home assistant, I have a macro radar in my home, and it will report if there are some human activities, which the data is represented in interval or multi-values. For example, the load 1, load 5, load 15. They are actually gathered from one thing, but they have to be displayed in different things and visualized to be computed in different things. But we can actually store them together physically. So to wrap up, yeah. Okay, so I won't read it out. Okay, thank you for joining me.
Thank you. I've always been waiting for the day somebody wakes up and says, let's rewrite Prometheus in Rust. And I'm happy that it's happening. It's actually quite exciting. We probably have time for one question. Who wants to ask a question? All right, no questions, I guess. Yeah. Oh, yeah. Where can we follow what you're doing?
For the parser, we have a dedicated repo for it, and you can also try to bend it to much other languages. And for the query, it is a standalone mode within GrabTime's repo. It does not have a dedicated repo, but the code itself is separated.
Cool. Thank you.
Thank you.
Yeah. And yeah. Next, we have something related. We kind of looked at how we can query Parquet files with Rust and PromQL. But now Jesus, Alan, and Michael are going to talk about storing our TSDB data in Parquet files at scale.
Nice. All right.
Are you looking for a seat? Okay, cool.
Give it a second.
See the slides up here. Right? If it shows up here, it will be behind you. But it doesn't. No. Okay. What's our backup? No, it's not good.
Wait, give it a second.
I don't have. I do have actually.
Do you need to change the display settings?
Yeah, you need to kind of like cast or change this.
I have no idea how to do that. Are you on i3? On? i3. Exponent. Okay.
Oh, okay. Let me bring the.
Bring the Mac man.
Yeah, it's time to bring in the MacBook.
Nice. Yes. Yeah, but this should work. What do I have to do here to put one on one side?
Then you extend it essentially. You have to extend it and do it. So,
Do you-
then 1 second. Yeah, so I can change, extend it,
Okay,
and then
Yes.
you
Yeah.
drag it into that. Yeah. Okay.
perfect. All right. All right. Maybe full screen.
Yeah.
Is
And,
that
1 second. You go. Yeah, you go here and then. Right.
all right?
Close enough. All right. Welcome again. Yeah.
All right. Can you hear me well?
Yes.
Yes. All right. Okay. Good morning, everyone. I'm very happy to be with you here today. We can finally share what we've been working on for the most part of the year by now, which is about introducing Parquet into the Prometheus ecosystem to see if we can handle long-term Prometheus data with it. But before all that, let's introduce ourselves. My name is Jesus Vázquez. I'm a senior software engineer at Grafana, and I am joined by Michael Hoffman, senior software engineer at Cloudflare, and Alan Protasio, senior software engineer at Amazon. What brought us here? Well, the three of us are maintainers of 3 different downstream projects of Prometheus, Cortex, Mimir, and Thanos. When I first joined the community, I remember watching a talk where they were sharing that Thanos was influencing Cortex with ideas and vice versa, and I'm happy that that continues to happen today. Throughout our experience running and maintaining clusters of these technologies, we've all experienced similar pains on the query path. More on that later. But perhaps the thing that inspired us to work on this and talk about this today here is this talk about Philip Petkowski, which did this awesome work at Shopify, where he modified Thanos queries to use Parquet. So that talk happened around November last year. And unfortunately, the code is not open source, but the contents of the talk were great. And we didn't know at the time, but we were all working on this separately. And in my case, it wasn't until March this year where I used one of the hackathon that we have at Grafana to kind of work on this a little bit. And I joined Grajo and a few others in the company to fork Prometheus and see where we could fit Parquet inside it. That same week, someone told me, I believe it was Gotham, that Cloudflare had open sourced a repository where they were trying to do a similar thing that Philip did. And so I immediately reached out to Michael, and I created this CNCF Slack channel, Prometheus Parquet Dev, and I went to sleep. And the day after, people from Red Hat, Reddit, and Amazon showed up on the channel. And that's when we met Alan, and he also said he was running a POC internally. So the next step was clear for us. We had to join forces, and we created Parquet Common, which is a library that exists in the Prometheus community organization. It passes 100% of the PromQL acceptance tests, So any sort of PromQL queries to run. The library is low level. It's meant to read and write Parquet files. But we thought it would be useful for people interacting with it to have like a queryable implementation, Prometheus interface. So you can just generate a set of cities and run a Prometheus query against them. So that's useful. Then all the downstream projects will have their own implementations. But yeah, this is good for the library. And other things it includes, it's able to generate Parquet files from a set of cities. And it can also convert TSDB blocks to what we call Parquet blocks. We've got great progress since April. We've got like 90% better, 80% faster, 90% less get range calls, 70% less memory usage, and 40% less allocations. But these are benchmarks against the library itself, not against Prometheus. So this is just how it's improved overall. Right, so why are we doing this? I'm pretty sure people in the room have experience running or using Mimir, Cortex, and Thanos, and perhaps others. But in the case of these three, you're probably familiar with the component store gateways, which has a lot of state. It's a stateful component. It has to pull the indexes of all the blocks to resolve the queries against long-term data. And over time, at certain scale, this component starts to get big disks, and these disks become expensive. And also, when you add a new pod to your replica set, it takes time. We have customers taking up to 15 minutes or half an hour to sync a single pod. So this also becomes an availability risk, because if the pod goes down, you lose access to query that part of the data. And to make up for that, you typically add more zones or over-provision the pods to make sure that this doesn't happen. So overall, it's an operational challenge to run, and you're typically bleeding a bit of money here. Another thing is that if we assume fixed retention, like 12 months, data is only increasing because people is instrumenting more and more. So these problems are not going away. If anything, they're getting worse. And then more motivation, we also wanted to, like we were thinking, we know the limits Prometheus has with high cardinality. So we were thinking if there is a format that perhaps can help us handle better cardinality, because the index grows a lot with high cardinality or high dimensionality, more labels, we will win in that front as well. And as we learned from the talks on OTEL, we know that the OTEL spec is still evolving with the resource attributes, with the entities model. We know that Prometheus has its issues with it. So perhaps if we had a more flexible storage. Of course, there's a lot of work to be done in the Prometheus itself, like what's a resource in Prometheus. There's no struct saying what it is. But if the storage was more flexible, I think it would be great. And last but not least, we also wanted to explore. We've seen in the ecosystem people playing with columnar store and getting good results. So we wanted to see for ourselves. So now I leave you with Michael. He will explain how the TSDB index works and what are the problems we see in the store gateways when we query long-term data.
Yeah, so is the microphone working? Yes? Okay, cool. Let's explore why we think that the TSDB index kind of gets into our way at times. And let's do that by working through an example select call from the select call for some vector matcher to the final materialized series set, while keeping track of the consecutive read operations that the time series DB index forces us into. So given some vector selector and assume for simplicity just one equal matcher, the first thing we have to do, and I don't count this as a read necessarily because that's highly amortized, we have to look up postings for it, and to know where those postings are stored in the index, we have to know the offset for the postings that match this particular equal matcher. I read that from the postings offset table by section. It's sorted. That's quick. That's nice. And perform my first read. I will read the postings list from the index. Postings list is the set of series IDs that correspond to series that match this equality matcher. So first read. I do that for all matchers. I intersect the series, the postings lists, and that leaves me, in this example at least, with one series with ID 23. That's great. I have all the series that match my query, but I cannot yet hand that to the query engine. I need to materialize time series data and labels still, so we're not yet done. The series IDs also function as offsets into the series table if I multiply them by 16. So I now know where to start reading data in the series table, but I kind of don't know yet where to end reading data. Right? I only have the offset where it starts, but it could be arbitrarily long. So the second read I need to do is read an integer at that offset to get to that. That tells me how much data I need to read subsequently to get all of the series data for this time series. I do that, that's my third read, and end up with all of the label key value pairs for that series and some chunk metadata. No chunks yet, only metadata. This chunk metadata contains chunk references, which again are offsets that I can follow into a chunk file to read the actual time series data that's stored there. But again, it doesn't tell me where to end reading. So I go to the offset, read an integer that tells me how much data to read next. And finally, I do one last read for that size at that offset, and I end up with sweet time series data. I mash it together with the labels and build a series set and return it to the query engine. So if I counted right, that's 5 consecutive read operations I need to do to get from vector selector to series set. That kind of works okay for Prometheus if I have local fast disks and a memory mapped index. It got us this far. Prometheus works well. But as soon as I try to do the same thing on object storage, things get less nice, because object storage generally, I would say, has a pretty high time to first byte, at least compared to disks, and okay throughput. But we're not using any of the strengths, and we're paying for all of the weaknesses here. These happened before edges that the index forces us into, makes us pay the time to first byte that's relatively high sequentially, which is not great. And the time series database index stores data ordered in classic series order, lexicographically by its labels. But that's not necessarily how I want to read the data, right? Maybe consider being Cloudflare and you operate a federated Prometheus that pulls data from all of our edge network, disambiguated by like data center ID and maybe a region label. And now if I want to query that, let's say application CPU usage, there might be an application name label that lexicographically comes before data center, right? And if application name is sufficiently high cardinality, then the series that corresponds to like one data center gets shredded by that cardinality into essentially random lookups in a large part of the index file. So I cannot even take advantage of like throughput because I have to do many small reads, sorry. And that's not great. And what else? Yeah, finally, that's a very naive way of doing things. Of course, a real production storage gateway does not really do those 5 reads. There are plenty of caches and heuristics involved. But I think the point I want to make is that time series database index does not really help us here. We need to be clever. We need to come up with caching strategies to kind of make it work. And heuristics can break and caches can be called, right? So I do pay for this with high P99 latencies and with high startup times because I need to memorize maybe the postings offset table on disk and download it if I start a new object gateway. So I hope all of you are now sufficiently scared of index files and object storage, but don't worry, we think we have a better way. Why instead of storing data in a way that I have to access it through consecutive, essentially map lookups, we just store it in a flat table and in some columnar format. In our case, we chose Parquet, but that kind of does not matter. But we store it in a flat table. And Alan will walk you through in a minute how to actually read that data in Parquet format, but let me quickly introduce the schema we came up with. That's essentially the first thing you would do if you would write your data in a table. Every row contains one time series. Every column corresponds to a label name. We do shard our data into blocks horizontally, one of length 1. And we have 3 data columns that contain also the chunk data, but are sharded into 8-hour ranges to have some balance between, because if I shard it in 8-hour ranges, the smallest amount of data I can read is 8 hours. So there is a balance between a read query, a range query that I can schedule reads concurrently for 8 hours, and like an instant query where I have to overfetch 8 hours. But in practice, it works fairly well. And that's it. It's a fairly simple schema, but it already helps a ton. And yeah, Alan, why don't you walk us through a time series lookup?
Yep. Is it working? Thank you, Michael. So yeah, let's try to do the same exercise that Michael did to walk step by step in how we are fetching the data on the Parquet files. But a little bit before that, let's talk in a very high level how the Parquet file is, the layout of a Parquet file, and also some concepts that we'll be using. So this is how we store the data in a Parquet file. The first thing that we can see is called row groups. If you think that your data is you visualize your data as a table that has rows. In our case, each row is a time series. A row group is basically a partition, a horizontal partition of your data. So when you're writing the Parquet file, you can say, look, my row group size maximal is 1 million. So every 1 million rows, the writer will create a new row group, and you start creating the same structure over and over again. Inside each row group, we have like an optional Bloom filter that is an option in the common library that Jesus talked about. So it's the first bytes will be like Bloom filters for every column or the columns that you choose to create. And then you have the column chunks. So for each column in your schema, you have the chunks. It's a columnar format, so like the data will be written by column. And inside of each column chunk, you have the page. So the page is like the minimum amount of data that you can read in the Parquet file. Data inside of the page is compressed together and encoded together. Depending how you are encoding your column, you can have different types of pages as well. Let's say if you are doing a dictionary encoding, the first page is a dictionary, and the remaining page will be reference to that dictionary, and so on and so forth. So we have this structure, and then we have multiple row groups, and at the end of the file, you have the footer. In the footer, you have metadata about the file, like how is the schema, the number of row groups, the statistics of each row group, and all like number of rows in general. And we have like 3 things that we'll be using to run a query. The row group statistics are like row group index, the page index, and the offset index. We're gonna go one by one in the next slides. So let's say that you have like this PromCon EU, very simple, like pre-matchers or predicates or constraints, whatever you wanna call. We have metric name, container CPU usage, container DB Postgres, and namespace cache. So the first thing that we do is like in a single call, we fetch the footer of the Parquet file. In the footer of the Parquet file, we have the row group statistics. This information will have like the min and max. Oh, sorry. You have the min and max of every column and row group in that row group. And then you can use that information to start pruning row groups. So let's say for the first matcher, using that information, I know that I may have data in row group 1 and 2. And then I do the second matcher. I have maybe information in the row group 0 and 1. And I do the third one. So at that point, I can prune all the row groups that is in a PromCon EU is an end constraint. So I can only get the intersection. So at that point, I know that like the only row group that I need to open is row group 1. So you do a very similar thing now inside of the pages of the row group 1. You have the page index, you have the same information. For every page, you have the min and max of every column. So you do the same thing. Like you do like metric name equals container CPU, whatever. Then you do the second one, the third one, and now you have like, okay, I know that I need to open the row group 1, and the page 1 of the row group 1. I do all of this just looking at the footer of the Parquet file. Then now there is no other way. I really need to materialize that columns to filter out the rows that I'm interested in. So to do that, I use another thing in the footer called like offset index. So in that index, I have like the page location, so like where this page is located in the Parquet file. So I know that I'm doing 3 constraints or 3 measures. I need to download those 3 columns, that page for those 3 columns. I do that. Now I have all the rows for that page. And then I apply the filters like container CPU, like all the rows match. And then I apply. And then I say like, at that point, I know exactly what series I need to fetch that match that PromQL. At that point, I finish my index lookup, what we would call in the TestDB. And now I only need to fetch the samples. For that, I go to the second Parquet file that we call chunks. We do the same thing. We found the page for that rows, like these 2 Parquet files has a 1-to-1 relation. So I find the page for the respective time series. I find the locations, and I download all the pages that I need to fetch the samples. There's 2 things that's interesting here. Like the first one is that like before doing any call, I have like all the locations that I need to fetch, so I can plan how I'm gonna issue my calls to the object store. So I have a way better way to like plan my access to object store, which has huge advantage. The second thing is that we do projections here. Like if this query has an aggregation, so I don't really need to materialize the extra labels for that series, so I just skip it. If we have like a by job clause like that, then I go and fetch the extra column that has the by clause, and then I give to the PromQL engine. At that point, we did everything that we needed. We hand over the data to the PromQL engine, and then PromQL engine like do the rest. That's basically it. It's a very simple flow. Like all the data is kind of partitioned. You are scoping down your query all the time, and we don't have like this global symbols table, and we don't have like the global postings that I have. I don't know, env equals to prod, and I have a huge posting lists and things like that. That's basically it for the fetching part. This is just like a comparison. This is a random block that we pick in some of the clusters. This block had like 13 million time series, I guess. And we can see like the chunks files, the sum of all the chunks is 26 gigs in this case. And like the chunks.parquet, which has the same data in the Parquet format, only have 14 gigs. It's a huge change in size, but it's even bigger in the index size. The index in this case had like almost 4.6 gigs, and the labels.parquet, which has the same data and is the file that we use to look up the series, has only 153 megas. That's basically it. We were going to do a demo, but your laptop is not.
But we have a screenshot.
Oh,
Do we?
I didn't update the. Let me connect it to the internet. Yes.
We took a safety screenshot of the demo before this happens. But if you want to see a live demo, just hit us up in the lobby at some point.
Oh.
I can show.
I need to refresh here.
It's same range, same data. On the left, Parquet. On the right, it's our productive Kubernetes setup, Thanos setup. It's 3.5 seconds on the left when read through Parquet format, and like 17 on the right. Much better. And that's a general picture. It's really much better.
And also no state.
Pardon?
No state.
Yeah, no state. They just start instantly. And that's like a day, I think. Yeah, that's just fetching data for 1 day. And I think it's some CPU usage. for some namespace, some container, I don't know. That's it.
Questions? All right.
Hello, hello. Besides the great optimizations, do you see the packet files unlocking new features for Prometheus?
Yes. For example, the first one that comes to mind is metadata. In the design that we chose, we split already into two files. Well, like we can see that there. Well, over here. So we have zero-labels.parquet at the bottom, the bottom two, and then the chunks. Metadata could be a separate file. And something that's been a problem in Prometheus has been making it retro backwards compatible. So every time we introduce something, we have to first introduce a change that's in case you revert to the previous version, nothing blows up. With Parquet, I think it will be easy because you just add a file that has a one-to-one relationship with the others. And if you go back a version, it doesn't know about the file, it doesn't open, it doesn't break. Yeah, so I think, yes, metadata, and I think it makes things easier as well. Yep.
Hi. Thanks for the amazing presentation and amazing optimizations. I was wondering about the query materialization. So is it possible to, like when you're writing a query, to like just fetch up until like the label pages, just so you can have a count of amount of here way before you execute? Is that something that you've thought about?
That's how we implement limits, right? As soon as you're done with this cascading filter, you know exactly how many rows, you know exactly the byte ranges, so you can sum up to how much data you would need to fetch, and you can implement really sharp limits on like the amount of rows, time series, and the amount of bytes that you want to download. That's actually done in the library.
Yeah, that would be really good for like limiting really bad queries.
Yeah, you know everything in front of doing any
Is there already limits, right?
Pardon?
Is there already some limits?
Yes,
Oh, there's
Implement.
pretty. Yeah,
we have some.
that's
Very bare minimum, but
okay. Thank you.
Hi. Oh yeah.
You can go. Oh. Is it not green? Okay. Can you?
Hi. My question is more towards the implementation part. I'm also using Thanos, as in my S3 bucket doesn't have that amount of data what you at Cloudflare might have. But in general, how do you proceed? Let's say this goes live and I want to use Parquet files now. So do I do like an initial migration of the existing objects on the S3, and that kind of look like?
so the library has a package called Converter, I think. What we've done, the three projects have a version of this, not the same, but very similar. We have another service called the Converter. And so the Converter looks for the blocks that are on object storage and generate the Parquet files. And you need to make a few changes, but then your queryers know which blocks are have Parquet data, which don't, and use one engine or the other based on that.
Okay, so over the period of time, I would clean it up, right?
Yeah. So you start converting today, and over time you could convert backwards if you want, but that's a lot of work. But over time, if you wait a year, you will be migrated. Yeah.
And specifically for Thanos, there's a Thanos community project called Parquet Gateway that implements serious and query RPC, and you can just point your query at it, and that should work. I personally configure it with the distributed query engine. That's
Okay. And do you see this benefit only for, let's say, companies or consumers who have big stores? Or let's say on S3, I have 1 terabyte data. Would it make a big benefit for me? Have you done that kind of a comparison? As in switching would also take time, as you told.
I mean, in the end, you will store less data, as you see, it's more compressed, and you do less lookups. And maybe you don't face issues where your storage gateway starts for an hour, right? But you still save on requests to object storage.
Okay, thank you.
One quick question over here to your left. the metadata in the footer, is that like a convention with Parquet files, or?
Yeah, it's part of Parquet.
So you always store it at the end in Parquet?
Yeah.
No, like it's just...
Yeah, when you open a Parquet file, what you're actually doing is reading the footer. And then you say, I want to read 10 rows. And you resolve
It's not
the offsets and you read.
Seems like it would be classically a header. I'm just confused by the naming, I guess.
Yeah, it's not a header, it's a footer.
Yeah.
But it's the same.
I guess because they write after you are writing the codes, all the rows and the row groups, and at the end they write the footer.
Yeah, you keep track of the min-max.
Probably they put the reference of the footer in the beginning of the file, so you know exactly where to read.
Okay, really, really amazing work. Thank you for joining forces together. I think every user wants to have one project that do those things. Now we have sort of kind of combined work together. My question is like from the user perspective. We have Cortex users, Thanos users, Mimir users. Do you see this thing to be really a default very soon? And what people can, when they cannot adopt it, when can they use it? Like how they can help maybe to make this happen? Like what's the next step?
A bit tricky. I don't know the full answer to that. We are at the stage where all of us are testing this at scale and fixing things. And then I guess we need to have a conversation on whether do we want to adopt this in Prometheus or not, or is there a way that Prometheus can say how to interact with it with Parquet, like a formal, so that users can rely on this and make a decision?
On Cortex is already experimental feature, so you can deploy.
Good luck. Thank you again. That was amazing work. Next up, we have Joel fixing amnesia in Alert Manager.
Actually, two more.
And then you can use this. That's absolutely correct.
Mic check. Hello, hello, hello. Bit closer, huh? How's that? Can you hear me? Yes, perfect. Then I hit go. Okay, thank you so much for the invitation to my first PromCon. Super excited to be here. As you see, the talk is called Alert Manager Has Amnesia, with the hidden subheading, Shall We Fix It? I realized that that's a bit of a provocative heading, so I removed it, and you'll see why at the end of the talk. I'm doing this, there's a QR code there, like if you want to, you can scan it and like follow along on your phone. I've never tried that before, but it's up to you. You can also follow it here. Okay, a bit of background to this talk. So I'm a systems engineer at Open Systems, but only for the next week or so. I'm actually leaving. So this is a bit of a kind of cathartic talk where I sort of write my memoirs about my time with Alert Manager. It's one of the tools that we introduced to our stack. It was a big change, it was a big migration. And I don't think there's any colleagues of mine in here, but I'm not sure I could honestly say it would be 100% good feedback. But it was, we introduced some cool new stuff. So yeah, this talk is really about kind of digging into what Alert Manager does, finding a few kind of gotchas. And at the end, I'll sort of introduce a kind of a hacky thing that we did just to sort of open the discussion as to sort of the future of where Alert Manager can go. Okay, so who's actually had like direct experience working with Alert Manager, kind of like an end user, like an operator? I see a few hands. Okay, yeah, that's good actually, that's good. So this will be like revision for most of you, but then also I think the rest of you, this is kind of interesting to see like a user's perspective of what it's like to work with Alert Manager. So what does it do? I mean, it manages alerts. Like, what does that mean? So, for example, in our production system, we have maybe 10,000 alerts firing, sometimes even more. If every single one of those alerts resulted in a notification that you had to do something about, you'd basically spend your entire day responding and triaging alerts. So Alert Manager is all about grouping alerts to make the number of notifications that you get manageable. It's about routing, so making sure that the right team gets notified when their service is broken. And you can also do other fancier things like inhibition and silencing, which we'll dive into much later. At Open Systems, we're big Thanos users. I've given a few talks on our Thanos setup in the past. And we are collecting data from lots of hosts. I mean, maybe some of you will laugh, it's 10,000 hosts sort of around the world. But that's why we have Thanos, and we have kind of centrally evaluated about 2,000 alerting rules. And we run this in a platform self-service manner, so teams can kind of onboard their own rules. You kind of know where that's going. You're at the mercy of your users in that case, because they can really do whatever they like. We also have an alert manager that's also managed in a kind of self-service approach, so users can define their own inhibitions. And typically, that alert manager instance will be handling about 3,000 firing alerts. On the right-hand side, we have the typical receivers that we're talking to. So we have Slack, that's kind of like for internal alerting. And then we have the important stuff, which is the customer-facing alerting. So we have a custom application called Alert Handler. And this is basically a webhook receiver for the alert manager, and that's plugged into our mission control network operations center. That means that if something goes through Alert Handler, pretty much it's going to end up in a customer-facing ticket. And so if Alert Handler or if Alert Manager has problems, it can be very, very noisy. So this is a picture of like our public display of what's going on in mission control. That was a bad day. Typically, you'd see like 50 tickets maybe, and this is like 2,000, so yeah, that was not good. But what we've kind of noticed is that there are some patterns in the noise that you see. So we found that like Tuesdays were particularly noisy for kind of complaints about alerting. I should also mention that the alert handler, you know, we don't just let this happen, right? We've actually built in some custom logic. We have like a rate limiter. We have, you know, quarantine. We call it quarantine, basically. So when it looks like something's going wrong, it can kind of batten down the hatches and stop anything getting to the network center. But that obviously can fail. So yeah, Tuesdays are interesting. So what happens on Tuesdays? Most of our workloads, they actually run on Azure Kubernetes service. So basically every Tuesday, that's when they do like a rolling node restart, every 2 weeks maybe sometimes. And you know, of course, we design our applications on Kubernetes that they can handle that gracefully. But sometimes they don't. So sometimes what we notice basically is every time Alert Manager reboots, we got a flood of alerts and a lot of complaints. And yeah, it wasn't just about the node restarts. Basically every time we looked at Alert Manager, it had this kind of effect. So like version upgrade or a config upgrade or something like that. So yeah, we kind of had no option but to dig into it and sort of learn how Alert Manager actually worked. That's why I'm here today, to share with you what we found. It is available, but this sort of, I think it's a slightly misunderstood application. So I think it's nice to have it was nice for me actually to put this together and like say, okay, this is how my understanding of this is, and maybe it's useful for some people in the future. Okay, this is the basic Alert Manager workflow. You have an API, and you can do two things with that API that we really care about. You can fire an alert, so you send an alert to the Alert Manager, and that then goes through into an alert store here. I think if I do this, you might be able to see my, okay, we won't do that. You can see on the top, you see the alert store. That's held in memory, that's important. That then goes through to a dispatcher and a notification pipeline, and at the end of the whole thing, you get notifications in the backends of your choice. Great thing about Alert Manager, it has a lot of integrations. So anything you can think of, there's probably a built-in receiver for it. If you don't have it, like we built a custom thing, you can also just do like a generic webhook, and it's very easy to set that up. We also have the silences. So if you know that some label or alert is noisy, you can fire off a silence to the API. That then inhibits, or that not inhibits, it's the wrong word to use. That basically prevents the alert from going through the notification pipeline. And then you also have this notification log. That's the persisted store of which alerts have been sent or which notifications have been sent. So the coloring is kind of suggestive. The dark colors, those guys you can opt in to persist. That means that they survive reboots. But the alert store, that's actually only held in memory. That means that every time the alert manager is rebooted for whatever reason, that store goes away. So the alert manager comes back and has amnesia. It doesn't know what's going on. But that's not a problem, as we'll see. It's actually a design choice. Okay. I think we can very quickly just run through some animations of how this actually works. So like there's basically two important parts. First is the dispatcher, and the next is the notification pipeline. So when you fire an alert into the alert manager, let's say you have some labels on that alert, right? It comes from a metric. The first thing that the alert manager will do is it will group by some configured set of labels. So let's say we're grouping by service. Because there's no service, there's no group already existing, a new group will be created, and the alert will be added to the group, and then a timer will start called group wait. That's the initial time that the alert manager will wait for before it does anything with that alert, right? So it's sort of a buffer period. As group wait kind of ticks, the alert will be flushed to the notification pipeline after the end of the group wait. Now, then comes in another timer called the group interval. This is typically longer than the group wait, and this will just keep on ticking. And at the end of every group interval, those alerts will be flushed again in that group to the notification pipeline. Now let's imagine that another alert comes in. So it's the same service foo. That means it's going to be added to the same group. That's the beauty of group by, so that now we have sort of one batch of notifications which will be sent downstream. And when that's added, it actually resets the group interval. So if we're in the middle of a group interval, when we add an alert to the page, we'll actually reset that group interval. Then we continue, the group interval comes through, we get another flush, and now we'll have a new notification in the pipeline to handle. Just for completeness, let's see what happens when a new service has an alert firing. It will be added to another group and with a separate sort of concurrently running ticker or timer. Okay, so that's how the dispatcher works. Once the alerts have been flushed from the dispatcher, then we're on to the notification pipeline. So there's several steps which the alerts have to overcome in order to get through to your endpoints. The first step is inhibition. So this is where you can basically configure in your alert manager config that if an alert with these labels is firing, then don't let these alerts have notifications. So it's a way of saying, it's basically a way of scoping alerts. I've got an example of that later, you'll see it. Then you actually check the persisted silence store to say, hey, does this match any sort of known silences? If those two checks are fine, then we actually forward them to the routing stage, and the routing stage is configured by users to say, hey, when these guys are firing, I need to get an alert in my Slack channel or my mission control ticket, whatever. So we basically fan out those alerts. Now the alert manager has to decide whether it's going to forward those notifications. So there's two steps. Well, actually just one step. There's a deduplication step. And what happens is that this notification log, which was previously mentioned, it's basically a list of alert fingerprints, which is unique hashes of labels. And it basically checks, should I send this alert? Has a notification already been sent? If a notification has already been sent, how long ago was that notification sent? Is it longer than the repeat interval? And typically you'd set a repeat interval of like 3 hours maybe. You want to get pinged every 3 hours if something is still burning. More critical, you can make it smaller. But the alert manager decides whether or not it's going to ship the alert. If it does, it goes through to a retry stage, and it gets through to your endpoints in the end. So that's how the alert manager works. Back to Noisy Tuesdays. We kind of dug into this a little bit, and we sort of said, hey, which alerts are actually firing here? What's the problem? Like, is there some pattern that we can find? And it turned out that in our situation, we got a lot of these host down and cluster down alerts. So those guys should actually have been inhibited because there's kind of higher order scopings which should have been covered. So that's the second kind of observation which we made. Now, just to quickly run you down how we model alerts at Open Systems. So we're running, we run remote hosts for our customers, network hosts. And they're typically clustered for kind of high availability. So if we're thinking about what we actually ship and what we're monitoring, this is it. It's just a server rack, basically. So this is like a host, and then multiple hosts form a cluster. So if a host has a problem, then we want to know about it. That generates one ticket in mission control, which is a host down ticket. If the whole rack has a problem, then we could, of course, generate 3 tickets, but that's a bit noisy because then an engineer in the NOC has to go join them together. It's just toil. So yeah, we have a scope. We basically say that the cluster is down, right? So that the cluster down inhibits the host down alerts, which are also firing because those guys are also out. We have another concept, which is a site. So there can be multiple clusters at big sites, right? Big, lots of network traffic. We need multiple proxies or whatever. So that's another kind of, another concept that we have. So of course, we can go through the same exercise. We can have 6 tickets, we can have 2 clusters down, or we can just have a single site down with the inhibition rules in place. Right, so that sets the scene for kind of the problem. So what happens during the reboot? As I've already hinted, the silences are restored from the disk. The notification log is restored. So the alert manager knows what it shouldn't send, and it knows what it has already sent. What it doesn't know is the current state of the world. It doesn't know what the current set of alerts that are firing. It has to recover from this kind of amnesia which it has. And the way it does that, it's actually, like I said, it's a design choice, because typically you plug in upstream rulers to your alert manager. So Thanos, Prometheus, I know for sure those 2 guys do it. So if we use Thanos. And so Thanos, it's basically every 60 seconds evaluating these alerts, and it's constantly shipping those alerts. That means that within, say, about 2 minutes, the alert manager should have the same picture of the world again when it comes back. So as long as you have to be a bit careful, and this is where you're at the mercy of your users. If you configure like a group wait at 5 seconds, you're probably going to have a bad time. So this is where sort of documentation and teaching comes in, but that's not very effective most of the time. So over the time, as long as you give Alert Manager enough time to sort of rebuild the groups in memory and collect all the alerts coming in, you won't have problems. The issue comes really when you have funny configurations that you can't really control. To give you a bit more of a concrete example of what's going on here. So let's consider that we have a cluster down alert firing. So every tick, 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 we get these alerts coming from Thanos. And let's imagine that we also have a host down, right? So imagine this scope scenario where we have the host down, we have the cluster down. Now, what happens in the good case? We have the group wait. That then emits a notification that gets sent to mission control. No problem, that's great. Then we have the group wait for the host down, and because of the inhibition, that gets blocked, that gets stopped. This is perfect. This is exactly the behavior that we want. But now consider what happens in the uptime of the alert manager. If we have a reboot just beyond this, so basically we have a reboot in between the cluster down and the host down arriving, that's a problem. Because what's happened here is that we've lost the in-memory state of this cluster down. And that means that when the host down comes in, we have another group wait, and we actually end up with a flood of notifications in mission control. So congratulations, you've now got a lot of complaints, and you have to go and deal with that. That happens. So maybe a highly available setup will plug that gap and save us. Okay, so here be dragons. Highly available alert manager. So you might think you can just go ahead and say spin up three replicas. It's not that simple, unfortunately, because each of those guys is just going to be working independently. They've got their own silence store, they've got their own notification log, they've got their own view of the world, right? They need to talk to each other somehow. So if someone calls the silence endpoint, maybe only the top guy knows about the silence and the bottom 2 don't have a clue, so they're just going to ship those notifications, right? Or even worse, if one of the replicas decides to send a notification, how do the other guys know that they shouldn't send it, that it's already been sent? And the way this is solved is with the gossip protocol. So the alert managers form a cluster, form a gossip cluster. They gossip with UDP, and they basically make sure that the silence and the notification log is kept in sync across the cluster. And this works really well. Alerts are not gossiped, perhaps surprisingly. So that means that the Thanos, the ruler clients, they have to be configured to ship the alerts to all the members of the cluster. This is very, very important. This is something which I see quite a lot in sort of GitHub issues and stuff like that. You really must make sure that your rulers are sending not even to a cluster IP or a load balanced endpoint. It has to be to every replica. And so that means that you have individual groups, group weights, etc., sort of tickers going in each of these alert managers. Now, there is another problem here, because in this picture that we have, you would still be susceptible to the duplication problem, right? So, or rather, let's not say it's a duplication problem, it's a race condition, right? If all of these guys decide at the same time they want to ship a notification, how do you make sure that you don't end up with 3, right? Even though they are syncing the notification log. This is the next step. So then we have to revisit the notification pipeline. And there's 2 additions which we have, 2 extra steps which we need to go through when we're working in the cluster mode. The first, we just have to check that the gossip is settled. We have to check that this knowledge sharing that's going on is in a happy state. And this is usually important on a reboot. So when you reboot the alert manager, there is a big flood and noise of gossip all going around. So this is usually, this is only usually a blocking step at the beginning of the process. Then you have your, the steps that we've already talked about. And when we get to the routing step, there is an additional wait component. And the alert managers each have to decide if it's their turn to ship notifications. And when they decide that now is my turn, then they'll go through the whole dedupe step, they'll check the NF log, and of course, if their partner or another member has already sent the notification, the NF log will be updated, therefore they don't send anything. But because they've waited, they've kind of avoided this race condition. And yeah, in theory, we get nice deduplicated notifications in our backends. The last piece of the puzzle is fixing this race condition. So what the replicas do is they form an order. So they give themselves just a number like 0, 1, and 2. And so the 0th one is the leader. They go first. The first one goes second. The second one goes second, and so on and so forth. You can actually see this in metrics. So there's a metric which is, I didn't put the metric here. There is a metric called alert manager peer number, I think, maybe, something like that. So you can actually see what happens during a reboot. What basically happens is you can see that in this picture, the yellow replica was the leader first, and then the green replica, and then the blue replica. Then the yellow replica was rebooted, therefore the green replica took over, and sort of you can see how these numbers kind of click down as a reboot goes on. This is nice behavior of Alert Manager. That's a well-behaved cluster. Now, how do we actually use that to prevent duplicates? You just have to remember this iconic scene in Breaking Bad. There's basically a sort of a talking pillow that the alert managers hand around to one another, and they take turns. And this is governed by another timer, which is called the peer timeout. This is typically about 15 seconds. So after 15 seconds, the alert manager 0 will hand the talking pillow to the first replica. This guy will take care of sending notifications for a brief time, and then the next guy will take care of sending notifications, all the while gossiping, all the while updating the NF log, and so on and so forth. Now, after all that, did it help us? Not really, unfortunately. So, yeah, this was really the puzzling thing. And I struggled a lot with this because I see that kind of theoretically it does work, but at the same time, my background is experimental physics, so I'm aware that life just doesn't work like that, particularly when you move to distributed systems. So yeah, so what are we looking at here? We've basically got the, this is a rollout. This is a picture of a alert manager cluster during a rollout. And on the bottom, we have a metric which we own. This is from the alert handler. And this is the number of events which are stored in our quarantine. So this is basically a good measure of if we screwed up, basically. If that thing spikes, then we screwed up. So what we see is that we have a lot of alerts at the start, like 3,000, like I was talking about. That's a typical number for our production system. And then we see 2 replicas go away very quickly, and they come back. And then there's sort of a gradual, and this is, if you look at the x-axis, this is over an order of minutes. There's a gradual sort of increase in the number of alerts which are being stored in the system. And at some point, after about, I think after about the 3rd replica disappears, that's when the quarantine spikes. Boom, it's there. The notifications have fired again. So it's kind of suspicious that it takes so long for the cluster to recover after the reboot, because we saw that it should be back within about 2 minutes. So we kind of, just within the team, we sort of threw around these ideas, like, what if we can bring this time down, right? Like, we don't really understand why that time is so long, but what if we can just bring that time down? The hypothesis was purely experimental. Maybe if we bring that time down, the cluster will stabilize quicker, and therefore we have less noise. That might be good. So yeah, that was the basis of a kind of hackathon project, which we did. We ran that back in July. It wasn't the only hackathon project. We had many, like 20 submissions. But a lot of people jumped on this project, no idea why. It's kind of famous in open systems, or infamous. So the plan was this, basically. It was very, very hacky. It was 2 days. Let's just try putting a sort of distributed store or a shared store for the alerts and see what happens. See if that kind of helps when we reboot the alert manager. So now we have a plan. We just kind of need to figure out what to do. That was the hard bit, how to actually do the plan. So, of course, we live in the modern age, and what else are you going to do but ask Claude to do it for you? So this was basically what the hackathon team did. Yeah, so, I mean, that was the actual prompt, I think. I just to recuse myself here, I was really the sort of the PO of this project. I wasn't on the dev team or anything. I was just sort of managing from afar. What was funny was that 20 minutes before code freeze, the team was super happy, and they were like, "We did it! We persisted the notification log." And I was like, "Guys, that's already persisted. Like, you're supposed to persist the alert." So then they had 20 minutes of rapid vibe. But they actually did it before code freeze. It was very impressive. Well, impressive. 3,000 lines of slop. You can find it, actually. We have our open source alert manager if you want to go and laugh. It's very funny. Then we let an actual human take over. So it was useful in the end. We took the idea. This is Fabian Cohn. He's my colleague. He's a fantastic Go engineer. And he reduced that by a significant amount. He actually made it useful. So what we actually did is we took this model and we just said, hey, let's just write this guy to disk as well. So we don't mess around with clustered sort of database mess or anything. We just, on shutdown, we write a snapshot of the alerts. And on reboot, we try and read that file if it exists. And that's all we did. So how did that work? This is how it looked before. So it's a pretty clear signal, basically. Every time you get this alert manager reboot, don't worry about the y-axis, it's kind of weirdly scaled. But you can see on the bottom, the quarantine immediately spikes, every reboot. And this was kind of every Tuesday, by the book, you knew this was going to happen. Now, when we rolled out our patched version of the alert manager, we saw kind of 3 different steps. The first was the initial version bump rollout. That caused some noise, of course. This is just showing the total alerts loaded into the alert manager. And then, from then on, we were actually able to recover the alerts on disk. And the interesting one is the last rollout, because then everything was kind of fully stabilized. And so when we do a rollout, you can't even tell that the alerts have gone away. And that actually had a very nice effect for us. So you can see here that this was a sort of a more recent, I say August maybe. Yeah, this was a successful rollout. This was a quiet rollout. And overall, I mean, if we just count the total number of alerts that hit the quarantine, it dropped away about 80%. So we do still have some issues. Yeah, but it's kind of nice. So yeah, back to the sort of the title. I need to finish up here. So Alert Manager does have amnesia, but should we fix it? Kind of 2 pictures that I would put to kind of answer that. The first is a UK child's cartoon. Can we fix it? Yes, we can. We've proven maybe that in our setup, we can fix it, perhaps. But should we? To be honest, the short answer is probably not, because like I say, there are very good design choices why the Alert Manager is built the way it is. So I should reiterate that we built a hacky setup that works for our chaotic and volatile environment. It really is very, very chaotic. It's almost certainly not ready for public consumption. But there is still room for Alert Manager to evolve. So there's some very interesting discussions ongoing at the moment. I know that I'm not sure if they're here, like Kevin Hellemund from Cloudflare or Sivash Safi. They are both working a lot on this at the moment. I know Cloudflare has a team who's looking at Alert Manager. And so there's a few ideas going around how to make the reboots more stable, because large environments do seem to suffer from this. And one idea is to make inhibitions part of the gossip. So don't gossip all the alerts, that might just be too much data. But let's say, okay, let's just take the important alerts, the inhibited alerts, and put them in. And there's some links there if you want to go and have a look, and a GitHub issue to get involved. So that's it. Thank you very much for your attention. And I think we have a few questions.
Amazing work. Questions?
Hello. Hello. I'm here.
Hi.
You said that probably it is not worth implementing the saving of state of alerts between alert manager restarts. And my question is why?
I would say it's not. Okay, I should caveat that. I was perhaps a bit too harsh on ourselves. So what we did is probably not the way to do it. I would say that. There was a pull request, I think, early days, like 2019, where someone actually added etcd as a backend, like a shared alerting backend. No?
Yeah, I think that it's too complex to add some it's ACCD.
That was
but it's better to store these states of alerts locally on local disk and then recover.
Yeah. So it could be, I mean, let's say I would like more people to validate what we did, let's say. I think that it looks interesting, but I'm also not 100% convinced that there's not just something weird in our setup, because it is complicated. But yeah, I think that it could be something which could spark a sort of, if somebody else wants to try, we have the code is ready, someone else can patch their system sort of tomorrow if they want to and see if it helps them. That would be really cool actually to get feedback like that. Yo.
So the guiding principle of why the alert manager is kind of wacky the way it is because the guiding principle is it needs to survive split brain. Mm-hmm. So if you have an alert manager in one continent and an alert manager in another continent and they're gossiped, if the gossip fails, each continent can independently notify.
Yeah.
So that's the only guiding principle there and why it's so weird. That said, do you want to become an alert manager maintainer?
I took the mic. You go first.
Absolutely. Yeah, I think that if any good of this talk comes, it would be great to see a bit more action on the Alert Manager GitHub. So yeah, certainly that would be.
Hey. Here, hello.
Hi.
Oh, Ben was faster than I. So what I wanted to say is that being very transparent in the Prometheus team, we are currently lacking expertise in Alert Manager. Mm-hmm. We have maintainers, but they've been moving around. They have different jobs, different priorities. We don't have many maintainers today. So what can Prometheus team do to onboard you or somebody in your previous company?
Yeah.
Yeah. How can we do so that we collaborate together instead of like we did something that's incorrect? Let's work together.
Yeah, I mean that's a good point. I think just probably more active maintainers would help. I know, yeah, like fairy dust, right? Yeah. I think keeping the dialogue open in the CNCF channel, that of course helps. Yeah.
Are you on CNCF?
Yes. Yeah.
Test. Awesome. I know we're not supposed to give statements. I wanted to just ask for one quick clarification about the 3 instances sending with this 15 seconds peer timeout. Maybe you meant it like that anyway, but just to clarify, it's not like they take turns every 15 seconds, but it's, as far as I understand, it's always the first instance sending, and then the next one is listening for 15 seconds on the gossip channel to see if the first instance made it. And if it already sees, oh yeah, first instance made it, it will never send.
Okay.
And then the next one waits 15 seconds longer. So the second one, the number 2, will wait like 30 seconds in total. So in the normal case, should always be only the first instance, and then the other ones will learn in time, oops, yeah, it has already been sent, right, over gossip, and then in the worst case, split brain, network partition, they all don't hear from each other anymore, and you will get 3 notifications if they can still reach you. So that's kind of this fail open model of Alert Manager. Yeah.
That's interesting though, because we see in our metrics, we see that there's like a pretty even, I should probably post it, but there's like a pretty even split in the rate of notifications being sent by every instance.
Okay. I mean, I can also be corrected from the audience if Alert Manager, but that's always been my understanding of it. And yeah. And I checked the code again, and it looks like it is supposed to be like that, but maybe there's a bug also, or in my understanding.
More
but
I'm wrong.
yeah.
Thank you for the talk. I'm here. It's not a question. I'm just wanted to also share that we're familiar with also such a problem, and what we have found is that there is dirty hack that you can swap basically inhibition engine and ingestion and put 5 seconds in between them in the code, and it will just work.
Okay.
Inhibition just very slow, and there is an open pull request to make inhibition faster, but it's been, a year, I think, in review.
Okay. Yeah, but that's interesting to share those kind of stories, right? I think those would be it'd be really cool to see those kind of hacks coming into the Slack channel and collecting them and trying to build features around them. This would be amazing. Yeah. Awesome.
Let's keep it with questions, not statements, but yeah, it's interesting. I got 2 statements and 1 question. First, thanks a lot, for confirming my sanity, because for the last 6 months, I thought that I'm just insane and I'm seeing what others aren't seeing.
Assuming I'm not insane.
Second thing is, like all the alert managers are sending the messages regularly. Like they are really, as it was. As it was described with the token, that's at least how we can see it in the metrics. That really all the like there is counter for how many alerts were sent. Yeah. So, and there are even open issues for that on the alert tracker. For. It's not supposed to be like that. Yeah. That's not okay. That's yeah. You said maybe there is bug. And my question: so currently you are running this in your production?
Yes.
Yes. Yes. And is it stable?
Define stable. Like I said,
it's place for horses.
So I would say yes, it's stable in the fact that we were able to successfully reduce the number of quarantine alerts we have. We don't see any kind of, for example, false negatives or this kind of thing, missed alerts. We're quite confident in the system that we have. It's just a bit too noisy. It doesn't like if things change. For example, there are some subtle failure modes, like if with the node restarts, if the ruler is rebooted at the same time as the alert manager, and you have resolved alerts, they get lost also from the ruler resending, which means that you can also lose resolutions. And that's a problem for customers because they don't like it if the ISP line looks like it's been down for 3 days, but actually it was resolved after 5 minutes. So I would say yes, it's stable, but with a very big caveat that I would not be comfortable to roll it out or propose it as a feature in the upstream alert manager until it's been validated by maybe more of the community. Yeah. But if you're asking sort of if you want to run the patch, I would say go for it. Yes. Yeah.
Hi.
Where are you? I can't.
Yeah.
There we go.
Thank you for the talk. We had the exact same issues in production.
Okay.
And we ended up fixing them by adding an additional service to handle the duplicates. But I wanted to ask if you tried adjusting the 3 configurations, the group weight, the interval, and the gossip interval to try to minimize the duplicates. And what are your observations there?
We spent a bit of time doing this, but it's very hard to run experiments in production. And the tricky thing as well is we really struggled to get a development setup that could mimic this behavior. So we haven't spent much time tuning those parameters. We kind of leave those at the defaults, mainly because, like I say, we would have to really mess with production. That could be very noisy, beyond what we're used to. So yeah, but that would be interesting. Like the first thing that we actually spent some time on, like a sprint we spent 2 weeks on, was can we build a dev setup that really mirrors this? And after 2 weeks, we figured, maybe not, because production is just too hard to model. So we stopped that and we focused on what we can kind of treat symptoms-wise.
Hello? The last question. It's not question, just suggestion. Probably it would be better to just wait after alert manager restart for the time which covers all these timeouts, which you configured in the configuration, and do not send any alerts period of time.
You've opened up another thread there, because then the Prometheus operator prevents us from doing that. To have like a min ready seconds, right?
I think that the alert manager can automatically determine this time duration, while it should not send any alerts until it rebuilds all the alerts in state.
Yes, so you basically build a sleep into the ready check. Or something.
Yes, something like this.
We did try that. We found it was basically then just too slow, because we'd have to, have a sleep of 15 minutes, pretty much. So yeah, I think that was successful as well. But we focused on getting the cluster back as quickly as possible. That was our sort of guiding light there.
All right, we're at time, but I love the momentum and energy around Alert Manager, so we wanted to keep it going, I guess. Please discuss some more Alert Manager things outside. We have a break now. We are back at 11:15, listening about CPU hardware counters. Just for the people in the room, we are going to start like 5, maybe even 10 minutes later, because we also have to wait a bit longer until we can get lunch later on. So we're pushing the schedule like 5 minutes back or something. Break. Just for everybody, we are like kind of pushing the schedule back by 5, maybe even 10 minutes, depending on how much time we'll need, because lunch is a bit later on, so we don't need to like stick around doing nothing or whatever later. But yeah, I'm super excited for the next talk. One of my highlights I was looking for sure. Always good time listening to Brian. So yeah, I'm very curious about CPUs and what they are. Hope you're gonna explain it to us. So yeah, stage is yours.
Hello. Everyone hear me all right? Well, welcome. So thanks for coming back to day 2 of PromCon. My name is Brian Borum. Let's put that up on the next slide. I work at Grafana Labs. I have worked on Prometheus and adjacent projects for about 8 years now, and I'm a maintainer of Prometheus. But today I'm talking about way down in the hardware, so there's no AI in this talk. There's no... there's no demo because I was too scared. And in some sense, I didn't really do anything. I mean, well, you'll see. You'll see what I do. I'm just going to tell you about a thing that you might like to do and what you can do with it. Okay, so well, let's start counters. So I think I'm about the 5th talk to put up a slide like this. You know, Prometheus is pretty keen on counters. And this is an example which is counting how many bytes has this network interface received. So counters are a thing that are found all over the place in operating systems and applications and devices and so on. So yeah, there's billions of them. How many seconds has this process executed on CPU is another popular counter. And that one leads us to CPU is busy. And you know, why do I do this job? Because I basically spend most of my time shouting at the screen like, well, what is it doing? Okay, it's busy. Doing what? You know, the CPU could be doing arithmetic. Maybe that's what you expect, but it might also be waiting for memory. Memory is much slower than the arithmetic bit of the CPU. Or if you kind of understand the complicated bits, there could be the instruction pipeline could have flushed after a mispredicted branch. What can we get that extra level of detail is essentially what this talk is about. So this is CPU. We'll be going through this. No. This is a Intel Xeon Skylake. It is a 28 core, I think. Something that looks a bit like this is a core, and they're kind of mirror imaged as they go across. So that's the kind of hardware I'm talking about. Other CPUs are available. Basically, the same facilities are available on Intel, AMD, ARM. It tends to be on the server parts. Maybe less so on the desktop parts. All right, so this picture is going to be a little bit complicated to walk through. So I simplified it. These are some of the things you find inside a CPU. It's going to fetch instructions. It's going to fetch data from memory. It's got some registers. It's going to read them. It's going to do ALU, or the arithmetic and logic unit, and it's going to write stuff back into registers. So, I mean, maybe some of you went to a school where they taught something like this. It's not always as simple as that. I kind of fleshed this out a bit. This is still a very simplified view of a CPU, but there's all kinds of more bits in there. There's in terms of the data cache, there's a level 1, level 2, level 3 caches that go at different speeds because the memory is like 100 times slower than the ALU. There are multiple ALUs in parallel. We're doing branch prediction, trying to figure out which instructions to decode next. So there's a lot going on. And so basically the point about counters, CPU hardware counters, is that we can find out what all these different things are doing at what rates. So there is a counter inside the CPU for hits and misses at each level of the cache. And there's more caches here that we'll talk a bit more about later. We've got counts of branches predicted and mispredicted. We've got counts of how many instructions finish this part of the pipeline. So, so that is the basic idea that I'm talking about. The CPU has counters, has a little Prometheus inside it. Does it? Maybe. Well, no. So I've drawn a CPU at the bottom of the picture and a Prometheus at the top of the picture. And we'll walk through how these things connect up. So the first part to talk about is the PMU. So this is a section on the chip. It is roughly there. It's bigger. It's not as big as that in real life, but it's roughly there on the chip. PMU is a term that Intel introduced, but all the other manufacturers are following suit. So you can look for this thing. And the PMU is the part of the chip that's responsible for collecting these counters and making them available to software. On Linux, the subsystem in the kernel that can get hold of these connectors is called perf. The perf subsystem in Linux. Perf is very powerful, very flexible, and so hardware counter is not the only thing that it does, but certainly that's where the counters arrive next in if you're using Linux. And then we need some kind of exporter to get it into Prometheus format. So the first one I'm going to talk about is Node Exporter. So Node Exporter already exists. Probably everyone who's using Linux is already running it. But to get it to talk to perf, you turn it on. You say -collector.perf. And this is what we got. Nothing. Okay, why is that? This is what happened when I tried it. I mean, nothing. So it turns out you need permissions to get this information. So basically, you need to tell the kernel not to be so paranoid. The paranoid number is 2 normally, which means it's this much paranoid, and you can tell it to be not so paranoid and let people see the performance counters by changing this sysctl or proc file. Now you can also run Node Exporter as root, in which case it will have permissions, but then Node Exporter will shout at you and say you should not be running Node Exporter as root. So multiple choices how you can do this. If it's inside a container, you might need some other privileges or security profile. Anyway, so I ran Node Exporter with the collector. We got some data. This is the Grafana drill down view, which I found really nice. It's relatively new. It's like, so you don't actually have to type any PromQL, but I gave it the prefix node perf. That's up here. So it just kind of finds everything that has node perf in the name and just shows me all of them, kind of grouped and aggregated. So that's great. We got perf metrics coming up on the screen. That's great. Actually, if you look at these, they're not hardware counters. All of these things, context switches, memory faults, CPU migrations, these are things the operating system does. So these are counters that Node Exporter gets from perf, good, but it doesn't get them from the hardware, bad. Okay, what else is going wrong? Why are we not seeing our hardware counters? It's because it's a virtual machine. Virtual machines hide hardware counters, and up until about 10 years ago, this would have been the end of the talk. You know, unless you can get hold of one of these things physically. You know, if you buy these things and run the physical hardware, then sure, you can have access to it. But the VMs that we get in the cloud, by default, will hide the hardware counters. And it's kind of a security thing. I mean, basically, you could be renting, you know, 4 cores, and Amazon or whoever would rent you that piece of that chip. And and if you could look at the hardware counters, you could probably tell what other people were doing on the neighboring cores. So that would be a security vulnerability or a privacy risk. And so that's something that never happens. If you're renting a portion of a chip, then you will not see any hardware counters. Nowadays, you can rent what they call metal instances, so you do get the whole chip and no hypervisor. So that's one option. But the other thing you can do is if you rent the whole, nowadays with the modern instances, if you rent the whole chip, then you get hardware counters. So I can carry on with my talk. How would you know? Well, the Intel publish a page. I guess I'll put the slides up somewhere at the end, so you don't have to type in this link. Intel, their literature tends to associate this hardware counters with their product called vTune. But basically, you need the capability. You need to have hardware in this column. So, for instance, an M7i 12x large, that's a 48 core. Well, it's 24 core physical, 48 with hyperthreading. So that one is the whole chip, and you get hardware counters. The slightly bigger 16x large, you don't get the hardware counters because you're actually renting 1.5 chips. So it's a little bit hard to follow, but it's pretty straightforward in the end. So yeah, in terms of demoing for the talk, I took Node Exporter. I rented M7i 12x large, which costs quite a lot of money. Well, because I was doing it private in my own personal Amazon account, so I didn't do it for very long. That's another reason why there's no live demo. Anyway, so now we got many more metrics. This is just running exactly the same command with the paranoid setting turned down on a different machine, and we get hardware counter. So you may be a little bit too small to read, but so we've got like cache refs total. We've got L1D. That's the fastest cache for data. Read hits, read misses. We've got a bunch of metrics here. That's hardware counters coming out at the node level. So that's pretty cool. So tick, we can get data. What if I want more detail? So that's at the whole node level. What if we want to go down to processes or containers? Well, there's CAdvisor. CAdvisor is a project from Google. And I quote, CAdvisor brackets container advisor provides container users understanding of the resource usage and performance characteristics of their running containers. Does it get me hardware counters? Yep, probably. I just need to give it this -perf events config. I need to give it a JSON file. Okay, how do I get the JSON file? Well, the manual says it should look like this. Okay. Some hex numbers, huh? Okay, cool. I should have asked this earlier, actually. Who's done this before? Yeah, that's kind of, yeah, nobody, right? Just give it a config file. Looks like this. It says config values can be also obtained from a book. Okay, let's get the book. So this is the Intel book that lists all the. This is where you get the hex numbers from. It's a 333-page long book. So each page looks like this. It's excerpt. It's long book because the counters change with each generation of the processors. So they have names like Sky Lake and Ivy Lake and Sky Baby, or I don't know what they called it, but they. So yeah, it's not quite that you have to read 333 pages. You sort of find the processor that you're using, and then you can look up the numbers that you want. As I've said, Intel are not the only people who do this. AMD have a book. Their book is a little bit shorter, but same, volume 2 of 6. Same basic idea. There's a massive book. And you can look up the hex numbers and you can get the hardware counters that you want. So it was a lot easier in Node Exporter, right? I just turned it on and, bit of permissions and I got something. In C-Advisor, I guess it's a googly thing, right? Simply type in the correct set of 50 hex numbers and you will be on your way. Anyway, so there's a but. Doesn't actually work. Wow. So if you download the container image that everyone uses, the sort of whatever Google C-Advisor container, and give it the file with the hex numbers and turn it on, crashes immediately. No waiting. But if you read this issue, people have noted all you need to do is build the software yourself, and then it doesn't crash. So this is on the same machine. I typed in some hex numbers. Actually, so there's a set of things that the perf subsystem can get you by name. So essentially, perf has the hex numbers in it. And then beyond that, there's a set where you have to type the hex numbers in. So this is counting the number of branch instructions, cache misses, instruction. I can get some data out of C-Advisor. And this is at the container level. So we can go down a level. I don't want to go into all the massive depths of how containers are implemented and so on. But basically, if you had a bunch of pods or something like that, you could see them coming out. I wasn't actually running Kubernetes on my machine that I rented to show this with. So the names don't look like. What can you actually do? Is this worth doing? Well, for an example, who knows what the TLB is? Like 10 people? 7? Okay, good. So when the CPU is executing kind of up here, it's dealing with memory in virtual addresses because you have virtual memory. And then when the physical memory has a different set of addresses, and there's a mapping between them at the page level. So the TLB stands for translation look-aside buffer. That doesn't tell you anything. But the TLB is the cache of mappings from virtual address pages to physical address pages. That's it. It's a cache. If we didn't have this cache, then every single time you accessed memory, the CPU would have to walk the page table. You start with a 64-bit address, and you end up, pages are by standard 4 kilobytes. So that's the last 12 bits are the only bit that actually physically maps into the page. So the first 52 bits of the address have to be walked up in a page table. There isn't a 52-bit lookup. It's a 3-level lookup. You need a cache. How big is the cache? 1,500 entries, roughly. It varies by chip, but that's a good number. 1,500 entries times 4K pages, you get 6 megabytes of memory to party on. You don't use more, nobody uses more than 6 megabytes, right? Surely. Okay. Why am I going on and on and on about this? Yeah, so there's metrics for these things, but they were not turned, or they were not coded into Node Exporter, so I've added them. I don't actually know if this PR is merged yet. Does anyone know? No, okay. So soon you'll be able to run this yourself. So we can get metrics on hits and misses. They're separate TLBs for data and instructions. So this is data hits, data misses. Oh yeah, I didn't put the instructions on this page. This is all data. This is reads and writes, hits and misses in the TLB cache. And what I'm doing here is I'm running a benchmark. I'm running a Prometheus benchmark loading the WAL, the write-ahead log. So this is basically startup of Prometheus. And it's gonna, in this particular benchmark, I'm loading about 8 gigabytes of data. So way bigger than 6 megabytes. So what I'm getting is I'm getting a lot of misses in the cache. I mean, percentage-wise, it's pretty good, actually. The hits are like 1 billion here, and the misses are like 10 million here. So it's actually, percentage-wise, it's pretty good. But I am getting a lot of misses. And what you can do, 4K is not the only choice for page size. You can turn on what are called huge pages, or in Linux, there's a facility called transparent huge pages. Again, I'm not going to go all the way down the rabbit hole here. But basically, if you do this, your Prometheus or your big programs will get 2 megabyte pages instead of 4K pages. They will, so that's 500 times bigger. And we've got the same cache. We've still got 1,500 entries in the cache. So we're going to look up the cache 500 times less, maybe. Okay, so here's the metrics. So I turned on that facility per those instructions, and the number of misses went down. It's me running the same benchmark twice. So that's a concrete example. Given the data, you can tell if you have a particular kind of problem. In this case, I'm getting a lot of TLB misses. Oh yeah, so this is a metric, another Node Exporter metric. This is an operating system metric, but it gave me 12 gigabytes of huge pages, and then it actually stepped down. That's kind of interesting. There's a daemon in Linux that tries to decide how much huge pages you need. It's just running the same metric, same benchmark, like multiple times over. So that's kind of interesting. Anyway, so there was the timings before. It was like 64 seconds, turn on, transparent, huge pages, and 57 seconds for exactly the same benchmark. So the whole thing 10% faster to start up your Prometheus or whatever. So there we are. That's an example of using hardware counters to diagnose an issue and then reconfiguring the operating system and make your program go faster. So that's the end of my talk.
Amazing. Now everybody knows why I love these talks. Quick question from my side while I walk over. Why aren't huge pages enabled by default on most systems these days?
Right. Why are huge pages not on all the time? So So basically, the amount of memory you're going to use rounds up to the page size. So if you ran a lot of really small programs, then going to the 2 meg pages, you would observe your memory usage would go up massively. And there are some other things that you might not like about it, but basically, so Go actually turned it on. It's either 1.20 or 1.21. The Go runtime folks put some code in Go that would get you huge pages without you doing anything. And they got enough complaints from people who ran a lot of small programs, or for whatever reason, it disturbed their functioning. And so they turned it off again in the .1 release of Go. So like 1.21.1, turned it off again. Those instructions that I quoted are from the go.dev website. So they tell you how you can turn it on and mitigate some of the bad effects. But yeah, it's not on by default. Yeah, make you run.
Hi, thanks for the talk. Do you have anything to add about accessing those counters from Windows?
Oh, Windows. I mean, it's perfectly possible. No, I didn't take the time to look into that. But I think now you probably got some keywords you could Google. You could do some web search or ask a AI.
Yeah, thank you for the talk. This was really, really interesting. I think the TLB example is interesting because we can control it from the kernel. Do you have other examples in mind, like how you could control, say, how many instructions you do? Because I guess a lot of Go developers here say they compile their code, they don't really have insights about how many instructions it is at the end of the day. So,
right, yeah.
And this is a mass of extra metrics.
Yes.
Yeah.
Yeah, I mean, it's a way to get more data, and then interpreting the data then can be its own problem. So in terms of other things you might be able to do with this information, I mean, if you saw a high rate of branch mispredictions, you might be able to reorder the cases. I think the Go compiler is pretty simplistic in terms of how it lays out what comes next, and by swapping around the if and the else, you might get the branch prediction to work better. Beyond that, knowing that you have different rates of L1, L2, L3 cache misses might help you pick a different algorithm or different data structure. That's getting into. I mean, you have to be really knowledgeable about those things to get anywhere. Beyond performance, there are things like security, for instance. So people might remember the Rowhammer vulnerability. So that's an example where you can detect somebody messing around with your system through hardware counters, because that would show up as extremely high rate of memory accesses. Basically, the Rowhammer, the exploits would flush the cache repeatedly. So basically never hit even the L3 cache was never hit, and they were hammering the memory. So that's an example. It's not a performance example, it's a security example where you could detect anomalies running on your systems and maybe fire an alert for somebody to go and check that out. Could be that malicious code has got onto your system. Another one, NUMA, non-uniform memory access. That's actually my previous talk from KubeCon Tokyo. But again, they're hardware level counters that would indicate that you the chip where the program was running and the chip where the memory was stored were not connected directly to each other. And you could possibly change your config at the kernel level to make that work better. Aye.
You mentioned that virtual machines aren't that well supported because you can't pass down the anonymized information, let's put it like that. But you also mentioned that cAdvisor can split it down on a container level. Are you aware of any efforts on passing down just specific things to your virtual machine instance to the host from the hypervisor?
No, I'm not. I'm not aware of anything beyond. So basically, what ends up happening is the hypervisor itself has a. I don't know if I can get back to the right page. There. So basically, the hypervisor steps in here, and there's what you might call a virtualized PMU. So the code executes a special chip instruction to collect the counters, and that instruction is only allowed in ring 0, so it trips a fault, and now the hypervisor steps in. So your question about could there be better facilities basically has to be solved by the hypervisor. So I'm not aware of anything better than what I talked about. You could go look at the Zen project or their different hypervisors. You could go look at what they support, or you could ask your cloud provider. I mean, the provision seems to be quite patchy. As far as I could tell, Google Cloud only supports the virtual PMU on ARM chips, so the C4 generation. It's only the newer chips and only some of them. To your question, in theory, the bit of the hypervisor that steps in here could do more, but I'm not aware of any that actually do more. So you guys need to all call your cloud vendors and ask for more.
All right, we're at time. Thank you again, Brian.
Thank you.
And can everybody who has a seat that's available next to them raise their hands? So all the people that are kind of blocking the entrance or exit, for what it's worth, like please find somewhere to sit, because we want to keep the emergency exits free as well.
Oh, I can get back in there. Thank you. Turn this on.
Are there any free seats left? Just so we know. It's one. All right, there's more over here if you want. You can see. You never need to look to the.
Oh, cool. Okay, I'm already presenting. Yeah, yeah, it's mirror, I think.
Change. Yeah. Yeah, this looks good. It just mirror.
Yeah, maybe I would like maybe.
Because you want to extend. That's already what you had. Yeah.
Yeah. Okay. So let me try.
Yeah, try. Step around.
Okay. Cool. Yeah, that's fine.
All right.
Cool. I'm audible.
Yeah, you should be. I think you
press this.
Should be audible. Yeah, I think it might be just a bit.
It's working.
Yeah, yeah.
Yeah, can you hear me, guys?
Yeah.
Cool.
All right. So with that, yeah, let's reverse engineer some PromQL.
Yeah, let's go. Hello, everyone. Good to be here. Pretty excited, crowded room. A little bit nervous, as of course, in the beginning of the talk. So let's try to reverse engineering like PromQL usage. So how many of you already need to answer the question is like, who is running this pretty expensive PromQL expression and breaking my monitoring system? Raise your hands. Yeah, I think most of us, right? So let's try to understand how we can try to discover that, because I've been in this place a few times now. So who am I? I'm Nicolas Takashi. First of all, I'm Afonso's daddy, this cheeky little boy. I'm a tech lead at Coralogics. I'm doing like platform engineering and a lot of other things, but mostly focused on observability. Also maintainer from Prometheus Operator and Persis, and contributing to different CNCF observability-related projects like Thanos, Prometheus, OpenTelemetry, and so on. Cool. So last year at PromCon, I gave a talk about unbreakable Prometheus and how to make your Prometheus more predictable in terms of like memory consumption, the shape of your data, and so on. And someone on the audience just raised a question, say, oh, this is nice, but there is yet another way to break your Prometheus. You can just have like pretty expensive queries going on. And that's true, because if you have too many parallel queries, concurrent queries, touching hundreds of samples, you will need a lot of memory, okay? Luckily, Prometheus provides some limits to that, but this is not the idea of today. I don't want to talk about limits. This resonates with me because I see myself needing to answer the same question that I just asked you, like how to identify those kind of things, right? We don't observe query usage. Like we collect a bunch of data, but we don't know how your users is using the data that we're collecting. We don't know the shape of the data. We don't know what are metrics being used and not to use it. What are the common aggregations that people is doing on our system? How far in the past people is looking the data, okay? So if we don't know all those things, we cannot optimize, we cannot like answer those hard questions in hard moments. So first of all, try to understand like how we can get in this kind of insights today, okay? Because we already have something available. Like first of all, we have Prometheus query log file. For the ones that don't know, Prometheus has a feature that allows you write into a file or to the std out every in-flight query, okay? So you can get in a lot of information about queries that are being made through your Prometheus instance, queries from the recording rules engine, and so on. And you can get a lot of nice insights. But like, you need to configure that because this is not available for default. This is very specific about Prometheus, so if you're running other flavor of backends, you might not have this feature. And later, you need to ship the data from there to some centralized log system or something to do some kind of aggregation. The second one, it's like probably Grafana panel inspector. You can just inspect Grafana panels and see how many rows, queries touching, the time taken, and so on. And the last one is traces, distributed traces. It's pretty awesome, especially if you're running some sort of like Thanos, Mimir, you have many components, you might have like many query instance ongoing, and you can see and spotlight what is the latency and so on. But you have the sampling problem. Sampling is hard in traces, okay? You might need to understand if you collect too much, you might have a lot of problems with amount of data. If you collect too little, you might lose important signals. And traces, they are not so good on answering questions like what is the most common partner that people is executing, or how far in the past people is looking on the data, okay? So luckily enough, community, we have a lot of nice friends in community. We saw today with the Parquet Common, like when you have community joining efforts. Me and Michael Hoffman from Parquet Working Group as well, we were chatting and we noticed that we have like some sort of the same issues as many of you. So we share the same concerns, the same pens, and we discussed that maybe we should build something, okay? Buy would be better, but yeah, we need to write something. But we have few constraints, like we want something that could work cross backend, Thanos, Mimir, Grafana, Grafana Mimir, Cortex, I don't know, Victoria Matrix, and so on. So the premise is like any Prometheus compatible API. The second one is like, we don't want to do any kind of change on the upstream project. It needs to be like very simple. We need to be able to enrich context from the color in getting more information and act it almost or near real time. So we decided to build like Prom Analytics. Naming is hard, okay? So this is basically proxy. It does exactly what the name says it does. It sits between your clients and your monitoring backend, Prometheus, Thanos, whatever. And it captures context and writes the results that we are getting from the context to a Postgres data store or SQLite if you want to experiment or running a small environment. Okay, so zero change to your backend. It's a Prometheus compatible API and very simple proxy. So how it works, okay? Basically, you have your client in this context process. Process is like sending requests to Prom Analytics, and Prom Analytics just forward requests right away to the backend. When we get the response, we extract the required information, and we push in a Go channel and reply to the client right away, because we don't want to block your query, your query response due to any kind of like analytical processing, okay? And this is persisted async by Go routines. You can have all the controls about like the amount of jobs that you can run to write into your data stores, the channel size, and so on. Cool. So what do we store? This is very tiny and very simple schema, okay? We just store the query, which is the raw PromQL. We store the step, the type to understand if this is a range or instant query, the label matchers that you have on your PromQL, the duration, stat codes, and some specific Prometheus engine fields that you can request to Prometheus query engine about the total query samples and the peak samples. These might be later useful to understand like what is the most expensive query, if we can apply any label matcher to reduce the amount of samples we are touching, and so on. Cool, so let me show you before we continue. Let me see if I can. I have a simple demo running. It's available on the project repository. You can just run it on your own computer. So first thing we have, this is the home page from the project. This is the overview. What you have here is like an overall healthiness from your backend system, okay? You have the distribution about like your query types between instant and range queries, the average duration, your success and error rates. And from this very first row, you can already decide if you need to drill down and looking for specific problems that we will later see how we can find them. The second row, you have like your query time range distribution. Like you can understand how your users are looking, how far in the past they are looking for your data. So if you're running Thanos or Cortex, eventually you might need to understand like how long you need to store your data in your bucket storage, okay? Of course, the reasoning behind that is more than just looking how your users is looking on that, okay? But this start to giving you some like sneak peek on, okay, people is not looking for more than 90 days or more than 1 year. So maybe we don't need like 3 years of data, you know, we can just cut storage. Although object storage, like it's pretty cheap in terms of like storage costs, it's always nice saving some resources here. So you can just drill down and see the distribution on stats code, okay, client errors, server errors. We have the query latents, the P99, the P95 and the average, and the same for throughput and errors, okay? And this is the overall overview. So getting back to slides, the troubleshoot workflow should be like looking to the system healthiness, and this gives you an overall idea, okay? Then you can drill down to fingerprints, and I will show you right now the next screen. And you can sort and see the detail. So getting back to the demo, let me just make sure this is still running. We have another page, which is the queries page, okay? So Whenever we're ingesting a PromQL a query, we are creating a fingerprint for the expression. So we remove all the, we encode the label, the entire expression, and we get a unique identifier for that expression, okay? What you're doing is like, we're basically sorting all the label matchers to make sure that even if you run the same expression, but changing the order of the labels, you will end up with the same fingerprint. Because it doesn't really matter if you're changing like first container and later instance and another moment the other way around, it's the same expression. So we create a unique identifier for each expression, and we store that, and then we can see a data table like that. Like, this is very weird PromQLs, because I'm just using PromQL Smith, which is a project that can generate random PromQL based on your available series. But you can see those kind of things, like their usage, and we can see the amount of executions, average duration, error rate, and peak samples for each single fingerprint, okay? So you can just like look in your overall system, you see, for example, some errors here, and you see it's high error or high latency, and you can drill down to the matrix, to the queries page, and you can look sorting for like high latency or high error rate or whatever. And we can look what it's doing, okay? So this is the same view that we have on the home page, but now I'm focused on the fingerprint, on the single query execution. So we can see the PromQL expression here, like if it was an instant or query type. Eventually people can run the same expression, but sometimes using instant, other time using range queries, okay? Also, how far in the past people is looking on this query, and some insights. Later, you can just switch to the executions if you need to look in a single execution specifically. In this one, we only have one. But imagine that you have some of them succeeding, other of them like failing. You can just say, okay, what is the partner, what is the issue with the failing one? It's an instant query or a range query? It's a range query. What is how far in the past is this range query that's failing from the one that's succeeding? You know, you can start answering those kind of questions. Later, we can enrich this with more information like, oh, what is the user agent doing this query, okay? And you can like approach specifically that user agent. So back into slides. So overview, system healthiness. You spot the issue that you want to find. You drill down to your query fingerprints, sort to find your why. So different sortings tell you a different history. You find the details by looking into the fingerprint execution context, okay? And this is nice. This has already answered these kind of questions for us, like what is the expression, how often the expression is running, how heavy is this expression? Is something that is happening once in an hour, every 2 minutes. You can like kind of spotlight if it's an automation running, if it's a dashboard, a freshing interval, all those things, okay? But what if we knew where every metric is used? Because we already have all the data from the queries, right? So if you have Grafana and if you have other clients per se or any CLIs doing queries to the same entry point, you know all the data. But you don't know where this data is being used. You don't know if it's in a dashboard, on a recording rule, on an alerting rule. So we just decided to try to capture that information and correlate with the information that we already have. And again, last year was a very nice conference, by the way. Augustin from the Perses team just had an idea on creating a Go program that can identify where metrics is being used. It's a Go program that you can run, and it will inspect your Prometheus compatible backend, Grafana or Perses, and you can also extend to other sources of where you might be using metrics. And it gives you information where each metric is being used. And what we were looking at, it's this metrics usage project that is now under the Perses organization, can post the results of that evaluation into a file system or posting the results to an HTTP API. So perfect for Prom Analytics because we just need to expose an endpoint that respects the contract that metrics usage is expecting. And we can ingest the usage events through our data store. And this looks like this. Matrix usage is looking to Perses and Prometheus, looking for dashboards, alerting rules, and recording rules. Computing all the usage, like it's getting all the metrics from Prometheus and later intersecting the metrics, the existing metrics with the existing resources and see where it's used and not used. And it's pushing the usage events into an HTTP API, in this case, Prom Analytics. So let's see what we can see right now with that. We have another page here with what we call metrics catalog. So metrics catalog is just based, it's an async background on Prom Analytics, getting all the existing metrics from the upstream service that you configure. And then we can ingest, since we are ingesting all the usage events, we can later create this kind of visualization, like all the metrics and where each one of those metrics is being used, alerts, dashboards, recording rules, or queries, okay? So we can just, for example, look for one. I don't know, maybe Prom. I think I have one here. Let me see if this one's being used. Prometheus query. You know, live demo is hard. But anyway, I would like to show you something. Yeah, this one. This one, we can just drill down into the metric itself, and we can see how many series it has, how many alerts is using that query, that metric, I mean. So one alert, one of one, this is only for the demo, one dashboard and one recording rule. We can see how many queries on your entire monitoring system is using that single metric, and the success rate and error rate for the queries being executed with that. Some other information, okay, and query latest and so on. So some nice insights that you can get from queries using that metric. You can later see what are the producers for that metric, or basically the jobs, okay, in Prometheus. So in this context, it's just Prometheus, but imagine you have, I don't know, HTTP requests total. It will probably be produced by many different systems on your platform, and you can understand like the amount of series between each one of the producers. This is something that you can also get from plain Prometheus, okay? You could just need to write some PromQL, not big deal. And the other one, it's usage. So we know every query, every alert, every recording rule, and every dashboard where this metric is being used. And you also know all the metrics that's not being used on your platform. So you can start doing answering questions like, is this metric not being used by anyone? Can I drop that? Is this metric, I need to change a label right now, you know? And if I change a label, what are the resources that will be impacted if I remove that label? This is the kind of questions that we can answer that now we have that. So getting back to slides. So what is next for this project? I mean, we have a lot of, like everything that I show you right now is still on top of that very simple scheme from the beginning. So we're not enriching much more beyond, like besides the data we are getting from matrix usage. So it's nice to see that with a very tiny scheme, you can get a lot of useful and like insights that can be used as data to supporting your decision. So later, this project is like, I want to improve like a lot of user experience because I think this is like, the data is very useful yet, but maybe we need to improve how we present that information for the users, okay? And maybe be more, I don't know, ambitious because we have context about like how users are using your Prometheus metrics. You know how it's being used on dashboards, on records, on alerting, on recording rules, how they are doing ad hoc queries. So we basically know how people are using the data. So maybe we can start providing some recommendations. Like if you're always using a metric with a like specific aggregation, why you need to store all those labels and not drop all the other labels that you don't really need then, you know? Or maybe you have 3 different queries, but they can be, we can like give some sort of recommendation that instead you have 2 different queries, you have a single one that will fit all your user cases, and you can use it in a recording rule or do other kind of aggregations, you know. And also, I've been discussing during these days on the conference, like also this proxy could eventually evolve on a proxy not only for query, but for remoting writing as well. Because if we have information about unused metrics, we can just decide in runtime if you want to drop the unused data or not. And you can just stop sending garbage for your backend, you know, if you're not using. Of course, this is like something that we need to explore, because how you make sure that like you need this data later, how you can use, you know, but it's something doable, and with user permission, they can just do that. So that's it from my side.
Awesome. Questions?
Hello. Hi. You said that this product can help us to protect ourselves from, example, too long queries that, I don't know, query for high cardinality or something. Is there some metric that we can use to alert ourselves if there are, I don't know, too many queries from a dashboard or something like this? Or is it just exploratory?
It's a good question. Like at the moment, I don't think there is any specific query that gives you, oh, this fingerprint is being executed too often, because, like, first, because every fingerprint later will count as another high cardinality data on your metrics backend. So this is one of the reasons not exposing. It could be exposed eventually. We don't have any limits in place, so it's basically collecting sites. Usually, if you're running other backends like Prometheus and Thanos, you have limits configuration for queries execution, so you can configure how many samples one single query will touch, how many parallel queries you will run. So the project is just leveraging the limits for, like, handovering the limits right now for the backend and just focus on giving the insights, you know.
Hi. Yeah.
Hello.
Thanks. Great talk. I have 2 questions regarding source of the queries. You are using the metrics source, like the component from Persis you showed. But I'm wondering, did you consider using, for example, a user agent or some HTTP headers for grouping of the source? Because, you know, there are sources of queries which you won't be able to integrate to the metrics finder, or sorry, I don't remember the name.
Yeah, that's a good one. Actually, there is an issue on the repo to allow us to store specific user agents that we can later show them on the UI. So this is something that's mapped, not developed yet, but would love to get this. I think the mic don't like questions, you know.
Working. Just quick question about multi-tenancy support. I know Thanos and Mimir do have multi-tenancy. Do you plan adding something about it to the proxy, or?
I mean, maybe if I mean, it might be very simplist, but if you allow header extractions, we can just extract a tenant header from Thanos and from, like. It's more complex because this is like you need to put this like after your Thanos query front end, for example, and before your Thanos query. So we can get in the tenant ID from Thanos, but like, yeah, worth a discussion.
Yeah.
Where?
I have a question. My short question is, how basically does it scale? I mean, to elaborate, we in Amadeus really are interested to use your tool because it's really giving things that we want to observe and we don't manage to, or partially thanks to the metrics usage. And I'm wondering if I should just put your proxy in front of our big Thanos that handle a lot of Thanos behind the scene and a lot of Prometheus. I think we have hundreds of Thanos and thousands of Prometheus behind. So if we do this, will it really scale, or do we have a way to put the proxy in front of each Thanos query and like make them aggregate in one UI?
Yeah, that's a good question. I mean, scale is very subjective, you know, like everyone has its own definition of scale. What I can tell you with few characteristics. This is a stateless service, so you can just spin up as many replicas as you need. You can, for example, choose like one instance per Thanos and pointing all of them to the same data store and later access the UI for a single instance, you know, it will work. Since we are like persisting all the analytic data in background, you can like scaling vertically, but increase the amount of Go routines, computing resources, and so on. You can also run multiple replicas. I'm running that in production like nowadays, and we are handling like 40K, 50K PromQL queries per second. It's like pretty tiny, I think less than 1 GB per memory per instance. So I would say that, yeah, it should handle pretty fine.
Okay, so you would advise me to put a proxy in front of each instance instead of the big one, actually?
Like my case, I'm running, it's like I have one source of data and then I have proxy as a sidecar on each one. But
yeah, okay. I will try. Actually, this is very interesting. Thank you.
Thank you.
One last question.
Hi, nice talk. Thanks.
Thank you.
I'm pretty sure I missed something on the architecture, but I was curious why what's the reasoning behind the decision of building a UI on this project? I mean, the proxy, as far as I understand, stores data on some data store. So why is this not a data source for Perseus or Grafana? And then instead of giving a UI, you provide dashboards that people can install on their, and feed back into the landscape that we already use.
Good question. 2 reasons. One is like, even or Grafana or Perseus, to get this kind of drill down between these different UIs, you probably need to build a plugin, because you can have one dashboard with the overall system and then another dashboard where you can have some variables and so on. But like, I don't know, I don't think it's too fluid, and you need to maintain 2 different plugins. Although this is something that me and Augustin, we already discussed it, like maybe might be useful in the future, provide some plugin for Perseus and they can just see everything on the same place. The second one, it's like just easier to experiment with the data, It's just a React application, so aimed on Go binary. It's easier to explore, easily to change, mainly that. Cool. Thank you.
Can everybody who has a free seat next to them raise their hand again? Because I think if the people are sitting down there, can you please move to wherever there's seats available, so we're not blocking the entrance and especially emergency exits. Thank you. Yeah, I think we got plenty in the back still. It's fine. All right, cool. All right, yeah. Next talk is already up and running. Stage is yours.
Thank you. Hello, everyone. So we are going to talk about OpenTelemetry developments that have taken place in Prometheus since last year's PromCon. I'm Arve Knudsen. I'm a software engineer at Grafana Labs, where I work on Grafana Mimir.
And I'm Owen Williams. I'm also at Grafana in the databases upstream team working on OpenTelemetry and Prometheus.
Yes. So basically, for a recap, at last year's PromCon, which took place in Berlin, we announced general availability of the OpenTelemetry ingestion endpoint in Prometheus. And in the meantime, we have been very busy adding improvements to Prometheus' support for the OpenTelemetry standard, both in terms of functionality and also OpenTelemetry protocol ingestion performance. This is not the end, of course, to the improvements. There's plenty more to come, many of which are already in progress.
Mm-hmm.
And so we have divided this talk into sections. The first section is dedicated to the functional improvements, which have gone into Prometheus's OpenTelemetry ingestion.
Yeah, so as we heard yesterday, there's still a lot of rough edges around integrating OpenTelemetry with Prometheus, and we're sort of working on those things one at a time and trying to smooth the experience. And so one major sort of piece of work in the past year has been the ability to allow for optionally untranslated metric and label names when ingesting into Prometheus. So this is for often, users who are used to OpenTelemetry and the semantic conventions, and they want to have those original names show up in Prometheus when they ingest using the OTLP endpoint. So previously, when doing the ingestion, dots would always be converted to underscores, and suffixes would always be added as per sort of the Prometheus style and specification. That is still the default. There's no plans to change that from the default. But for those users who know what they're doing and want those untranslated names, they can set the translation strategy option for the new no translation option. This is since Prometheus 3.4. So no character conversion is performed. Everything just passes through unchanged. As mentioned in the previous talk, this can cause problems with type and unit. If you have some sort of latency metric, one coming from one system that's in seconds and another coming from another system that's in milliseconds, those could collide. So we also strongly recommend that operators turn on the type and unit labels in order to prevent those collisions. And that's since version 3.6. There are two other translation options to make the grid of 4. Those are not very recommended. Users, some people need them. One of them is for compatibility with the current option in Mimir, but generally those are highly discouraged. You either want the Prometheus version or the OpenTelemetry version, and not some sort of weird mangling of the two.
Right, so another feature that was added since version 3.6.0 of Prometheus is promoting of OpenTelemetry scope metadata to metric labels. So the background here is that scope metadata is considered to be identifying in the OTL model, and it was not too long ago made a requirement in the OpenTelemetry to Prometheus translation spec that these scope metadata attributes, they should also be included as metric labels, because then they are part of the metric identity. So so we added this functionality to Prometheus, but it is disabled by default for backwards compatibility, even though it is recommended to enable through the config parameter otlp.promote_scope metadata. When OTL scope metadata attributes are promoted to labels, these labels have the prefix OTL_scope_. And when the functionality is enabled, there will be 3 standard scope labels which you can expect, which are OTL scope name, OTL scope version, OTL scope schema URL, but then there can be a number of other labels, kind of depending on which OTL scope attributes are present. And a bug fix that was introduced in version 3.1.0 of Prometheus is something that had simply been overlooked, which is that OpenTelemetry metric metadata was not converted into Prometheus equivalent, but that is now in place.
So another thing that we've worked on, and something that Fiona talked about yesterday, is initial support for delta temporality metrics. So this is going to be pretty redundant to what she said in much more complete terms. But yeah, since version 3.4, it's possible to ingest delta metrics over OTLP without using the delta to cumulative converter. They act like gauges, although they show up as an unknown counter type. And this is only the first step towards full delta support because, as Fiona talked about, you need to do extra work in your queries in order to sum up the deltas and then perform the operations you normally would on regular counters. So, rate and increase don't work by default. You need a rate over time or a sum over time. And then this is toggled with a feature flag as opposed to a configuration flag, the OTLP native delta ingestion flag.
And here's a feature I'm quite fond of myself, which is that Prometheus is now able to convert non-exponential OpenTelemetry histograms to native histograms with custom buckets. So the context is that when it comes to exponential OTL histograms, they are converted to native histograms, which is the preferred format. Whereas by default, when Prometheus receives non-exponential histograms over OTLP, they will be converted to so-called classic Prometheus histograms, which are really an emulation of histograms. So in effect, it means that each non-exponential histograms entering Prometheus via OTLP is translated into multiple samples in Prometheus, one per classic histogram time series. So this is not ideal. So since version 3.4.0, Prometheus has the ability to convert the non-exponential OpenTelemetry histograms to native histograms with custom buckets, so-called. This is again off by default for backwards compatibility, but the huge benefit is that when this is enabled, the OTL data points are converted to like in a one-to-one correspondence to Prometheus samples, and that can make a big difference because it can prevent basically overloading the server, depending on how many OTL data points the client sends to Prometheus. In the meantime, due to customer demand, really, customer demand and internal, let's say, use cases demand at Grafana Labs, we have added the ability to promote also the so-called identifying OTL resource attributes to, well, no, not to promote, sorry, to keep rather the identifying resource attributes to keep them as labels on the target info metric, because historically and still by default, these identifying resource attributes, service.name, service.namespace, service instance ID, they have only been translated to the job and instance labels on target info, but the attributes are not kept as let's say, rawly translated labels on target info. But some customers they wanted to see labels corresponding directly to these resource attributes as well on target info. And there are also some internal use cases where this comes in handy. So that has been introduced in version 3.1.0 of Prometheus. And it's enabled with OTLP.keep identifying resource attributes. And here we are arriving at the performance improvement section of our talk, because while not yet released, there has been a significant, shall we say, rewrite of the OTLP endpoint code in Prometheus. And what it means in practice is that there's no longer this intermediary translation step of OTLP write requests to Prometheus remote write requests. Instead, Prometheus takes the OTLP write request and just performs corresponding calls to the so-called storage appender. And this was done in collaboration between David Ashpole from Google and George Kajcevic from Grafana Labs. And that was a stellar effort, which led to amazing performance improvements. So according to benchmarking, on average, we see a 36% drop in CPU utilization, 38% drop in memory utilization, and a 19% drop in memory allocations. That's really fantastic.
Yeah, so that's the collection of things that we've been working on, but there's still a lot to do to make the OpenTelemetry experience in Prometheus better. So there's sort of a lot that we're looking ahead to PromCon 2026 that we'd like to work on and hopefully finish, although it's a pretty ambitious list of items. In general, just improved maturity and optimization. There's still a lot of low-hanging fruit for performance. And maturity here refers specifically to getting things out of sort of beta level and getting it really stable. We definitely want full support for delta temporality. This is working on Bartek and Fiona's initial work of start time calculation. This is something where we keep having meetings where we look at the theory and it's like, this should just work. And then we'll have to actually do it and see, what are the performance implications? Are there edge cases? Do we have to worry about resets and things? But that's looking really promising. There's also existing work on resource attribute UX. This is something where there is not quite the same logical arrangement in Prometheus. And so that'll tie into the namespace metrics and labels I'll mention in a second. So yeah, trying to make that more usable for people when they're doing their queries to get at resource attributes. One of the biggest problems with the name translation is the question of label and name migration, metric and label and name migration. What happens when you've been sending data that has underscores and suffixes and then you change to having the native OTel names? That's a huge amount of metric name churn. How do you deal with that? And it's also a problem, even if you start a new system with sort of native OTel, all of the stock dashboards and alerts and sort of community assets out there were designed for the Prometheus translation of the names. How do you handle that situation? It should be possible to write tools to rewrite dashboards. And then there's the work that Bartek was started for the migration schema that OTel has, which would be sort of a query time way of doing the lookup so that it would just transparently know which names you wanted. So there's still a lot of work to do there, and that's sort of a major question to make it a much more smooth experience for people getting onto OTel names with Prometheus. As for, namespace metrics and labels, resource attributes are part of this, and then also OTel entities are starting to come in. We're losing this idea that you have a single list of labels. You're starting to get groupings of labels. You know, you've got resource attribute dot whatever, or you've got some or other sort of categorization. And that will require, you know, work in the code, but then also in all of the query for, PromQL and things like that. How do you work that into the language in a way that's sort of natural and doesn't require a lot of text and that sort of thing? And then we're also looking at doing improvements on the Prometheus receiver, just making things better. So I wanted to do a short demo. This is a project called OpenTelemetry Demo. It is a little fake telescope buying platform that generates traffic. It is a Docker image and a Kubernetes setup that you can use, and it sort of demonstrates a full OpenTelemetry stack. This is something that Cyril's been working really hard on, and is just a great way to test out the full pipeline. And what I wanted to do for this demo was, you know, what if I flip the switch that says, okay, let's use no translation instead of Prometheus names, and what do you get? Now, from the user perspective, it's not very different. It is a bunch of panels, and that's what we would expect to see. And you really only notice the difference when you go in to edit the panels, and I have picked the wrong one. Let's try this one. That we are using the native OTel metric names for most of the queries involved. The process to rewrite these dashboards, you know, there's many dozens of queries, was partially automated. To begin with, I used Cursor and said, please rewrite all these dashboards. It was actually somewhat successful. There's not a lot of existing material on the internet talking about this new format for Prometheus for PromQL queries. So I kind of needed to hit it over the head, say, no, it goes inside the braces. You know, it had just as many complaints as everybody else has had. But then there's other issues where some things, you know, not every underscore was a dot. You know, often like a duration, it'll be something dot duration underscore count. And so you have to have a good mapping between the two systems. But it, you know, given the list of OTel metrics, it should be, you know, it's trivially possible to create what the Prometheus version was. Going backwards is the trickier part. So this and then also in Grafana, this totally works in the metric browser. You can select query, you know, select metrics, do queries. It understands how to format. This is a good example of get underscore cart latency underscore sum, but it just sort of works. And this is, you know, demonstrating that we've got that working. And then another question that's come up is, how does this work in alerting rules? Alert templates use the Go templating language. Usually use dot whatever. When you have a quoted item, the language says that you say index, and then the object, and then the thing that you're accessing inside that object. And it just works. It formats the strings just fine. I think a lot of this also came up yesterday, a lot of the difficulty in the move from underscores to full UTF-8 is it is a change in the logical idea of what a metric name is. And I think this comes, PromQL thinks of a metric name as an identifier, like a function name or that sort of thing in a programming language. But once you start allowing all of UTF-8, then it's really a parameter on something. It is more like a key in a map where you have a quoted selector. And I think that's the source of a lot of these rough edges. It's a big change in the way that you think about metric names. Whether or not you agree with that change is, there's, as we've said, the defaults are all staying towards Prometheus style, but OpenTelemetry is a big train that is not stopping, and this is the way that they sort of decided to do it. And I think, supporting that community as best we can is the way to keep Prometheus in use by lots of people and staying popular, which is, I think, what we all want. Yeah, that's it.
Thank you. One question first by me. Are you aware of any current efforts around like integrating back service discovery into up metric for proper target health monitoring? So I know that the things that are supposed to be sending me data are actually up and sending me data.
Not specifically.
Okay.
Yeah.
Because I heard some ideas being floated around some years back to have some synthetic up metric again, but I never heard more about it. So maybe you had, but yeah. Okay.
We wrote at ZineDoc, but never got time to really implement it.
Okay.
I think that's patches welcome, contributors invited.
Okay. Who else? I saw a raised hand there. I have it.
No, it's not.
Needs to be green.
Now it's green.
Yeah.
I definitely pushed the button. In your vision, like Prometheus 4, 5, what is the out-of-the-box experience for OTel users?
Personally, I think this is Prometheus. And even though there is an OTel endpoint, I think the default should be the Prometheus experience. And I think, because that's the thing that's going to work the best. That's the way that this community has decided to arrange things. I would like there to be basically one flag that says, I wanted an OTel mode. And then all the sort of things that we've talked about, like the deltas and the type and unit labels, that stuff would all sort of turn on with that one flag. Right now, it's all these things that you have to kind of know to do, and that's awkward. But I mean, this is what we see. And I think even when people have done online polls, there's this like 50-50 split with this like, I want the Prometheus thing. And then there's people who are like, I'm working at a big company. I know OTel. My company is using, I don't even know, they don't even know about Grafana Cloud. They just know that their internal observability team has given them this platform, and they just want to say, this is my custom metric. It's got some dots in it. I just want to type that. So I think we can serve both those communities effectively without, I don't think you need to sacrifice anything on either side.
Hey, hello, here. I have a question because in the metrics pipeline, of course, the Prometheus server is not the only place where you could do the translation to Prometheus. You could also have an OpenTelemetry collector that does the translation and then forwards data. So I'm wondering how the collaboration there works. Is there a shared code that the OpenTelemetry collector uses and Prometheus, or like how does that work?
There is now. There are 4 go ways of getting OTel into Prometheus. Is the OTel endpoint in Prometheus, is the Prometheus collector, the OTel collector, Prometheus receiver, exporter. There's the OTel SDK exporter, and then there's the collector remote write exporter. They all had different implementations of the translation code. A lot of hard work from Artur and me has now unified that into the OTLP translator package that's in Prometheus. it is one piece of code, but it also has a bunch of flags on it to try to not break everybody's metrics, is different, trying to maintain the way things happen. And this, I'm sorry if I've ever broken any of your metrics, it happens, based on the differences in those packages. But now they're unified, and they will be more unified going forward. Yeah.
Just to add up to that, we will eventually need to break, because if everybody's doing differently and we want to unify, we created a library, we made it, we tried our best to make it backwards compatible with everybody, but our plan is to unify. So eventually we'll release the OTLP translator 2.0, we'll remove all those flags, and people will need to decide how to do this unification.
One example is we had a customer that's like, oh, we were sending from hotel collector, and now we're sending to the endpoint, and our metrics broke. And it's like, yes, because the defaults on both of them were different. So you have to know to flip the right flag when you do that, and we want to get rid of that problem.
Hey, so yeah, interesting talk, thank you. On your slide about the deltas, I think I noticed one new function, rate over time. And I see it's not yet in 3.7, not as even experimental. So is that something planned? Can you comment? Rate over time.
Rate over time. Maybe that's a typo on the slide, because I know we usually use, usually use some over. I know some over time is there. It could be a typo.
Okay. Anyway.
Anyone else? By the way, we again shifted by 15 minutes. So again, lunch is, when is it? 13:30. So we are like good on time. No more questions? All right. Then we'll have Andre telling us about UX research on... Oh yeah, thank you. Sorry. Andre telling us about his UX research on hotel resource attributes.
That sounds good. So does it work? Does the microphone work? Yeah, wonderful. Nope. Oh, here it goes. Alrighty. Can you hear me? Can you hear me? Everything okay? Closer? Okay, thank you. Now, is it better? No? Okay. Speak up. I'll try. It's fine. Okay, good. So, hi everyone. Thanks a lot for having me, or us actually. My name is Andre, and I'll be speaking today about how should open telemetry attributes, or how could open telemetry attributes be handled, resource attributes be handled in Prometheus. So, yeah, I just now have to find the cursor. Nice. So this is a presentation of an outcome of Linux Foundation mentorship project. So there are 4 of us involved. The main person, most important one, and who should get the main spotlight today is Victoria Nduka. Unfortunately, she's not able to be here today, so I will play her part of a presentation as a recording. Yeah. So Victoria was the mentee in this project, and then there were 3 of us mentors. Arthur, you all know Arthur. Arthur is a Prometheus maintainer, and also Grafana software engineer. Then there is Amy, also from Grafana, a product designer, and me from Grafana, user researcher. Some quick background. Why did we decide to look into this topic? Arthur was talking about this, I think last year at KubeCon, and also he was getting some indirect feedback overall from different people that resource attributes from OpenTelemetry are like the way how they are handled in Prometheus can be problematic for some users. So when we were coming up with the topic for the mentorship, we decided to look into this problem. And before I move forward, I know that resource attributes were mentioned many times already, but I'll try to explain for folks who might not know how they work. So resource attributes are basically something like Prometheus labels that are sent from, like resource attributes are parameters of resources in OTel, and when they are stored in Prometheus, they are basically Prometheus labels. So that's quite clear. When it becomes problematic is when we talk about the instrumentation. So with Prometheus, you have to instrument things manually, and then there is, you kind of understand what are you storing and what are you sending. With OpenTelemetry and with the automatic instrumentation, people can start getting a whole lot of attributes that they might see for the first time, and it might be causing problems. And yeah, in this project, we wanted to cover three research goals. First one was to understand how engineers currently handle OpenTelemetry resource attributes in Prometheus. Then what are the pain points that they are having and with the current approach. And the last thing is what are their expectations and what could the Prometheus and OpenTelemetry community do to make their lives easier. And now I will give words to Victoria. And hopefully it will work. Okay. Bust. Sorry?
Maybe it's down here when you look at the left behind the slide.
Behind the slide.
Maybe you can just
I'm a user experience designer, learning to become a cloud engineer.
So let me
you can learn more about me in the work on my introduced perfection of the presentation. Thank you, Andrew, perfection of the presentation. I assume Andre already introduced me at the beginning, but I'm just going to briefly introduce myself. I am Victoria Andruka. I'm a user experience designer, learning to become a cloud engineer. You can learn more about me and my work on my website, victoriaandruka.com. I also want to take this time to say that I am bummed that I'm not able to present this talk in person. Getting a visa proved to be harder than I thought, so here we are. Now to the research. We started off speaking to stakeholders from both sides of the project so that we understand the historical context and evolution of both projects involved, and to gauge how much change each project was open to based on the outcomes of this research. And we spoke to a couple of interesting folks I'm sure some of them are at this event. Hi, again. On the Prometheus side, we spoke to Bjorn, Julius, and Richie. Thanks again for indulging us. And on the hotel side, we had Austin, Josh, and Jurasi. So I will talk more about what we learned from these interviews later on in this talk. But for now, the actual user experiences. We heard from 70 users in total, 7 interviewees, and 63 survey respondents about their experience working with OTLP resource attributes in Prometheus. The interviews helped us to explore the user experiences and perspectives in detail, and the survey allowed us to identify some of the trends and patterns that we observed in the interviews. So what did we learn from these conversations? Now, after analyzing the data and information we got from the interviews and the survey, we learned some really interesting things. As Andre has already mentioned, one of our research goals is or was to understand how engineers currently use OpenTelemetry resource attributes in Prometheus. So what does the actual workflow look like? And what we found is that there are 4 main workflows that really stood out.
Now, for a moment, because in the best spirit and tradition of live video presentations and yeah, any kind of live demos, just before this talk, like literally 10 or 15 minutes ago, we learned that from out of those 4 approaches, actually one of them is not working. Arf was the person who explained to us. We did this. We got this wrong when talking to the users, but the rest should be okay. So yeah, thanks Arf. We actually published it in a blog, like 3 different blog posts. We never got any feedback from anyone before, but yeah, now 5 minutes before the presentation, that's the right time. So yeah, but yeah, that's great. Thanks for the feedback. So, and I'll now let Victoria continue.
Attribute promotion is another approach, and a more selective approach compared to the complete mapping that we earlier discussed. So instead of converting everything, most users choose specific resource attributes, and it's usually the ones that they know they will need for pairing and filtering, and they promote those ones to be converted to Prometheus labels. Now, the problem with this is that you have to decide beforehand or upfront what you want to promote, and changes are resource intensive. We talk about the challenges with this approach later on. So with this approach, users have to be really intentional and strategic with what becomes label, because they are trying to balance having the metadata that they need while also avoiding some of the overhead that comes with having to make labels. And then there's the target info approach. It's quite different from the other approaches that we discussed. With target info, users store their resource attributes as target metadata. So instead of all those resource attributes coming from OpenTelemetry that you ordinarily would have converted or transferred to the meters as labels, you now have them in a single metric called the target info. So now when you do, and then your actual metrics are just clean. So when you query with resource attributes, you join the target info metric with the actual metrics using Prometheus, using PromCon EU. So it sounds, or it is actually a more efficient approach in many ways, because the metadata is stored once per target, and not repeated across every time series. And then users need to query with that information. Like when users need to query with that information, you just join it at the query time using PromCon EU. So you get access to the resource attribute data where you need it, but without the cardinality explosion that can come from adding labels to every. But from our conversation with users, this seems to be the least preferred approach because of the complex join syntax that most users struggle with. Then manual attribute injection, or what I call manual attribute injection. So some users that interviewed, they mentioned that what they usually do is they add resource attributes label in resource level attributes as part of the Prometheus scrape target definition. So rather than relying on the resource attributes that come directly from OpenTelemetry. So these are the 4 main workflows that we identified. And what's interesting is that each of these approaches exists because users are trying to solve different problems or work within different constraints, and that's specific to their circumstance or use case. Yeah, like I mentioned, BN shared this talk, other resource attributes from the Prometheus perspective. It's a really insightful read, and I think it's worth mentioning. He does a good job of explaining the various approaches to having resource attributes that I've just discussed, and addresses the misconceptions around cardinality explosion. So if you can stand the QR code on the screen to take you to the doc and share your thoughts here as a comment. So we've seen the approaches that users take to handle their resource attributes coming from OTF. And by now it should already be obvious that each approach there, that for each approach, there seems to be a drawback. So in the survey we conducted started, we asked users how satisfied are they or were they with the current distribution between authorities, attributes, and polluters. And as you can see from the charts, the majority of people, that's about 43%, rated their satisfaction right in the middle. That's at a 3. This suggests that while the integration isn't terrible, it is also not great. People are kind of neutral about their stand. What's also more telling is that we see more dissatisfaction than satisfaction. So if you look at the lower end, that's to the left of the charts or the graph, we have about 30% of respondents rating it 1 or 2, meaning that they are not happy with how things are currently. On the flip side, only about 27% rated it 4 or 5, indicating that they are satisfied. So when we add this all up, roughly a third of the users are frustrated with the current state of integration, while less than a third are actually happy with it. So that middle group, the large bar, they are the ones using the fence, probably getting by, but hoping that or wishing that things look better. It this really highlights that there's significant room for improvements in how these two systems work together. So now let's talk about the pain points, because our second research goal was to identify challenges users are facing with these workflows. And we found several significant issues. One of the biggest pain points is around complex joins. When users rely on target info to assess their resource attributes, they have to write complex queries with joins. And a sizable percentage of our respondents told us that they find these queries challenging. Writing these queries, like the joins are a lot more complexity to what should sometimes be straightforward queries, as you can see in the charts. Just about 8% of the respondents with complex joins as not challenging. So almost 90%. Almost 90% rated as challenging. Another main pain points we identified is around manually managing attributes promotion. Some of the challenges users pointed out with this is that, one, they have to decide upfront which attributes to promote. They need to predict what they will need for pairing before they actually start pairing, which isn't always straightforward, especially with complex evolving systems. Second, any changes to the promotion is resource intensive. So you can't just flip a switch and everything works. It often requires configuration changes on coordination across teams. It can be a hassle. And on top of that, and this one is particularly tricky, new attributes only affect new data. So when you add new attributes to your promotion list, they only apply to the new data going forward. Your historical data does not have those attributes as leaders, which creates inconsistency in your time series. So you end up with queries that work differently depending on whether you're looking at recent data or historical data. And that can be really frustrating when you're trying to troubleshoot issues or analyze trends over time. And the third pain point that came up repeatedly is documentation gaps. A majority of users we surveyed reported challenges with the current documentation around resource attributes and how they work with Prometheus. Looking at the charts here, you can see that about 44%, the actual number is 25 respondents. They found documentation gaps very challenging, and the same number rated as slightly challenging. So that's about 80% of respondents saying that they find they have an issue with the docs. That is a significant number, and it tells us that people are struggling to find clear guidance on best practices and implementation details and all that stuff. So this sentiment about the docs being a problem was equally reinforced in our interviews as well. Participants specifically mentioned wanting better documentation and resource attributes. So, and this complaint about documentation is not just specific to Prometheus. The hotel community have some work to do also with that. And now our third research goal was to understand user expectations. How do people actually expect resource attributes to work in Prometheus? And what we found here is really enlightening because it revealed some fundamental mismatches between user mental models and how things currently work. We discovered that users fundamentally do not distinguish between resource attributes and machine attributes. They feel at the same thing. We also found that users expect resource attributes to be directly queryable without any special syntax. So the joins are complex, they don't want to do that. But currently the joins make actions, simple actions, a lot more complicated than the users intuitively expect. And it's a big part of why you're seeing so much friction. Users also want flexibility. They ideally would rather not to have to be confronted with the dilemma of choosing which resource attributes to promote. They would prefer if Prometheus had a more efficient way of deciding for them. So some kind of mechanism that figures out what is relevant to the user to promote and what is not relevant to not promote based on their actual usage patterns. And finally, users expect to easily filter and aggregate their metrics by resource attributes. So in the survey, 76 of respondents rated filtering by resource attributes as very important, and 68% rated it aggregation based on resource attributes also as very important. So we are talking about core fundamental use cases here. These are everyday operations that people expect to be straightforward, but the current workflows make them kind of harder than it should be. Right. I said I was going to talk about the stakeholder strategies later on, so the time has finally come for that. And from my conversation with the stakeholders, we learned a couple of things. One is that Prometheus and Hotel were built on fundamentally different philosophical and technical foundations. Hotel comes from the angle of we need to handle everything, metrics, logs, traces, all of it. We can't predict what people need, so let's just capture it all and let them figure it out later. Prometheus, on the other hand, is more like, let's be really good at one thing, metrics, time series metrics. Let's be efficient. So naturally, there was bound to be mismatches when the user base began to intersect. We also learned that the projects didn't communicate with each other from the beginning, and this lack of early collaboration may have led to the integration issues that exist today. But on the bright side, the general support for improving UX around resource attributes. Both project stakeholders understand that there is need for the two communities to collaborate if things are to work well for the users. But there is a caveat. Prometheus stakeholders express a strong preference for Prometheus to learn focus on metrics, and any changes to the project should not alienate Prometheus native users, should not alienate the existing Prometheus users who use just Prometheus for their observability needs. So, bottom line is that there is a recognition that both systems serve important but different needs, and both projects just need to work together and find the right balance. At this point, I am going to hand over to Andre to cover the recommendations that we have for both communities. Thanks again for having me, and I hope you enjoy the rest of the events. Andre, over to you.
Okay, so yeah, and now back to me. So I'll just sum up, and especially the recommendations that Victoria already partially mentioned. So the first recommendation is that there are already a bunch of solutions, and I know that they were even mentioned during this event, and it's just about implementing them and making sure they get to Prometheus. We heard about eliminating join complexity through making native resource attributes query support, then speeding up attribute promotion by more intelligent attribute selection with cardinality awareness, and also a couple of concepts that are not yet in Prometheus could help a lot with the resource attributes and the user experience of resource attributes usage. That's the first thing. So that's the product part. Then the second part is a bit different, or the second recommendation. It's about improving documentation on both Prometheus and Hotel. As you could see, Prometheus, we got a lot of feedback about both Prometheus and Hotel documentation, and it seems that there is a lot of potential for improvement. Here, I will talk more about the OpenTelemetry part. So OpenTelemetry also has a way how to more efficiently handle resource attributes, but in their documentation, there is really just one paragraph covering that and not more. So it would be great if it would be expanded. And also related to Bjorn's talk, when he talked about how OpenTelemetry folks explain observability, that it is as if you are looking at the sky through the telescope. So do you know how this functionality around resource attributes is called in OpenTelemetry? No, it's called telescoping. So yeah, Hotel folks use quite ambiguous names sometimes. So there is a lot of space for improvement there for sure. The next thing is a little broader. It's about aligning both of these systems on like more philosophical level. For example, what we heard mostly from the stakeholders is that they see Hotel as since it comes from the traces background compared to Prometheus that is from the metrics background, they see it more as an exploratory tool. So it might be, and they see Hotel metrics and the way how Hotel metrics are structured better for these exploration use cases. So another thing that we would like to recommend is to think about how Prometheus could get better in the exploration use cases. And I would like to mention there's a link to a project that Arthur and Amy are already running with their mentee Anna, where she's working on designing wireframes for exploration use cases in Prometheus. And the last thing, again, as Victoria already mentioned briefly, the most important thing perhaps is the communication, that these communities don't live apart from each other, but they talk to each other and they understand how both system works and they can make them work in a synergy. At the end of the day, it's both of them are CNCF projects, so it would be great if they synergized more. Yeah, I like the word synergy. That's roughly it. Just 2 more slides. LFX mentorship. We would like to give a shout out to this program. All of us mentors, and I'm pretty sure that Victoria as well. We are all very passionate about this. We think it's a great way for CNCF projects or like Linux Foundation projects in general to get new people in and to get some more work done in perhaps a little bit different way. It's great for mentees. There are a lot of benefits, but there are also a lot of benefits for mentors. I would like to highlight those. So you get extra pair of hands, extra folks to work on stuff that maybe there was never like time to work on them. These folks are usually very motivated and very excited to contribute. And last but not least, for many of them, it's not just 3 months of the mentorship and then they are gone, but they continue to contribute to the community even after the mentorship is done. So yeah, we think it's an awesome project. And the last one, Victoria is a good example of a mentee who continues to contribute. So currently, she is helping with Prometheus blog, and she's trying to get it, make it a bit more lively to publish more posts. So I would like to ask you all, like if you have any topic that you would like to write about, please reach out to Victoria, and I'm sure she'll find a way for you to get to the Prometheus blog. And the last thing, Victoria is also looking for a job. So if you have any positions opened, feel free to reach out to her. I'm sure she would be very, very happy So yeah, once again, thank you all very much for having us, and that's it.
Thank you, Victoria and Andre. Questions?
I just wanted to ask whether you're aware of the info PromQL function, because that is actually supposed to make joins with target info easy.
Yeah, I think that was another thing that we discussed just today. Maybe some of the participants mentioned it. I'm not 100% sure, but it's for sure not something that is like widely adopted yet, and we haven't had like a whole lot of feedback about it.
Okay, yeah, because I would kind of be interested in hearing the users' feedback on that, since overwhelmingly found traditional joins very difficult.
Yeah.
I just wanted to add that actually, when it comes to resource attribute promotion, there is actually a second mode where you promote all of them.
Oh, good. So maybe
maybe there was some confusion around that.
Yes, maybe. Yeah, perhaps.
I just wanted to continue the answer. So the research was focused on users, and I think like Prometheus maintainers and Prometheus power users, we all know the info function, but on the user perspective, there is like lack of documentation, is not well advertised, and mostly nobody knew about it. So that was the problem.
Yeah, I guess like that's a good question. How do we raise awareness?
Yeah. Documentation. One of the options, of course.
Yeah. Thanks for the question.
Anyone else? Question? No? Okay. Then a statement.
Yes. Not a question. So as Andre said, we are continuing this research with more mentorships. We're currently working on the wireframes, trying to come up with a new UI idea. No promises that this ever makes to Prometheus, but we are trying. So if you're a if you're a hotel user and you're storing hotel metrics in Prometheus, we would love to get you on board in the workshop. We need only 1 hour of your time. And we are doing another mentorship for tech writers. So if you know any junior tech writers or someone that wants to be a tech writer and wants to contribute to Prometheus, we would love to get help, and you'll even get paid for that.
Thank you. All right, so it should be lunch in 5 minutes. Maybe I don't know, will they already let us in, Gautam? Or nope, Bartek is shaking his head. Okay, but in
So please go for it.
All right, thanks. Just making sure everybody can hear me in the back there. We're good? Right on. Okay. Thanks for having me. I hope everyone's now settled back in from lunch. Welcome to the talk on Prometheus support and agentic AI in OpenSearch. Just a little introduction. My name is Kyle. I'm a senior software engineer at AWS. I've been with the open source observability org for about 5 years now. I was part of the original team who launched Amazon Managed Grafana, and I work closely with the Managed Prometheus teams and OpenTelemetry as well. Now I'm working with the OpenSearch team to bring native Prometheus support and agentic AI into OpenSearch dashboards. Quick survey, show of hands, who here uses OpenSearch or knows about OpenSearch? Okay, quite a few. What about OpenSearch dashboards? A couple, more than I thought. All right, great. So I'll be going through a brief overview of OpenSearch and OpenSearch dashboards first, but then I'll dive into native Prometheus support and observability agents in OpenSearch dashboards. I'll also show a demo. Let's make sure I'm good for time, and leave some time at the end for Q&A. So OpenSearch is an open source distributed search and analytics engine and a project of the Linux Foundation. We have a vibrant and fast growing community of over 3,000 contributors, so if you're interested, please check us out. OpenSearch is being used for search, of course, but quite a large number of our users are also ingesting their logs and traces for observability and security analytics, as well as their vector embeddings for machine learning. The four main components of the project: OpenSearch Core, which is the main search and analytics engine; Data Prepper for ingesting data into your search engine, or search index rather; and the Vector engine, which powers AI features like semantic search, retrieval augmented generation, and dashboards for exploring and visualizing your data. So OpenSearch Dashboards is an open source data visualization and exploration platform for observability and analytics. You can query, visualize your logs and traces, create custom dashboards, do monitoring and alerting. There's also security and analytics and anomaly detection features. Well, the majority of our dashboard users use it for OpenSearch data. You can also connect to external data sources like S3 via the Glue data catalog, and we're working towards adding more like Prometheus, so we can get all metrics, logs, and traces for observability. Just a quick update on Prometheus support. For those interested, the backend plugin implementation is complete and merged. However, the front-end metrics experience is still in progress, but you can look forward to it in a future release. I did really want to demo the native Prometheus support today, but it's still in the works. If you want to discuss more during the Q&A, please do. We really want to hear your feedback and use cases as we continue to work on that. But I do still have some exciting new things to share with you, and how you can still visualize and explore Prometheus metrics and data sources in OpenSearch dashboards without the native plugin support. It's new and experimental with some agentic experiences that we're trying to define through agent-led exploration of metrics, logs, and traces. And we want to get the community's feedback, we really do, and opinions and direction on what I'm about to show you here. So the motivation behind the talk, show of hands again. How many of us here would say you have like an intermediate to advanced level of PromQL knowledge? Quite a few, that's what I expected. So out of you, have you ever been tasked with some kind of business question from someone who doesn't know PromQL to build out a dashboard to explain metrics? Yeah, like how many mobile users logged in last month or something like that? Yes, me too, all the time. So high cardinality metrics are great for this, but PromQL is hard for the average user, some of the people here in PromCon, not all. So how can we lower the barrier entry to beginner and non-technical users to explore their observability data? Keep in mind, these beginners might be experts in other query languages like SQL, but PromQL is just yet another query language for them to learn. And even if you're using the graphical query builder, it's kind of hard to know where to start. So some ways to help new users. First one, query generation. So the ability to transform natural language into PromQL, like how many customers are impacted by this bug. And another one is automatic data exploration, where you let an AI agent kind of take the wheel and guide you through an investigation of your data. My colleague, Pavan, did a really nice talk and demo on this yesterday. I recommend you give it a watch. I think the recordings are already up. It goes into way deeper detail of observability agents and is supplemental to this talk. So query generation. I'll start with an example just using the Amazon Q CLI. It's using Anthropic Claude Sonnet 4. I ask it, give me a query for feature adoption rate. And let's see what it spits out. Okay, so it's pretty good, but it doesn't have enough context to give you a direct answer. Well, it gives you some nice options and a starting point, but a beginner would still have a tough time making this query work for their data, right? So just a little refresher on knowledge base and context for those that didn't attend Pavan's talk, because it's going to be important for later slides. So a knowledge base. It's a collection of specialized data for our LLM to reference when providing answers. It's where you can store things like internal documentation and runbooks to help the model avoid hallucinations. So in the PromQL query example, the LLM did pretty good, but we actually kind of lucked out that PromQL has been around since the 2010s, and there's tons of documentation, blogs, Stack Overflow posts of examples of valid PromQL, and that's already in these LLMs training corpus. So the need for a knowledge base is better illustrated if we try it on a newer language, like OpenSearch's piped processing language. So I'm actually going to switch the model to 3.5, just slightly older. I'm going to ask, what is PPL? And has no idea what the hell I'm talking about. It actually has some pretty entertaining guesses that sound plausible. People programming language, a language for the people. So now I'm going to add PPL documentation to a text file and add this to the agent's knowledge base. So just scrolling through it, it's just like a nicely formatted kind of scraping of PPL queries. I'm going to add it using the knowledge add command. And then it indexes this knowledge base. And then I'm going to steer it in the question. I'm going to say, what is PPL? But then I'm going to say user knowledge base. Okay. So it knows enough to say that PPL is an OpenSearch query language for logs and traces. That's great. And it also gives kind of an example query, but still not enough context to actually run a query. So this is where context comes into play. Context is a bit of an overloaded term, I'll admit it, when talking LLMs, but I'm specifically referring to the dynamic user-specified information to help guide the LLM to a more accurate answer. For generating a working PromQL query, we'd want to provide available time series, labels, and label values so that the output is more likely to be a working query for your data. A bit of a contrived example here, but just for sake of time, if we include available time series and labels in line with my earlier PromQL prompt, you'll see it picks it up like pretty easily here. Yeah, so it works pretty well. But in reality, we'd be using something like an MCP server, like Prometheus MCP server, but you get the point. So now we'll talk about automatic data exploration. So you grant an agent limited access to your telemetry data and infrastructure. You steer it with internal documentation and runbooks, and it guides you through an investigation. It basically behaves like an on-call operator would, right? It documents its progress, showing queries and graphs as it's reasoning about its investigation and maybe a hypothesis here and there. This was also shown in yesterday's demo using Prometheus and OpenSearch MCP servers. But having the agent lead you through that type of investigation and leaving a paper trail behind with queries, if you're a beginner, you can go and then cherry pick some of those queries and go investigate them at your own pace, right? And all these features are possible using agentic AI. If you thought you were going to attend a conference in 2025 and not hear about Gen AI, I'm sorry. But it's under rapid development. GitHub trends this month, 4 of the top 5 repositories are to do with NLP, LLMs, and agents. So we're integrating agentic AI into OpenSearch dashboards. I'll start with bring your own agent support, the ability to swap out the agent in the backend in OpenSearch dashboards. And so why? Why pluggable agents? From customer anecdotes, we know there are very valid use cases for self-hosted agents in on-prem networks. There could be sensitive proprietary data in the knowledge bases, or using external LLMs is simply prohibited by security. There's also third-party hosted agents that you can use for like pay-as-you-go options. And we also want to be able to test new agents. Like if they come available, if it's a new agent framework, we want to just be able to plug that new one in. And so exploring some of the options for observability agents in OpenSearch dashboards, we know that we need knowledge and context to be able to generate queries. But for this agentic led investigations, we also need purpose-built observability tools for the agent to be able to discover alerts and metrics and perform root cause analysis on behalf of the user. So during it's like a rapid development phase, we explored multiple options in parallel. One was building a new agent from scratch and repurposing existing ones out there. And I set off on the search for open source options like K-Agent, just to ensure we're getting like the full picture of this pluggability aspect correct. And so this is when I came across Holmes GPT. It's an open source observability agent by the folks at Robusta. It's a new CNCF sandbox project, so really good timing. I think just last month they started onboarding. I think they're still in the onboarding phase though, but it's an AI agent that's purpose-built for observability. I was pretty blown away, to be honest, about the functionality, just like straight out of the box. So I thought I'd share it with you today. It has an extensive observability knowledge base and tool set. It enables the agent to perform like root cause analysis, as you're seeing it's doing right now. It's planning out what it's going to do step by step in documenting its process. It supports MCP servers and all the major LLM providers that I tried. And it can be deployed in your Kubernetes cluster or as a standalone server. So if you have been looking for something like this, I recommend you go check them out. That's like kind of the summary of the findings for its automated root cause. So with more agents came more problems. Now, the more we experimented with different agents, we ended up having to write adapters in our front end. And this didn't scale well. It made the front end code really messy, and we needed a more modular and scalable way to integrate across the various pages also on the front end, because there are open source plugins as well. And so we have adopted the agent user interaction protocol in our front end and back end. It's a recent project by the team at Copilot Kit. I heard of this project before, but I hadn't quite understood the significance of it until I was actually faced with the problem myself. So AGUI is a standard for connecting agent backends to front-end UI, which is exactly what we were looking to do to be able to have pluggable agents in our dashboards UI. So no matter what the agent is connected to under the hood, like other agents or MCP servers, the interactions with the UI are consistent. So for example, the front end just needs to implement its chat interface once, and if the back end implements AGUI protocol properly, the experience should be consistent across the various agents. And one of the things I was pleasantly surprised with AGUI was the support for front-end tool discovery and state sharing. It kind of felt like MCP, but for the front end. For the front-end context and state sharing, we learned that if you spoon feed an LLM with context, it can provide pretty good assistance right out of the box. So with AGUI, we get standardized context as required input to the back-end agent chat requests. In this example, we have our observability front end. The user is exploring some data, and they've entered a query, and they're asking the agent now, explain my query. So we have this information right there in our UI, so we can include that in the request. Don't need to read all this, but this is what the payload looks like. You have the prompt, and you have some supplemental context in there. It's like you're telling, because this could be a remote agent, so you actually tell it, give it that context. You are embedded in the sidebar on this metrics explorer page. And this is the user's current query. It's using this language over this time range. And so this means the backend server doesn't actually need network access to your data sources to provide meaningful assistance to you. And you could use a remote agent. Yeah, one other awesome thing is like proactive troubleshooting as well. You open up the agent, something's probably already wrong, and so when you open up the agent, you pass that in. It's like something's wrong, the error's already there. I'm gonna ask you, it looks like you're having troubles here, would you like some help? So just like an MCP server tool discovery in AGUI, the front end advertises its available tools as well. So then the agent can perform front end actions like asking for user confirmation, also like executing queries and graphing time series data, which I hope we have enough time to show a demo here. And so the agent can make a tool call with arguments that the front end can execute, like the query parameters. Yeah. So putting this all together, we've released experimental support for AI Chat Assistant in Discover Logs and Traces with bring your own agent support for AGUI compatible agents. And additionally, I've upstreamed experimental AGUI support to the Homes GPT chat endpoint, so now it can be plugged into OSD. You can run this demo yourself. I wasn't sure how to switch the screen over, but I'm running the OpenTelemetry demo. I did a fork and I added Homes GPT AGUI experimental server there, and so it's connected to OpenSearch dashboards. Let me just try and see if I can switch displays. I don't think it's showing on the display up there. Yeah, it's a Mac. It's on a different desktop.
Do that, and then you can change it to mirror. Oh yeah, you're mirroring. Yeah. So
start mirroring.
And then you can switch.
Right on. Okay, yes, yeah, I'm running the OpenTelemetry app. Probably doesn't need an intro at this point, but it's basically just a telescope chopping app that gives you a realistic view of a distributed system, so you can have like some real-looking telemetry, traces, logs, metrics. And there's also a flag configure that you can use to, inject some faults. I think I said adds high CPU, something else, cart failure. So there'll be some metrics that are off a bit. But this is OpenSearch dashboards in Discover Logs. Looks big enough for folks to see. So we have this query. Let me just refresh, make sure there's data. Oh, did I lose my back end? The demo gods can't even do a basic query right now, let alone AI. Let me just restart. Let me see. Something going wrong? Oh, of course, the red text. So probably like that socket timeout. I don't even need the internet. Okay, we'll try one restart of the server of the back end, and oh, it looks like I got logs. I think we're gonna have to just give me a quick sec. Okay, yeah, it looks like there's a connection error happening. Did I lose the internet or something? Hope not. Okay, well, I was prepared for this because, it happens. I have just a demo video of it working here. I promise you I took it just a few minutes ago. So we're in that logs UI. I say hi. Holmes is there. Hi, I'm your AI assistant for observability, and I'm just saying explain my query. So this is where AGUI is helping here. It already has the query context, and it'll actually include the first 5 log entries as well, just because we found that usually the user is going to start asking about this. And so how can I filter for errors? And it is kind of like conversational here, right? One thing that we don't include right now in the context is actually all those fields because it exposed the context windows for some types of log schema. So right now it's saying the field level not found. It's assuming that I have some field named level, when actually, let me just scroll ahead a little bit. I found that we have a body attribute that just kind of has the whole message in it. So I say there is a body attribute. I give it that information, and then you can see it's executing that tool, execute PPL query. That's actually the front end tool modifying that query and executing it, which can be a bit jarring at first. So obviously we want to add in some user confirmations, like, do you want me to execute this query? Do you want to trust me for this session to execute queries and whatnot? Here's the other one. And so kind of like just not really in the UI here, can expand it out. I'm going to do an investigation. I actually didn't know about, I didn't know details about the front-end proxy of the OpenTelemetry demo, so I asked explore the front-end proxy metrics. And so you can see this is Holmes GPT. It looks just like that, CLI output there. It shows the investigation is ongoing. It's telling you that it's looking for metric labels and values. It's executing queries. It tried Nginx request total, didn't find any data, so it's going to look elsewhere. And it kind of gives you like the checklist of what investigations are currently ongoing, what's completed. Hasn't given us Prometheus graph yet. But, there we go. Oh, lost data. There we go. All right, yeah, so it gives us like front-end proxy request rate by status code over time, and it tells you the query at the top. You can see, yeah, so sum by status, rate, app front-end request total. So you could take that and put it into, Prometheus front-end if you want to just sanity check. But yeah, sure enough, it is the data. And then the reason I'm running an experimental server, shouldn't have done that, is because right now we're working on an add to dashboard function. So, I'm not going to say it negates the need for like an Explorer option, but now like you know what it takes to investigate the front end. Why don't you just take those and put them onto your dashboard? And now that's one of your observability dashboards. This hopefully should be a view that, let me just scroll forward a bit because I go and make a dashboard. There we go. Okay, 5 minutes. Yeah, this is the end of the demo. Yeah, so we had now we can start adding in to the dashboard right from that Agentic Explorer. Okay, so what do we unlock here? We got our agentic-led investigations, or at least humble beginnings of it, for discover logs and traces. And we have pluggable, interchangeable agents without requiring network access to data sources using AGUI. What's missing? I'd like to get your feedback on that, because there's a lot of obvious things missing. We have the trust factor of not prompting before the user to be able to execute those queries. That's a really big one. We have a number of agents that we're actually going to be shipping with the production version. So getting those out there and having a managed offering for that. But I want to get some questions, comments, and feedback from you all of what you think about this. It's obviously in an experimental mode right now, but it's the direction that we're kind of heading with OpenSearch dashboards.
All right, thank you very much. Any questions?
Hi, thank you for the presentation. Yeah, more than a question is like a feedback, because something that maybe is missing now in the demo is the actual capability of the agent to go see the logs from the various sources and actually help us troubleshooting what's happening, because maybe we receive the alert saying, oh, your system is down, nothing is working. And you go and say, hi, can you help me understand? And he's gonna check all the data sources and try to troubleshoot and help us understand where to look into. Or maybe suggesting us how to fix it, since he can have the whole context of the architecture.
Yeah, no, that's a great comment. So it's really like the capability of your agent at this point. So the agent that I configured in that demo, it's really only connected to Prometheus. But if I were to extend it, I would add MCP servers for OpenSearch as well as Prometheus, and let the agent be able to use that tooling as well. And we would have that capability. Yeah.
Great, thanks. I have one question. I had something similar in mind, trying out internally, but my vision was to use Alert Manager Webhook API and do this automatic investigation of alerts from Alert Manager, like sending notifications there.
Yeah.
And then, for example, post this result of the investigation to the Slack. Did you consider something like that?
Yeah, absolutely. Like the full end-to-end workflow. I mean, I wouldn't be brave enough to actually take actions on the agent's investigation results, but there is that option to have hooks on the outside too, and have it run. I think actually Holmes GPT, they're doing this type of work with their Kubernetes operator. I don't know how fully fleshed out it is yet, but they've thought about that as well. Yeah, definitely a very valid use case.
Okay, thanks.
One actually that would be useful is if you hooked it up to, let's just say, your ticketing system. So the operator's already been paged, right? Get out, like, it takes them 5 to 10 minutes to get their laptop. The agent's already been triggered with the alarm. They've already performed some sort of investigation. Even if it's half as good as what the operator could do, it will give some kind of head start to the investigation. Yeah.
Any questions? Nope. You get to pick one of the orange knives.
Oh, great.
And yeah, thank you.
Awesome. Yeah, thanks. Thanks, everybody.
¿Cómo es tu input? ¿Todo es así? Okay.
The next speaker will be Israel Blancas. He will tell us about debugging the pipeline, observability for your observability with Hotel and Prometheus. Whenever you're ready.
Google? I have to click, right?
Yeah. Can you
Okay. Well, hi.
Can you hear?
Can you hear me? Okay, awesome. Thanks for these days, because the thing is that I have learned a lot. And it's pretty difficult to be almost the last one, right, after these great presentations. So, well, my name is Israel. I am software engineer at Corologics. Well, I come from Spain, usually in contributing to OpenTelemetry. So I am not a metrics expert, neither a Prometheus expert, right? So maybe there are things that are not like 100%, accurate. So please don't, just if you need to tell me something, do it outside or something, right? And yeah, well, also I participate on different community programs, so it's pretty usual. Like you can see me on different conferences and things like that. Usually speaking about OpenTelemetry. So yeah, the things that why this talk. Many things that I will share here in this talk, very likely you know about them, right? But the things that I am usually one of those people, right, who attract the chaos, right, and the problems. And well, the things that many times I have been, well, I was working also on another company before, right, with OpenTelemetry stuff and everything, right? It's like I was like pretty, let's say, excited, right, about the project and everything, right? So I have been like pushing people for using OpenTelemetry. It's not what I'm gonna do today. Don't worry. And the things that sometimes I reject, right, because I forget to tell them some things, right? So the talk today is like a little bit, right, to avoid that kind of things and situations that some people have had in the past, right? Because just of my suggestions, right, about using OpenTelemetry. Next time I will stay quiet. But yeah, the thing is that let's imagine, right? You are a developer or something, right? And you have many applications, right? Some of them could be writing in Golang, other in Python, .NET, whatever thing, right? You also have set up, because you heard something, right, about something called Prometheus and observability and these things, right, or monitoring, or whatever, right? So you know that you have to have that, right? So you set up a Prometheus thing, right? And you also learn about something called OpenTelemetry. So you set up also a bunch of OpenTelemetry collectors to gather many data and everything, right? And well, also you need dashboards, right? It is important because you need to visualize the data, but also you have to provide something to managers. Managers love to see things moving, right, on screens. So it's like you have to do that. But hey, you know that things are not going well, but you are not seeing anything weird in your dashboard, right? Everything looks green, or even it seems that everything is working fine, right? But it's not what could be happening, maybe, right? The things that I'm gonna provide you with a situation that I have seen like maybe 20 times. Something like maybe you have something with a target allocator, right, or whatever, something scraping data, right? And well, one day, because of whatever reason, the target allocator decide to go sleeping, right? And the thing is that, well, you go to dashboards, right, and you see everything on green, everything seems to look fine. But the thing is that actually you are not scraping anything, right? So some metrics, right, are like saying, oh yeah, everything is going well, but since you are not observing properly your observability infrastructure, right, you are not observing the server, very likely you can be like missing data and things like that, right? And it could be like at some point it's very late for you, right, to notice about these things. So yeah, some problems, some metrics, and many data could be lost, right? And especially it's because when I talk, I usually talk a lot about observability, right? But people are like, yeah, I have my applications, right, and I have some kind of magic that reach my observability backend, right? And it's especially, well, in the case of Prometheus, right, we have seen these days that people have to do like that instrumentation, right? But with things like OpenTelemetry, where you have automatic instrumentation, that looks like more like magical, right? Like more like a black box. And things that actually you have to convert, right? The observability stuff, like on a first-class citizen, right? So there are many things, right, that could be failing. Like for instance, this presentation. Okay. Okay, so some things that can be going bad, right? Things like background things, right? Maybe there is something that you are configuring, you are expecting it to be properly working, even you are running the collector and it's saying, hey, everything's going fine, right? Not even just you checking the metrics, right? But there are things that could be happening there. Other things like, cardinality explosion that can be doing pretty many bad things, right, on your downstream components. So for instance, currently, right, we have one pull request open by Cyril that I don't know where is it, right? But we are trying to solve some things related to spam metrics, right? To some bad instrumentation, and also, well, things that have been causing us many issues, right? And also even silent problems that, well, you don't know, right, that the instrumentation is broken until you just see that you are not receiving all the data that you should be receiving, right? So something, for instance, that could be happening, right, is like at some point you have a sudden drop, right, of the receiving data. Many people are just checking the value, right, and if the value is like higher than 0, let's say, right, is that they are receiving data. But sometimes it's like that is enough, right? And this is usually something that we have experienced a lot with, for instance, the OpenTelemetry collector operator for Kubernetes, right? You know that one of the features that this operator has is that it allows you to inject OpenTelemetry instrumentation libraries, right, in your workloads, right? But one of the things that sometimes that injection fails, right? And currently we don't have a way to do a monitoring of that, right? So if you want to take a look, we have one issue open. Take a look because the conversation there even is pretty interesting. And yeah, these kind of things can happen, right? Also, during the collection itself, right, we can have other issues like, well, scrapping issues, right? Things like, I don't know, the TLS is not properly configured or something. Also, sport bottlenecks, like, you start adding things to the queue, right? And at some point, the backend cannot receive it because of authentication problems, or some maybe, I don't know, the queue in the backend is also full or something like that, right? You can also have some kind of rebalances things, right? Like when you're using, for instance, the target allocator, and you can be missing data there, right? Because while you are creating or are rebalancing the data, the data still floats, right? But also you have some process resource limits and things that can help you, right, to detect things that could be happening, right? So for instance, something that usually is a debugging signal, right, something that you have to take into account is like all the metrics that are related to exporter send and fail, right? We have one per exporter, right? And also things like the resource usage and everything, right? If you are thinking about the target allocator, the things are pretty similar, right? Like the collector cannot scrape targets, right? It can happen when you are using that and not just the Prometheus receiver itself, right? But when you are using also the target allocator. It can also happen, right, that at some point it stops assigning targets. So the Prometheus will scrape nothing, right? And yeah, also it can happen like, you know, it assigns all the targets to one collector just, right, and the rest are free. And also what you just mentioned, right, while you are doing that rebalancing thing, it can be happening that you are missing data, right? Also, well, itself in Prometheus, right, we can be experiencing issues, right, when we are sending data from the collector, not just if we are using the scraping way, right, but also if we are using the OTLP endpoint. And things like, you know, while you are using things like, for instance, Prometheus remote write, it could also happen like you have some kind of lag or even some drop samples, right? Even things that can help to that is the high cardinality on the metrics and things like that, right? Something that can help you is like that metric, right? The scrap samples scrap. That will, if your targets are still up, right? That can happen that this metric is dropping, right? Because you are not receiving the data actually, right? And one of the things that the worst failures are not loud, right? As I mentioned before, one thing that we see pretty commonly is like things like everything's green, right? And it seems that everything is working fine, but at some point, you know, for instance, the target allocator stops to rebalance, right? And everything shows that it's up, but actually it's not, right? Regarding the open telemetry collector, one of the things that is good is that, well, it's something opinionated, right? So you can configure on different ways, but that is also a problem, right? Because if you don't know exactly how to configure it properly, it can provide you many problems more than benefits sometimes, right? So it's like, usually it can happen that it fails silently, right? So when you need the most the signals, right? When you need the traces or the metrics or whatever, you check and they are not there, right? So we have different kind of metrics, right? Like for instance, those ones that I mentioned before, right, related to the process that can help you to detect an awful memory thing or receiver metrics, right? So in that part, if you are seeing that the asset metrics, right, are close to 0 or something like that, right, and refuse are going up, it's like very likely something is failing, right? Maybe things like the data is not well formed or something like that. Also, we have many, right, on the exporter side, like the number of data that we are sending, also things like the queue sizes, right? That is something that you need to take into account a lot. Also, we have that pipeline health, right? That you can check like what's happening inside the pipeline itself, inside the collector. We have that health check extension that until now, if you go and check the components right now, if you check, you will see that we have currently 2 versions of the health check extension. We are migrating from the V2 to the V2 implementation to the V1, right, to avoid breaking changes. But the thing is that it was not reporting properly the health of the different components, right? And this is something that is going to be fixed pretty soon, right? And working on that. So if I broke it, you will notice too. Yeah, so there are different symptoms that you have to take into account, right, depending on your metrics. So things like, for instance, if if the exporter queue, for instance, is raising, right, the number is rising, very likely it's a problem on the Prometheus or in the backend that you are using. Also, it can happen, right, that things like issues with the network, with TLS. So the good thing there is that you can also check, right, the logs and everything, but it's like starting with the metrics that I mentioned can help you a lot, right? Also, things like if you have a pretty complicated pipeline, you can see that very likely if you are using many processors, right, for doing like different transformations and things like that, that is pretty common. You will see, right, that your CPU and memory will rise a lot. And also it can happen depending on the cardinality of the data that you are using, right? That will also happen, right? And yeah, also things like it could happen that in the receiver you can be happening like misconfigured limits and things like that, right? So the things that you should adjust those limits depending on your thing, or even doing some kind of scaling, right? Also, so the things that sometimes what happens is that actually is the collector the one that is breaking the thing, right? So Nicolas, that I don't know where he is, right? But the thing is that some days ago, well, actually on the very beginning of October, right? Alert that, well, something was like having, one of the metrics that from the collector was having a high cardinality issue, right? And after a little bit of time, right, we found that the problem is that the collector itself, right, the exporter thing, right, was adding the IP, right? So that was housing a high cardinality thing. It's not fixed yet. The things that they created the PR today, right? So yeah, soon in your OpenTelemetry collectors or not, right? Who knows? But yeah, another thing that we are also starting to see in the OpenTelemetry collector is doing some tuck fooding, right? The things that yesterday there was a pretty interesting talk about Weaver, right? That will help you to, like, you have one manifest, right? Let's say, and you can generate some you can generate in the SDK that you need, right? You can generate the metrics, right? And it will have the units and everything that you need. But there are also other things that you can do, like just checking that you are not breaking the backward compatibility and things like that. That is something that currently is happening a lot on the OpenTelemetry collector. Even when we add some tests to avoid that, I think that since that has been a little bit better, right? But there is some work there, like to do more stabilization on the telemetry thing, right? So you can see exactly what metrics are exported by the different components. So it's something that is still open and needs some conversations. But I am pretty excited about this happening at some point. Something that I always recommend people when people are running the OpenTelemetry collector is building a collector health dashboard, right? With just things related to OpenTelemetry collector, nothing else, not about the rest of observability things. Why? Because the things that with that, you can see pretty fast the CPU and memory usage for your collector, right? So if at some point the data starts to become weird or something, right, you will notice pretty fast. Things like the exporter queue size and failures, right? And well, also the data that you are receiving and refusing, right? And also having a ratio, right, between what you are receiving and exporting, because sometimes it's like you can see, right, that you are missing some data. I remember having a conversation with somebody who was like, oh yeah, well, my OpenTelemetry collector is working fine, right, and everything. Yeah, the things that they thought that there were some things that were not working fine, but they were not pretty sure about what those things were exactly, right? Because they thought that they were missing data, but they were not pretty sure. So after creating one dashboard, right, doing this comparison, they noticed that we were dropping around the 30% of the data, right? So it's sometimes when you are running things at the scale, it can happen that you don't know exactly that you are missing data, right? And well, actually it was a 30%, it's something big, right? Something even like that, right? So the thing is that something that also why this is important is like, it can provide you right information pretty fast about what's happening, because if at some point your telemetry pipeline dies, you are gonna lose all the data, not just the application data, right? Well, so it's like you are gonna be like totally out. Regarding the target allocator, right? Well, the problem that usually can happen, right, when you have just Prometheus on receiver on the collector, right? It will be like it will try to scrape all the service monitors or pod monitors or targets or whatever you are using, right? So the things that the things that with target allocator is like it rebalances, right? The load of scrapping, right, between the targets and the collectors. Something that usually happens, right? Things like the allocator stops assigning targets at some point because whatever, right? maybe because it doesn't have enough resources or whatever, or maybe one collector has 500 targets, another just 50 or something, or maybe you have a pipeline that is not pretty healthy, right? So it is rebalancing all the time. That is also something that happens in some environments. Yeah. So yeah, it's like you have to be like checking right all the different metrics that you have in the allocator to ensure the number of targets assigned right per collector to ensure that they make sense, right? They don't have to be exactly the average, right? But they make sense. And also that you are still scraping data, right? This is something I know that I repeat a lot, right? The part of the scraping data, but it's something that I have seen it a lot, right? And also, check for sure the logs and everything, right? But with the metrics, we should have many things, right? And also avoid things like, when you have these kind of environments, right? You should like avoid run collectors on high volatile infra, right? So for instance, I don't know, things like, let's imagine AWS Lambda or something like that, right? Where you are starting and dropping things all the time. Because it will like, the target allocator will need to do rebalancing, right? And it will become crazy, right? Here I will go a little bit faster, right? But something that also we have seen a lot of times is like, the remote backend, right, starts going slower, right? Or things like dropping samples or things like that. Or you are starting to have a high latency, or even silent lag, right? That this is pretty interesting because I remember one situation with somebody that they were having some lag, right? We're sending the data, and they were debugging. They were receiving the data from 10 minutes ago, right? So when they have an issue, actually they were just checking the data from before, right? And it was pretty difficult for them to debug the things, right? So there are also some pretty interesting metrics, right, that you can debug on the Prometheus, right, about these kind of situations. And also, you need to, depending on your thing, right, you will need to very likely to tune the queue settings, the scale the remote backend ingestion capacity, right, because sometimes it's like we just let the thing by default, or drop or aggregate high cardinality metrics, right, at the collector. So something that you can do it, right? If you notice that something is like wrong because your dashboards are blank, it's too late, right? And usually this is something that I have seen many times, right? That people just go crazy because they see their dashboards blank, right? So the idea is that you should notice about the issue before, right? That situation happens, right? Because your telemetry data went away, right? Actually, it's not reaching or something like that. So just to finish, the things that the big important part is like observe the pipeline, right? Not just the applications. The applications are important because at the end of the day is what are doing the business, right? But also you have to treat observability as a first-class citizen, right? The collector metrics are gold. Check the metrics that are, if you are running the OpenTelemetry collector, every time that you add a new component, check the metrics that are emitted by that component, because sometimes it's like not all the components are sending exactly the same metrics. For instance, there are some of them, right, that have some custom metrics that can be pretty useful for you. The target allocator also is fragile, right? Because it's like every time that you have a big change, right, in your environment, it's like it has to rebalance everything, right? Remote write will betray you, even if you don't think so. It happens, right? It's like we don't have to just trust the things because they are pretty very well battle tested, right? Because the environments are pretty different. So it's something that we have to prepare. Prepare alerts for your safety so you can recover pretty fast from things. So thank you. I hope you learned something.
Right. Thank you, Israel. Are there any questions?
Thanks for the talk. Just one question regarding the uneven load. Do you know any ways how you can mitigate that? So when you, for example, have targets like cube state metrics, which export a lot of...
Can you speak loud or something? Because I cannot.
you have targets like cube state metrics, for example, which exports several, like a lot of metrics, and some targets are just thousands active series. And how do you monitor the uneven load, and what do you do with that?
Wow. Could you repeat the last part? Sorry.
So when you have targets that have like 1 million metrics and
Yeah.
targets with like hundreds of metrics,
Yeah.
is the load uneven? How do you monitor it? How do you mitigate it?
Okay, yeah, the thing is that there are metrics, right, that can allow you to tell you exactly how many targets you have per collector. So that part is like pretty easy to see, right? And how to mitigate it is like, depending on the, really like there is something bad in your configuration that is not assigning properly the load between the collectors. So that is the first thing that you need to check. Another thing could be that there are some kind of error. Like, you know, the configuration, everything is fine, but I don't know, there are some network issue or something like that. I remember one situation where everything looked fine, right? But the thing is that even the errors were silent in the log, right? I don't know why, but the user decided to disable the errors even, right? And when we enable, we start seeing all the problems. And the problems were usually timeouts because of the network, because they were communicating across 2 different clusters or something like that. I don't remember exactly the environment. And yeah, also another thing was related to the certificates, right? They were doing certificate rotation, but they were doing it pretty fast. So the things that when you were starting, right, the collector, it was getting the new certificates. But since it was not getting the data, the target allocator was dropping it, right? So, yeah.
Maybe one more question anywhere? All right, thank you.
Thank you.
Yeah. Also get to...
Yeah. Well, I don't know if I will be able to get this into the plane, right?
If you can check in, you can take it. If you can't check in, we'll ship it.
Okay, ship it, please.
Right.
Right. Our next speaker, Attila, is going to tell us about counting what you care about in your security data pipeline. Whenever you're ready.
Okay, can you hear me? Cool. So, hello everyone. My name is Attila Szakács, and I will tell you about metrics, about logs in your observability pipeline, or as the title says, counting what you care about in your security data pipeline. So, quick introduction. My name is Attila Szakács. I'm a founding engineer and tech lead at Exaflow, which is a startup where we develop a logging pipeline on steroids, that's how I would introduce it. I'm doing software engineering here. I'm the tech lead of the data plane team. Actually, I had the privilege to develop syslog-ng for more than 7 years now. And I'm also a logging operator maintainer, which is CNCF Sandbox project. So I'm coming from mainly a logging background and from the developer side, not strictly as the user of log pipelines. So my introduction to metrics was probably very different from the rest of you or most of you, more similar to the approach in the next or in the previous presentation. So most of the time I looked at metrics to debug the logging pipeline I was developing and maintaining. But I hope because of this I can give you a slightly different perspective to logs and metrics, maybe one you have not really heard about, or maybe nothing new will come from this, or every one of you knows these, but at least you can see a different path of learning about metrics. Also, I'm a first-time conference speaker. I'm very honored to be here, so I must thank PromCon for having me and starting on this journey. Okay, so what will we hear about today? First, we will talk about what syslog-ng is, if you have not heard about it before, what metrics looked like in syslog-ng previously and how we transition to Prometheus-style metrics, which I think is interesting to see because syslog-ng was not developed in Prometheus in mind, and we had to retrofit this. Then we will talk about what other limitations syslog-ng's metrics have, and how we think that log-driven metrics solve those issues. And then we will see some examples and a case study of these metrics in action. So, how many of you have heard about syslog-ng before? Wow, that's quite a lot of hands, more than I expected. Cool. So those of you who don't know, syslog-ng is an old-school log processing service. It is older than Prometheus or even Git itself. A couple of talks earlier about the UX research, Andrei mentioned that Otel came from a tracing background. Prometheus focuses on metrics. Well, syslog-ng is, I think, one of the pioneers of log collection and processing. It was founded in 1998, so it's a pretty old school project. It supports all kinds of protocols for receiving and sending logs. In the last couple of years, we added OTLP support as well, but its main strength was or is cleaning up the syslog mess, the variously malformed syslog messages, which some of you might have seen, which looks like this, and it's not even a mess. This is a correct syslog message. Just for reference, this is the best case scenario, just how logging was always intended to be. So syslog-ng is used in on-prem environments usually, but your Kindle or certain BMW models might be running it too. It has a really small footprint, memory footprint, and is written mostly in C. It has metrics, but it exposes them in a custom CSV format. And metrics are not the main data forwarded by syslog-ng. Last year, Exaflow forked syslog-ng, called it exosyslog. We kept it open source, added a bunch of destinations and a completely new processing language called FilterX, which we'll see some snippets in the slides. And a lot of old syslog-ng maintainers work on exosyslog, including its original creator, Balázs Scheidler. Yeah, okay, so what did syslog-ng come up with in regards of metrics? Well, this is the custom CSV format I was talking about. What kind of metrics does syslog-ng expose? We have source and destination side metrics, also a bunch of global performance related metrics, similar to the metrics we saw in the previous presentation. But they tell about the behavior of syslog-ng itself, nothing about the logs. So we can see that we have queued and written metrics at the HTTP destination, but we don't know what kind of logs were queued or written. We just know some of them. A bit of details about the metrics. So the most interesting parts are that the metric name is at the end. Labels are static. We have like a URL label for the HTTP destination. We have a destination type label, which is HTTP itself. We have the name of the destination configured. It has the information, but it's hard to make sense by a human, I think. Users of syslog-ng usually wrote their own shell scripts to process this info. And then Prometheus came and showed the world how it is done, and we wanted to do it the right way. There were a couple of things that made this the clear choice for us. First of all, syslog-ng's metrics were already cumulative. Why was it like that? Because syslog-ng also stores and processes these metrics, processes the queries, and mostly cumulative information was useful for the user, for like how many messages were sent, how many are there in the queue, and so on. Also for performance considerations, you want to create a counter once, if it's possible, store it somewhere readily available, and update it until the service runs, so you don't eat up a lot of performance by creating metrics regularly. The second point is that syslog-ng's counters were already stateless. It was a really similar architecture that we see in the Prometheus format or style. One line means one counter or one metric. Syslog-ng stores metrics like that. This resonates well with Prometheus's architecture, though we do not support type and help directives because of that, because we do not group these counters together. And also, which was a big plus, that we didn't have to change much for formatting, because CSV formatting and the Prometheus style text formatting is really just string concatenations, so a couple of tweaks did the job. So this is how it looked like in the past, what we can see on the top of the screen, and this is how it looks like now. Though we have backwards compatibility, so you can query the old one too if you still want to use your shell scripts. Okay, cool. So syslog-ng's metrics are now easily processable, but we still have a problem. They only show you how syslog-ng works, but they do not expose anything about the logs themselves, like I mentioned earlier. The logs which syslog-ng is intended to make too easy to handle for the user. So why can't we look into the data with these metrics? At this slide, we can see that sources and destinations have their static baked-in metrics, no meaningful labels regarding the data itself. So why don't we have info there? Well, first, the info you would want to put into the labels are only available later in the pipeline after parsing. In the source driver, those are just characters, and later than the JSON, CSV, or KV parser, or the syslog parser is what is making sense of it. So syslog-ng doesn't have the luxury of having readily available structured data that it can pick the interesting labels from. Secondly, the data is not normalized. So even if we had readily available information in a structured manner, whether the certain field is called dest IP or dst IP is dependent on the data itself. So you cannot know it. You do not know how it will be called when you are compiling syslog-ng itself. And third, even if you had normalized info available, you don't know what is relevant for that certain use case. So needless to say, you don't know all this when you are writing the code for syslog-ng or compiling it, and so on. So we came up with a logical solution to this, I think, which is letting the user define the measurement points themselves. The name of the metrics and the labels can also be customized. So here we can see parse events total metric being generated after parsing, and it is already using the field label. And then after we have filtered the logs, we can count those messages too, call them selected events or whatever you want, and use any labels you would like to. So this is FilterX, the new processing language in exasyslog. Actually, it is not available in syslog-ng. And this is how it looks like in it. So first we have a CSV parsing. Then we build up the labels from the parse data. So that's labels equals host and service labels coming from the parsed dictionary. Then we add another label, which is called rec, and we can see that it is accessing data from another place, another object called hostdb. And this is what we call enrichment. So this info was not available in the message itself, the log message itself, but some info was available, and based on that we added new information from outside. Then we measure the parsed events total. We put the labels to that function call. We set the increment to 1, but you can set it to the size of the message and call it parsed event bytes total, for example, if you want to measure that. Then you have some filtering. You only continue the processing if the parse level is error. Then you count those messages too. And these are the example metrics that are getting generated from this code. So parsed events total, selected events total. We have the host service, rec information, some values for them. And here are some example labels in the wild, which we came up with. We can see that some labels come from the message itself, like the host information, the service the log was generated by, and the transport, or sorry, not the transport, the severity of the log. Some labels are only present in the pipeline, which is very important, I think. I will circle back to that in a bit. So the connector type, like we are collecting Windows events with the VEC connector on that port, is only available in the pipeline. The client IP itself, so the host we are communicating with, is a meta information, and that we are using the HTTP transport is also a meta information, which can be useful for some use cases. And we can see that some labels are coming from enrichment itself. So like we can imagine that we looked up the host, that Azure US East 2 Windows, and we have some values for it, like building location, rec, I guess, or which team it corresponds to, or calculated information like vendor and product, which is, yeah, you can imagine anything here, whatever fits your use case. So in summary, I think customizing your metrics in your pipeline gives you observability into your data itself, whatever that means. Okay, so let's see it in action. Not a live demo, but I prepared some graphs we can, or dashboard-like things we can check. So we will do 2 small exercises. You are probably familiar with this if you have done log analytics in SIEMs before. So let's see what we have here. This is the previously shown classified events total metric visualized with a Sankey diagram. So a small introduction of how we use the Sankey diagram. The full height of the parts show the full sum of this metric. And the height of each label's value show how much the counters with that specific label value contributed to the sum. Yeah, I had to read that because I can't say that by myself. It's complex, but once you wrap your head around it, it becomes like second nature. Also, you can see the intersection with the neighboring labels. So we can see that most of the FortiGate logs had error severity. Some had info, and some we don't know which or what severity it had. Okay, so what infrastructure problem can this Sankey show us? Do anyone have any ideas? Okay, so we see a lot of debug logs coming from a service on a single host, from the app server Nginx host. If this is a production system, I think we do not want to see this many debug logs sent to the SIEM. It pollutes it, it makes large bills and so on. So we can maybe deduce or get a hunch that probably debug logging was enabled after a troubleshooting session. Okay, let's look at another example. Same labels, but a bit different ratios on the Sankey. This is a simple case. We can see that we have a lot of error logs. And the interesting part is the correlation between the host label rec label and the error severity. We can see that most of the errors are coming from rec A, so probably it has some localized problems. And actually, usually these kinds of analytics are done on the logs in seams, but like I mentioned earlier, you have some metadata available only in your pipelines, so we can have more info here. Okay, so after these warm-up examples, let's see a case study. Let's see how these dynamic metrics helped one of our customers, City's Department of IT and Telecommunications. So this department is responsible for receiving logs from all agents of the city and routing those logs into their respective pub subtopic. Each agency has their own dedicated topic, and there is a mapping between host information and the agencies. So we know that this host corresponds to this agency, for example. All the logs are received in a single port, so you can only deduce the info, the host info, from the logs itself. So usually how people solve this is they open like as many ports as many agencies they have, and those agencies can send to only those ports. But here it's on a single port. And it can be possible that the mapping has failed, so we don't know that this one host, so we don't know how, okay, sorry. So we don't know which this host corresponds to, which agency it corresponds to. So the routing logic itself, syslog-ng extracts the host info from the log, then it maps that host info to an agency. It sends the log to the correct topic, and if it failed to map, then the logs will be sent to the fallback topic. And the big problem is that the fallback topic must be checked by hand, and the mapping must be updated based on the logs there. So how does the fallback topic look like, or how could it look like? These are fake logs, of course. I highlighted the host information in the logs. So in some cases, it is in the right syslog header place. Sometimes it's under the dev name, key value pair, or the ID, or underscore age, or sometimes it is not even available. So it's hard to see. It's tedious. You need to manually check the fallback topic. You need to untangle the host info by yourself without the help of the connection meta info you could have had in the pipeline. And you have to worry about not missing a log. So maybe you have tens of thousands or hundreds of thousands log in the fallback topic, and you don't even recognize that you have missed one from a not so chatty client. And you need to do this all day, every day, until no logs end up in the fallback topic. Okay, so what solution we came up with? We let the customer use user-configured dynamic metrics in the pipeline. They have added host, IP, agency, and topic labels. And from the Sankey, you can see instantly that there are logs that have no agency or topic, and the host and IP information is available here. So what are the benefits? No more digging in your raw logs. You just look at the Sankey, or even better, you can write some alerts based on those metrics. If you need to document what you have found, you can run some queries and export their output. And as a bonus, now you can warn an agency if it has an unreasonably high load, or you can give them their own view. So what have we learned? First of all, syslog-ng/exosyslog supports Prometheus with all the querying, dashboarding, and alerting that it comes with that infrastructure. Secondly, we learned that metrics can be generated from logs, and it makes analyzing the logs easier. We saw this in the case study. We also learned that some really important meta information is only available in your logging pipeline, so it might be too late to do analytics in your SIEM. And even though I'm a syslog-ng developer, I must emphasize that you can do the same with hotel call or any other alternative, I think. And even generating metrics from data in motion is useful, probably even outside of the logging pipeline realm. Thank you for your attention. If you are interested in what we are doing in exosyslog, make sure to check it and give a star on GitHub.
Thank you, Attila. Are there any questions?
Going once, twice. Well, thank you.
Thank you.
It's time for the break, and after that we'll come back for lightning talks. I think we have like 13 lightning talks. We might have space for 1 or 2, but this time we will also have a super loud timer playing from his phone into the audio system. So yeah.
to the second round of lightning talks. First up, we have Arthur and Nicolas talking about, again, like schematization stuff, right? Yeah. And then next up, we have Siad Usman. So please get ready already.
A disclaimer, we didn't prepare. I was looking for Nicolas during the break. I couldn't find, so we are winging. Yeah, our talk. Do I start or you start?
Go ahead,
okay.
go ahead.
No, let's go back. I did a talk yesterday about creating schemas and how to use the schemas to create documentation, dashboards. But there was one question. What do I do if I already have metrics, I already have applications, and writing schemas by hand is very tiresome. I don't want to do it. So Nicolas built something that we want to present.
Cool. So like Arthur showed everything related to telemetry first. It's pretty nice, but the question is the same. What do we do with existing telemetry? This isn't a new problem, right? We kind of faced the same problem back in time when OpenAPI became a thing. You have a bunch of APIs on the wild, how you're documenting all these APIs to people adopting API first. So the way that I think about solving that, it's like reverse engineering telemetry. Like you have a telemetry pipeline, you can just extract the schemas from the telemetry pipeline in runtime. And this is what we're going to show you right now.
So we have to showcase. How do I exit all full screen?
He's not a Mac user.
Yeah. Okay, there you go. So we don't have Node Exporter running, which would be a good example. We have Hotel Demo. There's a lot of microservices running, sending OTLP to a tool that we call Telecat. In Telecat, we can see all the metrics, logs, and spans. And if I knew how to run a profiler in Mac, I would have profiles, but I don't. And then we have an API to, for example, we are grouping together metrics in scopes, which is a logical group that makes sense together. For example, we have Go metrics, we have, I don't know, HTTP metrics, and if you go to API v1 scopes, let's see, Java. Then we have a schema with all the Java metrics, and we can just download the whole schema. If we go to another scope, let's see, Go, then we have all the Go metrics in the schema. So that's our plan for migration. We run on whatever we want to create a schema from, send to Telecat. Here, Telecat will give you the schema, and then from there, you do manual adjustments, and then you start using schemas.
Yeah, just to give you an idea, like all those telemetry are produced by SDK, instrumented on the code, and we don't have any schema from that. So we're inferring schema from runtime in like OpenTelemetry format or Prometheus format. We just like extract like metric name, what is the type of the label, and label values, and so on. And then this schema you saw right here is the Weaver schema that you can later use to generating all the SDK, okay? Like this project, like there is a ongoing discussion on Weaver to donate this project to Weaver, so it becomes like a Weaver UI. Weaver project has more ambitions on maybe becoming a, I don't know, catalog management, telemetry, where you can do data governance. But this is just a way that we can give some incentive to engineers onboarding telemetry first implementation, but without rewriting everything from scratch.
Yeah, we got buy-in from the Weaver maintainers, so we have green lights to do this. There is one small problem. Weaver is written in Rust. I have no idea how to write this thing. So yeah, I don't know how do we proceed.
We will manage. We have AI.
Yeah. Another thing, Telecat is very under development, so we are open to whatever contributions. We were thinking, we are focusing on OTLP, but one idea, we could put the scrape manager code from Prometheus into Telecat, and then Telecat could scrape metrics from the usual /metrics endpoint, and then create the schemas from /metrics, and we don't need to convert to OTLP first. There you go.
That's it.
All right, thank you. So we have Syed Osman. Ah, yeah, perfect. And then next up will be Virginia Diana.
So testing, yeah. So thanks everyone for joining this session. So this will be talk about, sorry.
You want to use this one?
Okay. Yeah, thanks for joining the session. So a little about me. My name is Usman, and I work in Grafana Labs as a developer advocate. And yeah, I've been with the tech for like many years, 15 years, and using Linux. I love Linux. And yeah, today's talk about PHP, which I used to work in the past. PHP has a very cool history. If some of you may know, it started from very basic, then the Docker, some people use it, and now we have even Kubernetes, which is fun, but not so fun. And one cool thing about PHP is that like one of the project was WordPress. I actually give this talk also in the Linux Foundation event as well. So it's very minimal version of it, and we will see how we can use Prometheus with PHP. And you need to use it because when you talk about Kubernetes, you do not know what's going on where. It doesn't matter how many you do scale up or whatever, and think everything will be fine. There will be never something fine. So yeah, and the part which we will focus from the pillars of observability will be metrics. And yeah, we will use Prometheus for that. So a very quick demo. So this is the page which you see if you run like a PHP info. So it gives you all those data or metrics, and you can see a lot of information. But for me, the curious part was this part, because on the same page, you can get all these metrics as well, and they are live. So you can definitely able to use Prometheus with PHP as well. And here's an example from that sample web app or from the page. So if I want to see the memory size, I can, or bytes, I can get it via Prometheus. And I just define like a basic Prometheus exporter on the node, and it gets the job done. And if we go now, like, okay, this was basic, but if we go a little bit more advanced, then we will talk about, like, for example, if running something like a WordPress where you have like backend, front end, and things going on. So again, yeah, this is like full version, but the minimal version, which we can say like, okay, we are interested in WordPress, and we want to see the metrics of the backend via Prometheus. We can use different things as well, but yeah, not today, next time. And yeah, so here is the demo. So this is my WordPress deployed on Docker, and here's some page. And if I go and type like I have used WordPress exporter for this. And for example, I'm interested to get the number of count on the comments. I can see, okay, there are 10 comments, which, okay, nice. And can use Grafana to see in a more visualized format, and can also gather other metrics like number of users, media, system health, and so on. So definitely there is a way to use these exporters and get all the details. Also, I think without alerting, there is nothing incomplete. So this is just to let you know that you should define policies when you're defining alerting, because when I work with or see issues from community users who are using either Prometheus or some other tool and say like, hey, this is our notification policies. So always try to structure in a way you get as less noise as possible because those are costly. And yeah, and my final takeaway will be for both Prometheus and also for Grafana is that you should use it definitely for your application, like PHP as well. It doesn't get that much love, but it's there still. And it is available in many flavors. Both the Prometheus and Grafana have a very rich community support. A lot of community, like Prometheus has many PHP exporters written by the community users, so you can definitely check it out. And yes, it's a complete stack for everything. And I just put this final QR code. If you want to check out this project or the details, you can scan it and try to view all of it. Yeah, that's all.
Thank you. Next up, we have Virginia, Diana, and then Hervé, Nicole.
Like mirroring? Perfect. So, hi. Nice to be here for the very first time at PromCon. I'm Diana. I'm a developer experience engineer at Victoria Metrics. And I wrote this talk like early this morning. I couldn't sleep at night. I actually had cold sweats. And it was like one deep philosophical question I was asking myself. It's not the world hunger. It's not about the wars. It's not about my family being safe. It's about what is platform engineering? So if you know what is platform engineering, please enlighten me. So yeah, because I don't know what is platform engineering, I went and I have one very good friend actually that knows about platform engineering, and I asked him. So this is actually an interview with them. So what is platform engineering? So I got this answer. Actually, it's pretty accurate. It gave me like architecture. It gave me like, you know, the scraping. You could see like it goes like in deep analyze here. It's like remote write, recording rules, alerts, scaling. So it's like in less than 3 seconds, it gave me like all the blueprints for how to build Prometheus for platform engineering. Yeah, so you guessed it's ChatGPT, right? But then I went to this conference and was a keynote about platform engineering, and I asked them, okay, but can you tell me, in your expert opinion, what is platform engineering? And they told me, yeah, platform engineering is all about the metas. Right? Okay, so as a philosophy graduate, I did metaphysics. I was like asking myself deep down, what do they mean about the metas, right? So then again, I asked my expert friend, what do they think about these metas? And they came with a like very important blueprint about platform engineering. So it's not about the actual answers, it's about the actual questions, right? So if you really deep down ask questions about platform engineering or how to create something on platform engineering, it will become like a revelation, right? So next time when you want to do something, doesn't matter Prometheus or not, just ask questions, right? So you look at that. So it has like security, operational model, data governance, like it's amazing, right? So even has appendix at some point. Right, so yeah, I'm like as you know, clear about all the answers as yourselves. Actually, I'm super clear. But since I joined Victoria Metrics, I have like this like very deep debate in my head, and everybody has been asking me. So I'm looking at you, Julius, and looking at you, Roman. So yeah, apparently there's this like really big debate between Victoria Metrics and Prometheus. But yeah, I don't know. I'm not a marriage counselor, but I think they'll be doing fine. So yeah. So yeah, if you want to get in touch with me or just see like what random questions I ask myself at night, you can just use a QR code. This is actually a photo of me last night coming from the dinner. Yeah, and you could just connect with me if you want to find out how many beers I had. So that's totally fine. Thank you, and that's it for my sharing.
Thank you. So next up we have Alexander. Yes, and then Igor. I think, right? Yeah. Oh yeah, I skipped one. Avery, yeah, sorry. Yeah.
Oh, quick selfie with everyone.
So, hello. I wanted to talk about a little different topic, Prometheus rules. Because we talk a lot about them, but so far, I'm not sure how people manage their rules. Looks like there's some secret behind that, I don't know. So I can talk about what we are doing at Giant Swarm, and if you are doing differently, please come to me and give me some new ideas. So yeah, the question is about how do you manage Prometheus rules? Who stores their rules in a Git repository? Okay, so far we're all good. Who runs CI tests on their rules? Oh, quite nice. So at Giant Swarm, yeah, we store our rules in a repository. We package them as a Helm chart. And we validate them with some CI. We package them as a Helm chart. We Flux deploys them on our different clusters where we have some monitoring. And Alloy deploys them from the resources created on Kubernetes to the rulers. So for validation, we are using different tools. We are using Pines from Cloudflare, which is really great in my opinion. We use it, so it checks the syntax first of all, okay? It checks for label aggregations. For instance, we want for each aggregation, we want to keep the cluster name and stuff like that and team name. So it checks that we keep them. So if someone writes the rules and forgets to group by team or whatever, our pipeline fails. It checks that we have some required annotations like the runbook, which has to be indicated in each alert. And then we also run PromTool. So PromTool does also the syntax check, and it runs some unit tests on the rules. So I don't know, who uses Pine here? Oh, okay, and who uses PromTool? So I guess all of the others that did some CI checks. Maybe there are some other tools that I don't know about, and I'd love to know about. So a bit more about PromTool, which was quite of a pain point for some stuff. So okay, so you already answered that, fine. The result of PromTool is a pain to me. I don't know what's wrong there. How can I find it out? Quite often, I had to copy it in two separate files to do a proper diff. Okay, useless. And so, an idea that we had, it was 2 years ago, we did a small hackathon at Giant Swarm, and we just created this diff output that shows exactly what is wrong in the output. And so we did, I participated it, I was part of it. We pushed a pull request. And the magic thing is that yesterday, when I wrote the slides, I saw that this PR had actually been rewritten by my colleague who worked on it with me and was actually merged where I thought it was still pending. So I saw that it's actually available. So yeah, thank you very much.
Nice.
Thank you. So now we have Alexander and then Igor.
How to detect and delete unused metrics. How many of you know about this unused metrics problems in Prometheus? Yeah, I think there are a lot of users who stumble with this problem. And let's think how to solve this problem. And why unused metrics are important? I think you know that they occupy a lot of disk space and occupy a lot of memory. And obviously they are never used. Then the question arises why we need to spend disk space and memory for such metrics. Okay, how to detect unused metrics? There are two ways. The hard way is the following. The first step is you need to get a list of all the metric names from your Prometheus or from Victoriometrics, like this example. Then the next step is to inspect all your recursion and Alderson rules and extract all the metric names from these rules. Then go to your Grafana dashboards and extract all the metric names from PromQL queries across all these dashboards, and then subtract these found metric names from the metric names obtained from this Prometheus API, which returns metric names which are stored in Prometheus. This is the hard way. Who tried this way? Oh, there are people who tried this way. Okay, and there is a simpler way. I heard that Mimir tool has this analyze command, and it can perform something like this, but automatically. But the only drawback, it works only on for Grafana, as understood correctly. Okay, and the second way is the following. You can track all the metric names which are stored into Prometheus or other database during data ingestion. Then you can track also metric names for all the queried metrics with all the query time series selectors. And then you cannot wait for some time, for a day, for example, or for longer time, and then automatically subtract the queried metrics from the stored metrics and get the set of unused metrics. This is not so hard to implement, and that's why, okay, that's another step. When you identified all the unused metrics, it is good to start removing the metrics which takes a lot, the majority of memory and disk space. And how to detect these metrics? And obviously, you can use TSDB status information for this, this Prometheus feature, which shows you metric names with the biggest number of time series. So if you identified unused metric names in this list, it's better to remove these metrics from this list. And as I said, it is not so hard to implement it. That's why, okay, I forgot. And how to delete unused metrics? You can delete them at metric ingestion with metric labeling configs like this one by enumerating these metric names or prefixes or suffixes with regex and drop these metric names. And Victoriometrics already implements this. You can see here metric names with the top number of time series, and you can see here the number of requests for this metrics, select requests, and the last time this metrics has been queried. And if you see 0 here in this row, then obviously you can drop this metric. Or if you see that the metric has been requested long time ago, then probably it's also a good idea to remove this metric. And the call to action is to let's implement it in Prometheus.
Thank you. All right, so we have Igor and then Brian, Mr. Borham.
Hello. After Bjorn's talk, I was thinking about the definitions of observability and monitoring. I learned a lot here, and I tried to figure out, since he said that maybe a good definition was that monitoring leads to observability, is there a situation where maybe that doesn't apply? Let's try to experiment and see if we can find something. First, a bit context about myself. I deal mostly with bare metal hardware. All my machines run Windows. I'm in a very different context than all you guys. So I'm not talking about my work. I'm trying to draw from different experiences and try to bring a different perspective here. So when I get monitoring, I'm trying to diagnose systems. I'm trying to improve performance, and this may translate a bit and bring a different perspective, maybe. I also really like splitting hairs. So there's going to be some philosophy here, just thoughts for us to think about what could be. So very different context, thinking about the car. Like most of you, I assume, don't even know what half of these fluids are. But that is something that a user can observe on their system, on their car. If they open the hood, they can get data from, is this full or is this not full? And sometimes there's monitoring on those. But I would say that engine oil in some cars have it. But many cars, you have to go there and check, otherwise you don't know until the car starts smoking or something gets wrong. So maybe there's a nuance there. And even to get that information can be very hard. These cars here, they have a frunk and a trunk, and you cannot really get to the engine very easily. Some you can remove some of the covers to get some access, but a mechanic would go from the bottom to actually perform maintenance on that car. So here we're starting to see a pattern where in cars, it's actually getting harder to monitor what's happening there. Even though if you ask the manufacturer, maybe there is something that they can observe. Here, I almost forgot, this is another example. If you get an electric car, you can see even less. Like this car has a frunk and a trunk, but the engine system is so different that it assumes that a normal user cannot get the information. They're just supposed to maybe add a bit of liquid somewhere. So it's not a good solution unless you have one of these. So yes, you can get observability if you connect a device that will give you access to the monitors. Then I start asking, which one's better? So here we have two systems. This here is an alert that is waiting for the right time to happen. Here, no one's observing this until the alert happens, but there's a physical alert that will draw everyone's attention. While this one here requires wires to be able to identify more points of failure. So yes, there is monitoring on this one, but I would argue that the observability on this one may be better. Matter of opinion. So I'm thinking about a thought experiment here. Start thinking, if you don't have that device that will give you information about the car, you cannot go there. Maybe you can't even open the hood. Just trying to see if it was a black box, something that you are just trying to extract information from the system. You have to talk to the mechanic and explain, oh, when I accelerate, this happens. And you know how good users are explaining what's going on, right? There's a lot of biases. Maybe they don't understand. Maybe they lie on purpose. Maybe they lie by mistake. But the information doesn't get across. And you can get some weird situations or try to figure out, but you can't really have all the information that you need. Imagine if you went to a mechanic, he got a bit of the oil and said, I'm going to send it to a lab, and in 2 weeks you have the result to see what's wrong with your car. So that wouldn't be good. There are different ways that you have to think about certain systems. Even worse, like when you get to this here, Europeans here look at this and might say, these ratings are wrong, that's too low for my car. Sometimes even it's hard to get the message across of what has to be changed. And some people don't even believe when they say, your car needs 91. You're going to suffer if it's not that. Now, I was hiding a bit of the goal. Does anyone have an idea where I'm trying to get at? No? No hints? So there's a device that I believe is the equivalent of the OBD device for the topic that I'm really aiming to talk about. Here, the tricorder, or more specifically, the medical tricorder. Maybe in science fiction, we had the system that could point and say, hey, this is what I've diagnosed that has to be fixed with this person. But we have very little of that. Most of you probably don't even know about continuous glucose monitor. So that's something that you can monitor your body and know how food is affecting glucose in your body. Is that done? Okay, so maybe you can get the link afterwards, more devices, and maybe get correlations. I've been trying to figure out how we can get better information and observe our own bodies. It's very important to do that as well. And we shouldn't forget about getting the information that our body is telling us. And we are not very good at knowing, the same way that I was saying that the users can tell what's going on, we may not be good at saying what's wrong with us and identify what our body is telling us. So if anyone wants to see the presentation, leave comments there or reach me afterwards. Happy to talk about it. Thank you.
Thank you. Brian, and then Bartek.
Hello, I'm sharing with Cryo.
Hi there. We are going to talk about Prometheus bug scrub.
We got the... Oh, that's not it. Hang on. I've done that talk.
Yeah, you have that.
Yeah.
You could do the intro.
Yes. So, if you see the Prometheus GitHub repo, you might notice that there's a few number of pull requests and issues there. And you might wonder if you open up a PR or an issue and you don't get answer in 1 week, 2 weeks, 1 month, and suddenly somebody writes, hello from the bug scrub. What does that mean? Why didn't you get an answer, and who is this bug scrub person? And we are going to talk about what it means and how it works in reality.
Yeah.
Okay, yeah, so thanks. I thought I'd ask, who's submitted either an issue or a PR to Prometheus? About a third of the audience. Okay, and keep your hand up if you had a really quick response. 5. So the bug scrub is trying to help in that situation because I wanted to put this screen up. We have, so as of right now, 221 open pull requests, 522 open issues. And just looking at Prometheus, you know, the central server. Once a week, some of the maintainers or people in general get together on a call, and so the call is listed. This is in Prometheus.io docs. If you go down to the calendar down here. And then open up the calendar. It's on a Tuesday, the Prometheus bug scrub. I could scale that bigger, but it's on a Tuesday. So Cryo's going to tell us what we do.
Yes. So first of all, we sit in silence because we are waiting for everybody to join. But yeah, jokes aside. So we get a couple of people there. Obviously, it doesn't work if it's just one person. But if there's a couple of people there, then somebody volunteers to lead the call. They will share their screen, and we will go through, from the last time we left off, we will go through issues and pull requests. Usually, if it's just 2 or 3 of us, then it's either issues or pull requests for the whole meeting. And then if there's 4 or more, then we can split, and we can do pull requests and issues. And we go one by one, and we open the issue, look at what it is about, what are the latest developments. If
it seems to be alive and people are talking with each other, then we don't have much things to do. But if the issue has, or the PR had like the last response was a year ago, or there was no response, then we try to decide and triage, basically, and do something. And usually this ends up with a comment written by the lead who's sharing the screen that says, hello from the Boxtrub, and either we ping some people with GitHub mention to take a look, or we advise on how to move forward, or in some cases we actually approve and merge the PR if it's in the right state. So we try to do something, and that's when you get this help from Boxtrub. And when you get that, you can know that it's more than one person that has looked at this. So this is a consensus. Somebody writes a message, and then we kind of say, yeah, we agree that this should be done. And in some cases, this might mean also that we bring the issue to Dev Summit, which is where a wider audience of maintainers will discuss it, if it's the size of the problem is bigger. You want?
Yeah. Okay. Well, I just we're probably running low on time. It's a call for help, really. Usually, there's about 3 or 4 people show up, so we might get one group to run through for 1 hour. We don't get very far, or we might get, if there's 4 of us, we split into 2. We go twice as fast. So if just a couple more people showed up, we could split into 3 and go even faster. You don't have to have a great deal of experience. You don't have to be a maintainer. As long as you're willing to, because it's kind of a human process, right? That we're just trying to see what's happening with this issue. Did anyone say anything about it? Are we waiting for someone? Was the whole thing misunderstood? So yeah, please consider joining us. If it's not a great time zone for you, let us know. We could do a different time. But the situation right now is we have very, very few people show up. It's basically me, Cryo, and Bjorn, and Ayub is pretty faithful. So yeah, that's it. That's the talk, I think. You got anything else? No? Okay, thank you.
Thank you. Bartek, and then next up, Jorge.
Okay, let's see if it works. Yeah, actually it works. Yeah, I want to talk about trams and how they can help us to really show the problem we are facing in collection. So, hello everyone again. Let's talk about collection resiliency. Yeah, we have some kind of feature which would be nice to have, but it's kind of blocked on some kind of dilemma. And it's really similar, or maybe you recognize this, tram trolley dilemma, and that's how it's called officially. It's kind of like a cool experiment, thought experiment about ethical problems, ethical questions. So what would happen if you would be in a situation where tram is incoming and, some people might be hurt, and you have sort of control to reduce that that kind of situation to maybe that less people are hurt, but still they are hurt, and it's really like very difficult to figure out who are you then responsible. Should you do this or not? And it's not very easy to answer. And I think we sort of have this problem right now with collection resiliency. Take it with a grain of salt, of course. We are not killing people, hopefully. We are killing metrics or servers, but it's, maybe metric is so important that it actually causes planes to go down, then it's kind of important. So how to really map this out? If you imagine the tram is incoming data, it's, for example, when we are scraping the data, and you are, and the Prometheus, and the code we are developing, and configuration we are putting into Prometheus server to decide things, is this guy on the lever, and you know that Prometheus you are this Prometheus process and you know you are close to memory limit, you sort of have two choices here if you see a very expensive data incoming and you are super close to memory limit, you see data like this, which have like very high cardinality like dimension in it, you know things will go wrong. So Tram is going definitely in the direction of crash loop, right? Your server will be down, your collection will be down, your likely querying will be down as well. So you have a choice. You can kind of maybe stop this scrape job. You could stop, maybe you can ignore this metric, this one metric, maybe it will be better than killing the whole server. And it's actually not only Prometheus, it's also OpenTelemetry collector, any collector decision when we are pulling metrics. This is like difficult decision to make because it's not easy to really tell what metric to kill, who should make this decision, because there is no good solution what happens when you kill those series. You don't know if it's important or not. And I want to show what kind of OTL is doing. And OTL, of course, have this. It actually kills random, let's say, pushes. On the push side, it's a little bit more easier because when you push, you kind of expect, or you are receiving pushes, you are kind of expecting that people kind of retry. So sort of maybe you can slow down for a second and clients can retry, but eventually they will kind of collapse because the client cannot buffer unlimitedly. It has to kind of collapse. So essentially, this push receiver memory limit is kind of pushing the problem somewhere else, right? Okay, it's not my problem. Actually, yeah, you do it. I just cannot commit to this. Find another collector. So that's kind of like a benefit and downside of the push. So they don't need to make this decision, right? They're not killing anybody. It's like client kind of like have to deal with stuff. But we have a problem, and essentially, I just want to clarify this problem and kind of make any progress towards solution. And we need your feedback as a user. What would you like to do, right? We have a bunch of things we could do. We could kind of maybe have some flashing early, like garbage collection, kind of early compaction to just, like reduce the memory for some sacrifice of like, I don't know, like a block size in the storage. Maybe we could actually slow down scrapes. So kind of like maybe, okay, you want every second metric, every 10-second metric interval, maybe make it 1 minute for a bit. I mean, maybe your monitoring should be fine, right? But then actually samples is not the main memory usage factor or contributor. Actually, it's new series, so cardinality. So maybe you don't add more series, or maybe for certain series. But then there are so many questions, and all of those, there's no perfect solution. But my point is like, let's iterate, let's have something dump, naive, and iterate over it. Let's make sure we get your feedback, if it's useful, if you know what to kill. In my opinion, we should have it, because I think we should kind of kill one metric, then the whole server, and I think we should have something, in my opinion, behind optional kind of flag. And I think in the future, we are talking about telemetry health. So every metric would be, we are talking about schema, it would have additional information about criticality of this metric. Hey, these pieces of metrics are critical because it's auto-scaling, because it is, super important alerting metric, don't kill it, right? But there are some experimental metrics, yeah, you can kill, like my collection will survive. So you could do it based on, yeah, thank you.
Thank you. So we have Jorge, and then we have the other.
Hi everyone, I'm Jorge, and I mentioned in a previous talk that we introduced a new anomaly detection robust strategy. So I just wanted to talk a little bit about this. Remember, the idea is that we want to, display some bands around your metric and detect when you're off. So let's look at how it works. So first of all, we need to calculate the median, which is going to be the middle point for your bands. And we can do this by looking, at a time window of 1 day, and taking the median. And we choose the median here because it's a robust function, right? So it will be less affected by outliers. So once we do that, we draw this line. This is the middle line for our bands. The next step is to calculate the median absolute deviation, also called MAT here. And a way to approximate that is to do the absolute distance between the metric and the median. So you see the metric at the top, and you can see the yellow one is well, 1 second, sorry. So first you do the average, the absolute value of the distance between your metric and the median, and then you calculate the median of that. And that gives you an approximation of the MAT, but I just learned that there is an experimental function that is MAT over time, so I guess we will be able to use that soon. And that will give you a measure of the persistence, and again, it's over 1 day. And once you have these two things together, you just basically do the median, so the middle line, and you add the MAT that you calculated times constant. In this case, I just chose 2, and you can draw these boundaries that you see on top of, above and below. So that's not all, and that's something that it changed from the previous algorithm, is that now we have a concept of level, and a level is basically, again, the median one more time, but this time is only over 1 hour, and that means basically that, I'll show you how this helps, but basically, this is basically smoothing your metric. It's not just like, we're not looking just at the metric and how it falls outside of the bands, but actually we're looking at this specific level, so the smooth version of your metric, so that we have more robustness there. And this is how it behaves. So I ran this overnight yesterday, and I basically have a request rate that is more or less fixed, and I simulated a short spike and a more sustained spike. And as you can see, the first spike actually didn't trigger any anomaly. You can see because the level, right, the dotted line, didn't really move at all. And that's because the way the median works, we're looking back 1 hour, and it's the 50th percentile, so you actually need 30 minutes of a sustained change so that this will even be affected. So nothing happened, nothing was fired. We just ignored this spike completely. In the second spike, it was more sustained, and it was actually long enough that it actually pushed the level outside of the bands, and in that case, we actually fired an anomaly. And you can see it's a bit going behind of your metric, so it's a bit delayed compared to your metric, and it also fires for longer, right, until it goes down again. So let's compare with the algorithm that I presented last year, which has been renamed to adaptive. So in the first algorithm, the one on top, you see that the short spike actually immediately, we don't smooth the middle line, the level. So it immediately went outside of the bands and triggered an anomaly. But also the bands adapted really quickly and became really wide. So you can see that the second spike actually wasn't detected as an anomaly. And that's undesirable for some people because this algorithm has been biased to reduce false positives. But as you could see, you could miss some spikes. If you want to have something more sensitive, this is really maybe not for you because it's been biased to reduce that. The second algorithm, as you can see, the short spikes, it doesn't even care about them. The second one is delayed, so it fired way after the first one. And then it just, as I mentioned, was sustained, delayed but sustained after a while. And I think this could be better for some types of metrics. It really depends on the type of metric that you have. Yeah, I think that's all I had. Thank you.
Thank you. So we have the other Julius now, and then Ivona.
Hi, I'm Julius, and I'm trying to tell you how instant vectors are and scalars are and how that bit me. I was looking at some graph, and there's some anomaly down there, and then I tried to zoom in, and then there was no data, and I thought like, what the heck? How's that possible? And yeah, you have to keep in mind we're using Victoria metrics for this, so it might behave differently with Prometheus. Yeah, what's happening? What's the graph? We're trying to assess whether a target is available with a black box exporter, and we're trying to do that from different locations and only alert if a threshold of them agrees that things are down. So we don't have to wake up when things aren't in order, but yeah, only for some things. Yeah, and then I turned the things around, like I just switched things, and then it worked. And I was wondering why. Yeah, then it worked. And this is kind of how the data looks. So importantly, the exporter location counter doesn't have any labels that might become important later. Yeah, and there you can see the query again. Yeah, Victoriametrics tries to be smart here, and it does a right-hand side label pushdown. So it uses the labels that we have, like for our example data, we have two host names, in this case A and B, and Victoriametrics recognizes that it's on the left side of the query of the binary operator, and then it does a label pushdown, so it takes this thing and applies it to the count exporter location too. But that doesn't work because it doesn't have any labels. Yeah, and if you turn it around, it works for some reason. Yeah, and why did it work unless I zoomed in? That's because there's an optimization that only applies if you have less than 100 unique values. So when you zoom in, you have less values, and then you don't get any data back. Yeah, I was using a metric or an instant vector as a scalar. And yeah, that shouldn't have happened. Then I can add a scalar function, and then it works. But what I should have done is add some label so I can add things later if we want to have a parallel setup for something else. But now my question is, why did it ever work? Is this something of Victoriametrics? Is it that there's a, I don't know, if you don't have any labels, it's supposed to match everything? What is it?
1, 2, 3. Yeah, it was me who implemented this smart behavior. Yeah, I didn't remember actually the actual reason why Victoriametrics automatically converts the real metric into scalar. It was implemented in the first days of Victoriametrics, so probably that's a bug which must be fixed.
Yeah, like at Prometheus, none of these two would ever have returned anything.
Okay.
Or no labels matching.
Yeah, good to know. Yeah, I just took a look at the binary operators where it's documented, but yeah, apparently it works as it should with Prometheus. And there's the issue I opened with Victoriametrics late last year. It has been handled and it's been closed because I didn't care too much about it at the time. Yeah, if you want to get in touch with me, that's my GitHub. Thank you very much.
Thank you. So we have Ivona, and then we have two more after this. We have Arve and Theo.
Okay. Hi, everybody. So this is really going to be a lightning talk because we just came up with it during lunch and we don't have a presentation, so just use our imagination. We got a few notes on our phones and papers, and let's try to make this. So like, we would like to talk about how we validate this user-initiated config changes in Prometheus repositories. We are a part of platform observability team who, among else, maintains our monitoring infrastructure. And as most of these teams, we don't write alerting rules. We provide the infra and the best practices so people can do it themselves. And since the beginning, we wanted to have this source to sort of like control mechanisms where we can validate both these configuration changes and alerting rules, and promote these best practices. The way we do it, the way we do it, we have this, let's say, single large Git repository, like almost everybody does. Users, when they want to create either new script targets or something like that, or alerting rules, they open up a pull request. And how did these controls that we want to implement look in the past? So we did it by hand. We went to every pull request and had this list of checks that a real operator had to check. And you can see the problem with this. It's cumbersome and it's prone to. So the quality of these validations actually depend on the engineering expertise of the engineer who does this. And how did we try to solve it? So how we do it now?
We automated it, of course. We made a cute little project. We call it PR Checker, and we integrated all our logic. So this document that an engineer had to go through manually, we integrated it in the code. Of course, we use Go because we need the Prometheus parser. We have the same like the other Lightning Talk. We have some special labels we want to enforce, but also we cannot use all PromQL features, so we kind of cut them off. The output of this PR checker is not only the build fail, it's also a comment on the pull request. So if it's just a warning, something we can live with, then the build doesn't fail. But if it's something that we don't want in our system, then you get an error comment and you also get the build fail. So this is triggered on every pull request and pull request change. So what do we check? We check for targets connectivity. We check number of metrics. We do alert definition checks. So some alerts are potentially problematic. We go through the expressions and then we write what exactly is wrong with this alert. And we had a really good feedback with this because people feel like it's a person who's telling them, okay, your alert is not that good, please fix it. So they do fix it. And we are very happy with this. And we like the extensionability of this. So if we need to add a new check, we can always do that in our project.
Yeah, thanks. So like, what did we get from all of this? Of course, less work for our team. Because the company grows, more teams are onboarded and a lot more pull requests are arriving day by day until now. But like the main point I want to drive here is that we found that this is kind of the best sweet spot for promoting these best practices and good ways of doing things onto our users. We try to have good documentation, but users usually don't read the documentation a priori. And as Ivona said, when they get a comment on a pull request that actually states what's the problem, provides a link to the documentation, then this is an entry point for the users to actually see what else are we promoting. So yeah, we kind of leverage this manual work to like sneak in these points we want to drive to our users. And it turned out really good. It turned out really good. So if you have these kind of problems, maybe this is sort of a proactive way to reach out to your users to actually have them start doing things the right way. Thanks.
Thank you. All right, Arve. And then we have Theo as the last one. Oh, there's one more even? Okay. But that's yours, right? Yeah, okay. Don't count that as a... Okay. Ah, right. I get it. Yeah.
how many of you use OpenTelemetry? Sorry.
Yeah. How many of you use OpenTelemetry? Show of hands, please. How many of you? How many of you choose to promote resource attributes to metric labels? And can I ask how many of you prefer getting resource attributes via the target info metric? No one. Oh, I see one person over there. Do you then write join queries? I mean, how do you use target info in practice?
Thanks. Yeah, I was saying that my answer was completely theoretical, not really. I embrace the fact that to me resource attributes should go to the target info, but I'm actually not using it a lot.
Oh, I see. So the rest of you who promote resource attributes, do you then actively prefer it to use it to target info? So I'm kind of like bringing up again something we talked about during last PromCon, which is the info function as like an easy way to get resource attributes out of the target info metric, because during today's UX research session, it kind of became clear that it's a major pain point for a lot of OTel users to write join queries. So I kind of wanted to take the occasion, I guess, to pitch the info PromQL function instead of writing join queries. How many of you are familiar with the technique of joining with target info in queries? Okay, I see a lot of hands. How many of you are familiar with the info function as an alternative? Okay, I see a few here. So basically, target info was introduced as an experimental PromQL function in early 25, as I recall it. So what we see here is like a traditional join query, which is quite hairy. And on the other hand, we see the alternative info function query. So you can see it's much easier to see what's going on, and should be much easier to compose. So basically, the simplification with the info function is that it assumes by default that you want to join with the target info metric, and not just any old metric. So it also makes the assumption that you're going to be joining on the job and instance labels. So this is an assumption which is designed specifically for OpenTelemetry resource attributes. So that makes it very limited in comparison to join queries, but it also makes things it is also far easier to use. So basically, what we see in this query is that the basic query is augmented by adding the K8s cluster name label from target info to the resulting time series. It's like a very simple way to
to include resource attributes, corresponding labels, really. And yeah, I guess that's it. That's my point.
All right, thank you. And we have Theo, and then we can decide what to do about Richie, who has not signed up as a lightning talk. Huh? He's there now. Okay, okay, fair. Okay.
All right, can you hear me? Yeah, this one is ready. All right. Can you hear me? Yeah, good. All right. So I just came up with this talk during lunch, so just a few slides. But wanted to share some experience around Alert Manager and silences. So I'm Theo Brigitte. I work as a platform engineer, whatever this means. I'm also French, sorry for my English. And I work at GiantsForm. I'm part of the observability team there. So let's see how we provision silences into our alert manager. So quickly, what we do at GiantsForm, we provide a fully managed Kubernetes. And the thing is that we run a monitoring stack isolated into each our cluster with HA alert manager. And the problem there is that our engineers are on call 27, right? They're responsible for the infrastructure. And we, as the observability team, we're also monitoring the monitoring stack because, yeah, you need that. And the problems come on when, like, you need to, because we use the same set of alert in all our clusters, whenever things go wrong because you deploy the wrong version or God knows what can happen, you need to silence this alert across all the clusters. That's just not feasible manually. And we also had problem because user would just create a silence in the alert manager UI and just not give any info about what was the related incident, or they would just set the expiry date to year 4000 because they just wanted to silence the thing, right? So how do we solve this problem? So then we decided to store our silences in Git because, as Hervé mentioned before, we are heavily GitOps based. So we store our Prometheus rule in Git, and we also decided to store our silences in Git. But the problem came up as there is no way to define a silence. Like, how does a silence look like? And because we're part of the Kubernetes ecosystem, we decided to write this silence operator and define what a silence is in terms of a custom resource definition, which is basically a YAML file, right? And thanks to that, we can have all kind of CI validation on top of that. Like, we can validate the expiry date. We can make sure people add some relevant information about what the silence is about, who created it, and so on. So this is fairly simple operator. Like, if you're familiar with the Kubernetes ecosystem, it's like use a set of Kubernetes label to select which CR you want to reconcile and which namespace you're taking them from. And then the operator just use the Alert Manager Go client and sync those silences with Alert Manager. Also does the expiration logic. It's not there in the spec, but we use it as an annotation for now. Maybe we move it into the spec in a later iteration. But yeah, basically your silence, whenever it's synced to the cluster, it gets synced to Alert Manager, and when the expiry date is over, then it's removed from Alert Manager. And you have the set of matcher, exactly what you have in the Alert Manager API. Yeah, and on top of that, we also used to run Prometheus. Now we moved to Mimir for scalability reasons. And this operator also does support tenancy from Mimir. So yeah, it's out there. Feel free to use it and give us feedback if you do.
That's the wrong one.
You just told me about a picture where I look stupid.
That was the wrong one. But I have a whole talk track about motivating people to do stuff and to appeal to their own selfish self-motivation. And someone chose to make this image of me as a direct result of my actions. For who is this the first PromCon? Okay, nice. There's a tradition. So with my Grafana hat on, not my Prometheus hat on, we obviously have some data about data sources being used and everything. And while this is a very closely guarded commercial secret for potentially obvious reasons, we have one single exception to us not talking about those numbers, and this is Prometheus. Of course, we really like Prometheus. I mean, I'm biased, but also kind of obvious again. So once per year, we basically show the current adoption stats of Prometheus. And as is tradition, this is the last lightning talk on the last day. So these are the numbers of the last few years, basically when we had, this year is missing, whatever, numbers go up, it's good. The last time I stood, not here, but talked about this, I actually had a little bit of a word of warning of us seeing a slowdown in the adoption trajectory. If you were able to look at the graph, which you're not, it actually stabilized. So it flattened out a little, but it's linear again. So maybe a little bit of a curve, but not a super bad problem. But still, I also want to take this as an opportunity to shout out to people to try and get more life into Prometheus, because there is a reason why it's the most adopted thing in all of Cloud Native and beyond. Without much further ado, this is great. We are at 1.4. I hope Björn approves of the plural form of Prometheus here. Yeah, and that's it already. And that's it. Taking on a different hat just for a second. I deliberately did not come in here all day. I don't know if you noticed. And there was not a single escalation which required me in the room. We solved everything through here. And one of the people who made a lot of this work is now going to give the closing talk after I kind of forced him to.
Almost there. Let's see. Entire screen, start mirroring, slideshow. Okay. All right. What? Okay, that's fine. Yeah. Well, thank you, everyone. I hope you had fun. Did you have fun? Okay, great. Like this venue is like, again, very nostalgic for me because, you know, I was a baby like 8 years ago. And then I gave my first conference talk at this venue when I was still a student. So yeah, so that was like, again, I'm happy that we are back in Munich. And I'm happy that I'm helping kind of organize this conference where I started my journey. I mean, I wasn't even a full-time developer back then, but yeah. So yeah, I'm actually quite happy that we have PromCon in Munich, and I'm happy that everything went well. Well, unfortunately, it is over. I'm kind of sad, but also very relieved that it's over. Yeah, but everything went pretty smoothly. I think so. But yeah. And this is basically possible all thanks to our sponsors. You can see a bunch of them. I had to make this at 4 a.m. on Friday because I forgot to print banners and I forgot to put Google on it. But Google has been an amazing sponsor. So please give a round of applause to all our sponsors. And also, this has been possible because of all the speakers. So if you have spoken, please give yourself a round of applause. And everyone, please join me in congratulating the speakers. And yeah, if you are a speaker, feel free to join us on stage if you have spoken today. Yeah, okay. Yeah, come on. Yeah, it's okay. And yes, it is compulsory for you, Brian. Yeah.
One quick interception. We forgot to hand out the knives today. So all the speakers who spoke today, please find us and pick up your
Knives, yeah.
speaker gifts. We're sorry.
I mean,
so not everything went smooth, but you weren't in
not
the group for
lightning
this.
talks. Lightning talks, we don't have enough knives for it. It's kind of funny. We've done bowls, we've done spoons, we've done cups, we've done knives now. So next year, you know, we're going to do forks. Yeah. And then chopsticks later. Yeah. All right. Also, thank you to all the MCs. So if you've been an MC here, please come on stage. Yeah. And also, if you're a Prometheus team member, a maintainer, yeah, like feel free to come on stage. I think most of them are also speakers, so they're here already. Yeah. Yeah, Matthias and Ben, yeah, and Basti, okay. They're two.
Pay attention.
But no, yeah, again, please let's give a round of applause to everyone. MR, why are you sitting there? And yeah, thanks again to you folks who made this happen with all your questions, all your discussions. And yeah, thank you for making it a great PromCon. Like every time I ask questions, like, is it good? Like everyone really enjoyed it. They loved the vibe. Even the speakers felt like very comfortable because they think you're all very chill and cool. So I'm like, yeah, thank you for making this a great conference. Yeah. Yeah. Yes, don't forget to be excellent to each other. It's over. Also be excellent to the Prometheus community. Please open PRs. Please be patient while we sort through them 6 months later. Yeah, and please, yeah, help us make it a better project. Please contribute PRs. You can use AI to make these PRs, but make sure you test it first. And yeah, like, please join the bug scrub, join the community, join the alert manager community. Just yeah, be excellent to each other. And yeah, thank you for being a great community. And I think that's it. While you leave, if you see like cups and trash and stuff, please like pick them up while you leave. That would be super helpful. And we want to come back to Google again. And I mean, I love the lunch here. It's the best thing. I've never been to a conference where the lunch was this good. So yeah, I want to come back here again. So yeah, let's be a nice, good participants. And yeah, that's it. Thank you again. You can hang out for like 15 minutes, but after that, we'll have to kick you out. Yeah. Yeah, thank you.
I want to formally congratulate
I'm sweating.
Congrats.
Good.